Yeah, 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 yeah. Yeah, yeah, yeah. 1, 2, yeah, yeah, yeah. 1, 2, yeah, yeah, yeah. 1, 2, yeah. Yeah, yeah, yeah. 1, 2, 1, 2. Eh,
Good morning, everyone. Welcome back to the third day of sessions. So today we have a presentation from the Health Librarians, and Dan will introduce the speaker for us. Thank you.
Hi, I'm Dan Garandese. I'm the Chief of International Programs at the National Library of Medicine. I'm here to introduce Richard Sonono from the Infectious Disease Institute at Makerere University. Richard and I go back a long way, worked together for years. Member of NAML, which is a network of African medical librarians. They are NLM's ambassadors to Africa, help us implement all of our programs. And I was hoping there would be more NAML people here. Are there any? Stand up if you're here. About 10 of them. The reason they're here is to run a workshop with about 24 junior librarians, train them to support you at your institutions. So let me just introduce Richard now, and why don't you come on up and speak.
Thank you so much, Dan. Okay. Thank you so much. Good morning, ladies and gentlemen. Richard Sonono, as Dan noted, and I'm going to take you through some of the things which are either been hidden or things that we can work together as information professionals and see how best can we really move on this journey of data science. As you may understand, we have been moving this in a loneliness kind of approach, but we realize that we have skill sets across other disciplines, including information science. So we thought moving together as researchers in this journey, it will we shall make a big milestone out of our initiative. So I'll be sharing with you some few one or two things that libraries or librarians, specifically those who work in the health sector, are able to offer to researchers in line of data science and informatics and these other disciplines. Just to introduce, you may wonder when Dan was introducing me, I work with IDI, infectious diseases, but at the same time, my background was library science, my first degree before crossing over to IT and informatics. So you see that it's multidisciplinary where it comes now to data science. So we thought that we have so much of my kind that can easily work with you on different projects that you have. Okay. Yeah, I have a full hour and we shall be looking at some of the few aspects, as you may see. Of course, I'll try to introduce this entire concept of libraries and data science, or librarians and data science. I'll give a few definitions to get the context right, and also try to talk about some bit of perspective, meaning that I'll try to see the overlapping or overarching aspects of data science and information science. These are twins in a way, but unless someone is told, at time you may understand this by looking at it from the surface. And also I'll try to look at what I would have called redefine the role of librarians in support of data science initiatives, especially with DSI Africa and the different approaches we've been having or movements on the continent. I shall conclude by looking at some way forward and conclusions, but also same time shall get a chance to interact and see more areas of collaboration within this endeavor. Well, to just introduce this, you really appreciate that libraries or librarians have been here for some good time, quite some good time. I think before 16th century and all that, we've had so many people looking at libraries, and for long we've been kind of in charge of the safeguards of knowledge. And in this way, libraries stand to benefit by adding data science efforts onto the list of their offerings or their services. the orphan libraries. You would appreciate why as we continue going through this presentation. But such a grounded profession can easily nurture the younger profession that is close to what they do. So that kind of synergy is what we're going to see as we progress. And of course, you've all know, those who are not coming on this continent, that when you go to Western continent and also looking at developed economies, you find that those economies have developed professions like data librarians, specifically guys who are in charge of data or this research data, and they have been working on this for decades. Of course, before all this movement of data science, we had things like microfilm or microfiche. We had those guys who were in charge of management of census data on the flop and all that. But now, with the new approach, we are just getting this now to computing and to AI and machine learning. So, but the entire concept and all that has a history that all these kind of data sets were already managed in those forms. So you find that these guys have a rich history of data management. So if we work with them, we can even go now back and do retrospective kind of analysis on the different sets of data that housed in the different libraries. So it becomes critical and important that as we go through this journey, we get now these rebranded data science librarians part of our endeavors in all the different projects and grants we have on the continent and also outside the continent. So I try always as I teach this kind of concept to look at how one of the grounded scientists, and I quote him, that the ability to take data, to understand it, process it, and get value out of it, visualizing it and communicating it, surely that's the next skill of the new generation. So the skill that is going to be so much important for the next 2 decades is that important skill of you processing, analyzing, visualizing, and understanding data. So if we work and move with this multidisciplinary approach that I'm going to teach you today, we shall make sure that at least we're developing a new generation that appreciates data as a key goal now in Africa. So that's the kind of essence in this talk. But also such skills, when they're developed, they are not only for data scientists, but they could be skill sets that you can develop in this general workforce. The moment we develop a workforce, including librarians that appreciate data science and the ability to utilize data to make informed policy and recommendations, it will help us go a long way in terms of policy formulation. So that's the essence of trying to put together this multidisciplinary kind of approach and get so many people who understand data and data science, and we move together with them. And I think that's the essence of this quote, and very important in these endeavors of data science that brought us here today. Now, being a person who comes from the African continent, I always look at Victoria Odoy, who noted that if you want to go fast, go alone. But if you want to go far, go together. That proverb is very, very important in the context of data science. How about if we change our mindset now and we try to see that, yes, we've been pulling on statisticians, we put on mathematicians, computer science, engineering, but now, how about if we add information guys that bring their expertise in information processing, we marry it with our data mining skills, and we move that mile. So exactly, this is the idea I have today. So my talk is more of an awareness talk, awakening you that there is much at our disposal if we use it appropriately. All together? So that's exactly what we are here. So let's move together and we shall see that we move miles. Okay, just to bring things to context, I try to look at data science in terms of perspective as extracting meaning from the massive amounts of data we generate every day. Right now, as I speak right now, my sound is being recorded. At some point, this talk may be a talk that can inform a decision somewhere. So exactly, the things we do every day, the data we collect every day, and all these massive amounts that are all over the globe and all that, data science is grounded around those that kind of aspect. And I think majority of you who are here, you really appreciate the 5 V's. I think now they have moved to 5 V's. They are now to what? How many V's now do you have? I think for me, I call them the 6 V's. I had the 6 V when I came here because the idea is that whatever we do, as long as we are not able to synthesize this information and have it presentable in a manner that is understandable, it wouldn't make sense again to us. So to remain data, and we shall not have package it to become information. So I added the visualization as a great component of this endeavor, visualizing this kind of data in a graphical form and also in a form that is clearly understood by any layman. So visualization becomes key to data science. So that's my 6V. So we no longer have velocity, volume, value, velocity, or and variety. Now we also need to have what? Visualization as key, or which become now number 6. But all this is about automating this extraction. Data science is almost about automating what? The extraction, the process. Instead of doing all this kind of thing manually, can we use a computer? Can we use different programming languages to pull together this and present the information? So that's how I perceive data science. And you see how I link it to information science as we continue to look at these perspectives. So ideally, data exploration, of course, and the data science and all that depends on fundamentally ability to capture. Ability to capture, curate, and also analyze the different data streams. Now, I was so keen when I looked at something called curation here. Now, to curate our data sets and all that is very key. And this is the skill set that these libraries or librarians have been having for decades. Just imagine now if we work with them and they're able to preserve these data sets for decades. That means the young science, the young science who are coming up and all that 4 or 5 years from now, 20 years from now, will be able to again revisit these data sets and even make more prognosis, more predictions, out of this kind of data sets. So if they are preserved well, using now their principles of the traditional library information processing approach, So that's exactly why I'm trying to marry the two. Now, as we appreciate, information science is not anything new. It's not a new discipline, and it looks at the genesis, flow, use, and preservation of information. Now, this data, those sets of data that we have, at the end of the day, we want those data sets to get informed policy out of them, evidence-based. So if they are not preserved, if they are not used, there's no way we shall generate the impact of data science on the continent. So these guys who are doing all this kind of work are people that we have to move with. Those are the librarians in the sense of information science. They will be able to preserve for us. They'll be able to help us use and be able to help us understand how to make the data easily accessible and also well packaged for the future. Now, of course, we can't leave our sisters, the computer scientists. The fact that data science is multidisciplinary, we need to see that the algorithm and all that, the techniques for computing process and all that are well organized. We have a standard we're going to use to really try to navigate the different big data sets that we have in our institution. So they are very key on this. And I believe most of you, we have here, I think, some programmers in the house, right? We have programmers here. I know data scientists have all qualified to be programmers, but so that's why I'm telling you that we need to really to see that this is multidisciplinary. Yes, they're all programmers now. You're no longer called a statistician because they are also doing the modeling. The librarians are also saying, I'll help you do the metadata and curate. So we all now a mix of everything. So that's why I want to see that we move with that energy and take this to the next level. Okay. And I'm also happy that we've even now crossed over to medicine. I'm seeing Professor Vice Chancellor Mbarara here. So you can see we've even gone to that level that even now, even those who are completely into other disciplines have known that the use of AI and the use of these technologies can even improve now diagnostics. So you see, So it's multidisciplinary, and that's why we don't want to leave our sisters behind that have had these kind of things for years. And those are the information scientists. Now, still on perspective, need to manage my time. When I get a mic to speak, I can speak for the full day. So when you look still at perspective, you appreciate that if you look at this flowchart diagram, you appreciate that the data science foundations lie so much. If you look at this upper end, information science and also computer science, stat and all that. So all these are disciplines that bring together their expertise to see that data science thrive. You understand? So information science in terms of metadata creation, ethics, we've been grappling with ethics here. We've been grappling with preservation. We've been grappling with things to do with our context and content and culture, how how data science marry all these concepts and all that. You can see that these guys are with us. So we need to move together. They have the social part of data science, and they can easily help us really move together. So they may not do so much of modeling and evaluations and differentials modeling or inferences, but they can help us to do that. Let's say they help our data sets well organized, and we are able to easily make meaning out of those data sets. So we need to see that we move with this knowledge domain together in our efforts as data scientists. Of course, this is to note that still on perspective, we are relatively new in the field, but again, we are now riding on those who have our fathers, those who have been there for some good time. And we get skills from all these disciplines. You can see information science is not left anywhere, but rather we need to move with them. I did a simple search before this talk to just appreciate and give a context to my talk. And I realized that when you look at Web of Science, I think I tried to search a topic data science to just appreciate what is there, how to. And you could see that almost 2,000 papers are being written on the topic data science from 1980 to 2009. But again, when I looked at all this, the biggest community that has been contributed to the discipline has been computer science research community. I think for known reasons that want to see that our methodologies and all that are applied in this area. But again, on the same, I tried to search about information science and their contribution. It was quite small, around 3.4%. So this energized me to really wake up and come talk to you that, look, these guys are trying to add knowledge to us, but because maybe we've not given visibility, that's why their contribution has been limited to this extent. But you could see that at least there's much that is coming, or there's something that is coming out of them in terms of data science. So the more we give them chance to work with us, the more we shall see that we move together. Now, when we look at some of the issues to do with the defined laws, or what I call my defined laws, what would these guys bring on board? What are librarians or data scientists, data science librarians bring on board? I just wanted to note that I have a few slides looking at this, but when I tried to do some bit of mapping around skill sets and all that, I realized that there are things they can do that we don't know or we can't do as scientists, and we need to move with them. And you could see that all these taxonomies and all that are things that they are able to work on, metadataing our schemas and all that. So they are very important. But to start with, now, the data science librarians of late, okay, a little bit can handle programming. Those who have a bit closed, but having foundation as library science, now they marry the library science foundation into programming, and they're able to program well, very much. And I think at back home, I think in one of the lots that we have currently for PhDs and all that, we have more than 3-4 information scientists now doing informatics and big data analysis, pure data science and programming with all these languages, Python, R, and that means that yes, now they are even now jumping into to program. You see, there's no way we can leave out such people. And of course, with the help of statistics and visualizations and all that, they they have been doing, or they are now designing their different dashboards in Power BI, and all these aspects of tools, reporting tools, using to try to see that they can also make informed decisions out of the library data they get. So that means that they are able to work with data sets, and that's a great incentive to see that we move with them. Of course, there is an aspect of now, in terms of redefined role, there's something called meta research of data science that is very much something that is important. So librarians are now taking such outputs and documenting them and preserving them, so that for the next generation and all that, they're able to find this. I know at Makerere, I think we're coming up with a biorepository. I don't know to what extent Alison is involved in this, the biorepository. Alison there. So Alison, maybe if you're not involved in this, that biorepository is going to serve decades and will be a source of any science and drive innovations. So if you're not working, let's say with now the scientists in line of this data repository, you can propose and have this housed in the library for preservation, and also you can help in the metadata link, so that at least you can easily find a specimen and all that in that repository. So that's an area of interest to us, So I'll ask some of the questions later, but yes, that will be very key now that librarians are getting involved in research metadata and to ease our data science extractions of the data sets. Of course, data curation is very key, as I noted to you, that they help us, or they can help us to do the correcting, the structuring, the indexing, and cataloging of these data sets, so that when you go to a data set, you can easily extract the values, or you have key features you can use to extract your different questions. And of course, in one of the sessions I attended here, I had a bit of people struggling in terms of data governance, and authoritativeness of information and data sets and all that. So for long, I think in my first degree, these are things that we are looking at because data governance is very key to libraries. So, and also to either improve their access to their resources or deny their resources. So they have been involved in most of the endeavors or efforts in data governance. So these are people who can help you, advise you in this direction. Of course, in terms of methodology, they can guide on methodology to talk about how data be collected, to so that you preserve data or you collect data that can is data extraction or is data science work. So in the process, before even you start doing the data, or if they are involved, they help us have well-prepared data sets that will ease our extraction, you know what I mean, and our scripting. So if they're involved in this, you find that even right away from the methodology, before we collect these data sets, they already are having an understanding of our architecture models or the models we're going to use to extract the data. So they preserve it and prepare it in a way that is going to help us with extraction. So very important if they are involved from the start. Of course, documenting. I know documentation at time when it comes to researchers, it's a nightmare. We don't know how to document. Someone will ask you about your data management plan. You can't even struggle to come up with a plan, or you struggle to come up with the plan. These are things they do easily. These are soft skills to them. You understand? For us, you think code. For these guys, they can think theoretically and preserve and put down our procedures in written form. You understand? And when you go to NIH and all that, data management plans are now very key. And these guys have great skill sets when it comes to data management plan development, and even having standard templates already they are using. So they can guide us very much when it comes to documenting our procedures. Of course, in terms of training and also increasing our awareness, they can help us, or librarians can help us to see that our training and instruction materials have a component of data science. So if they are not involved in this, how will they be able to do their correction development that embraces data science? But if they are involved, they will know that, look, we need to have such resources that students will read to ascertain and also evaluate, elevate their understanding of data science. So they can help us so much in terms of providing support when it comes to training and instructional material development. So that's very key. Of course, they can offer us advice on metadata creation. This is their cake. data dictionaries. I think I've been struggling with most of the data sets that we have in our institutions. You go to an institution, you want to do some extraction, you ask the data managers, can I have access to your data dictionary? At times even they struggle, what's this data dictionary talking about? So how will I base my code? How will I base my instruction? How do I script this data that has no data dictionary? You understand? They struggle to come up with data dictionaries. So these guys can help us even come up or guide us on how do we develop a data dictionary so that it eases the extraction work. So very important. We are seated on gold mine. If you didn't know, so this is very important here. So we have gold here that we've not utilized as researchers and data scientists. So let's take note of that. And also our taxonomies, they'll help us to do all that kind of work. Of course, at time, if we involve them so much, they can also investigate even our architectures and also ontologies we've used when we are collecting data. So they can get into to understand the architecture we're using as we're developing our platforms and whether those architectures will help us when it comes to extraction. So they have all these skill sets. And also in terms of long-term archiving, they can help us come up with preservation strategies. How are we going to preserve these data sets for years? Which media should we use? Even at times they even advise on backup strategies, backup strategies, offsite, online, offsite, and also media itself, and also maybe advise us on longevity of this data. So very important because this is what they do or they know better. Furthermore, when it comes to FAIR principles, they have a grasp on FAIR principles. And I think without FAIR principles, there's no way we're going to use or have data that is important to us. So we need to see that we make them important in these endeavors. They help us make our data findable, accessible, interoperable, and also reusable. And these principles of scientific data management are very key. So without that, there is no way we shall see that we have our efforts moving on. So we need to see that we involve them because they are good at this and they have been doing this in their open access movement. You understand? So this is their cake in summary. So why not to have a technical working group that has a librarian when you are coming up with the data management policy or a data sharing policy, so that they guide us on our FAIR principles. Of course, when it comes to aspects of data sharing, yes, this is what they have been doing, open data movements, open science, open research, and even the models, the different models. Some are involved in developing these models, the OCD models, the ODC, the public domain models, the Creative Commons. Can we start having our data sets licensed under Creative Commons so that someone at UCT doesn't struggle when you come here and you want to use a data set? Researchers have already given away some of the rights as long as for academic purpose. But these guys have been doing this. It's just that we didn't know. So they have been doing this and they can help us to see that our data sets are easily accessible and anyone who can access the data set and make something out of it. So they have been doing Creative Commons for years and they can help us. Even negotiating with publishers who have our data to see that at least when they give them the data, they allow researchers to go and fish out this kind of data. So that's very important as we go through this kind of efforts of data science. Of course, this is just to show you that, yes, there's so much benefit in using the librarians and also the benefit that comes with FAIR principles. I mean, the open FAIR principles, and they have been doing this. So just to reassert what I was talking about. But also, this era of data science, there's something which we can't forget. That's about ethics and all that. Information ethics and data ethics, they have been doing this kind of policies that looks at ethical considerations of data use, so they can help us when it comes to ethical use of data. So they can help us and work with them to come up with these policies. Of course, the naming conversions, consistency and the speed, librarians are very keen at attention to detail. You know what I mean? They are very keen, they have that attention to detail kind of capability. So they can help us to be consistent in our naming conversions, so that at least we are able now to find our data easily. So they can guide us as we're coming up with our namings. Of course, the legal conditions and ethical, I've talked about it already. But yes, when it comes to data collection, procedures, informed consents, the privacy, and even the rules and regulations around privacy and all that, they have been so keen and observing these rules, for years. For example, when I was still a student, you go to a library and you want to photocopy and say, okay, do for me those 15 pages. They will say, no, that's not fair. What? Fair use something. That's not fair use. There's no you can use to that extent. If you just want to read a chapter, only go for this chapter. So they have been preserving these kind of rules. They know the rules. So if the data set, can you stop at this? Do you want to take the entire data sets? Why the entire data sets? Have you consented to that? So this is what they have been doing on a daily. So we can't reinvent the wheel. We just need to embrace their skill and see that we move on with them. You understand? Very important. So, of course, IPs, intellectual property rights, IPRS, patents, copyrights, trade secrets, all these things we've been struggling with when it comes to data and data use. And I think for decades, I think even in their training, and it's a full module, 2 years, you're just understanding, or 3 years, just understanding property rights, intellectual property rights, on data and all that. So what a skill set, what a source you have, you understand? So, and I think thanks to Dan that you had this talk. So what a skill set you have. Guys who have been doing IP for years, who can better advise you on IP when it comes to data sets than these guys, you understand? So let's see how best we can embrace them and work with them. Trade secrets, and patents. Prof, I wanted to use an example in Uganda. Prof, I know he had some struggle with some IP issues and all that at one of the universities where he heads. And I don't know to what extent were librarians involved, but this was something which could easily advise, that look, you've used the resources for this university and all that ethically, what? This should be an IP of a university than an individual. You know what I mean? But I don't know to what extent were librarians involved in this, but this is something that they can easily advise you. So it's very, very important as we progress. Let's work with them and they'll help us have issues of data licensing. How do we form up with these MOUs, with partners, community norms, and even some contractual elements. Do we have some lawyers here? Lawyers are struggling in this area. Yeah, we have a few IP lawyers on the continent. I don't know whether you knew this. Yeah, do you have some lawyers? Yes. So if this is something you have to take on in the law fraternity. They are struggling to understand IP issues. Yes. So, and there are few, because IP has not been a lucrative kind of discipline or stream within law. So few people have taken interest to understand IP. What do you share? Why don't you share? To what extent? The legal implication. Even awareness is soft. Maybe the lawyers may be there, but even that awareness they haven't given to people to really contextualize this kind of approach. But the librarians, with their knowledge and their best practices, they have been trying to preserve these things, so they can give you a leaf. When it comes to these kind of aspects. So very important. At time I tend to review agreements that we sign with NIH and all that. To appreciate that FBC is ticked because of the 15 years of understanding and reading these things. So that kind of advice and expertise is available. So let's work with the lawyers, but also we bring in our expertise and see that we really move together. Of course, storage and preservation, very important. Replication and authentication processes, they can also do something in this area. Data policy, we've talked about it. Analytical skills, they are very analytical when it comes to conceptualizing things and how they are searched. Of course, the different data management plans, as we talked about, and quality assurance on your data as you collect this data and all that. Do you have a mechanism of ensuring quality assurance? They can help in that area. That's another area that they do well, research data management, new concept, but very important. And once we do research data management, that means our research data sets will really be catered for. of course, they will ensure that these data plans are reproducible, they can easily be searchable, they are fair, and where to deposit some of these data sets. They can be of importance when it comes to that area. So I reflected on this research life cycle for data, data life cycle. And I realized that I think it has just, we've been just waiting for this talk, or my talk, to really see how important these guys are in our discipline. Now, so when I looked at this data life cycle, 90% or 70%, are the things these guys do. Look at it. From capture, from creation, synthesizing this information, aggregating, storing it. Some now even do storage, and even security itself. They archive this kind of data sets. They can help us in analysis, even access and share. They have the wider community to share our findings. Once you have your findings and you put in the library, 1,000 people will access it. Such a partner, where would you get it? I'm asking you guys, such a partner in this kind of data science, data science initiative. So this is exactly what I'm talking about, that if we knew, would we even have moved miles? So I think this is, I told you this is an awakening call to know what we've been seated on that we didn't know. So if you look at this, you appreciate that these guys can move with us from creation straight to our sharing of results and all that. So they can be our partner throughout the entire journey of data science. Do you understand that? Exactly. So, yeah, even when you look at your research life cycle, even straight from capturing, managing, synthesizing, even defining and cataloging all this, we are rotating throughout their thing. Wherever you go, you find them. When you go here, you find that, yes, you need this schema that is metadata. You need DOIs, the digital identifiers to find this data well. This is what they have been doing for years. To help you identify, the taxonomies and all, even the disciplinary taxonomies, they have some. They're able to help you retrieve these data sets instantly, as long as well organized. Even helping us to get some insights. And now, as I told you, they are doing Power BI, they are doing visualization, So this is something that they can help you with, all this, even in terms of data archives and even administration. So let's work with them in summary. Now, as I was saying, let's work with them. What? Now I hear that they also need to move to our pace, or to the pace of researchers, regardless. Now, those of us who are crossing from mathematics, from computer science, from START, this wasn't our core calling, from pharmacology and all that. Now you're a data scientist, you know what I mean? So this is the spirit. Now, these are some of the technical skills that they need, or the tools they're going to use. So they may not be good at all, but we can hope. You know what I mean? We can hope and see where can they help us. But as I told you, right now, we have people who are good at SQL. They can do modeling, and some are even doing machine learning and even distributed computing and all that. But more important, when it comes to tools, I've had more than 4 of my team that are doing R now and Python, So from library context, now they are moving. So they highlight the areas. Yes, they may not be good at SPSS model and SAS, but if they can do R and Python and some bit of Java, you see that they are coming. Now, when it comes to visualization and the presentation of these reports, this is their cake. So we can do the modeling, we can do the what, then they can help us to present the results. So let's start small and we engage. Then the next thing you'll see, we have a community of doctors who are developers, doctors who can code, statisticians who can code, you know what I mean? Librarians who can code. So it becomes part of us and a normal routine. So in that, visibility of the discipline is increasing, and also we have a large mass of people who are pushing such efforts of data science on the continent. Are we getting? Can we proceed? I told you I have an hour. So I don't know how many minutes I have now. Okay. Yeah, almost concluding, then we interact and see. Some of the way forward, and of course, some concluding remarks that I have. Now, as I was coming here, I was telling Dan, one of my funders, to come here. Actually, I phoned some of my peers here, and I was saying, oh, Richard, what are you doing here now? You know, you're in an administration, you know, this director, but again, now you're in this thing. Say, no, maybe someone identified Richard, come and awaken these guys to move with us. So we need to advocacy, and this is exactly what we're doing. We need to advocate for the librarians. We need to work with them when we are having grants. We are submitting our grants. Let's have a data librarian or a data person in terms of the soft skills that's going to help us with our analysis. And let's have them and form some bit of a technical working group for them on this entire concept. I don't know, Michelle, where's Michelle? Yeah, this is something, you know, we may have some technical working group that is looking at this. I think courtesy of NIH, you have in this building more than 50 librarians. What a God. In one of the rooms, 50 are learning how to support you guys. Are they online? At some point we shall get them. 50, full week, they're here to prepare themselves and how to support you. You understand? So such a large mass that if we utilize properly can make us go miles and miles. You understand? So we need to see how best can we engage them. Of course, there's need to reskill, and they are reskilling right now. Dan got them here through NAMLI to reskill and support you. So they are reskilling right now already. And of course, having coming from an academic context and all that, we are also trying to see how we can now even review our curriculums in different universities to support this issue of data science. And the fact that I come from Makerere and I do part-time, teach with them in the College of Computing. So I'll see that the library information science curriculum has a presence, a component of data science, because we need now the young generation that comes up and all that with this skill set. So, and I know in Tanzania, there's some diploma level curriculum that the Ministry of Health is supporting, and they have data science as a component. So you can see they have already rebranded, trying to see how to support this mass efforts of data science. So we need to see that we don't let their efforts down, but rather move with them critically. Of course, methodologies for data science, yes, they may not be do all this, but they can help us in the data analysis. They may not do AI and machine learning, but yes, where possible, let them do those soft things that can still help us go miles. Of course, mentorship, as I told you right now, we have a TOT moving on down for young career librarian, what we call budding librarians, researchers, to help this entire mass that we are building here. So we've already started. And of course, they can help us so much. And they are also engaging in data visualization. Tableau, they are working with those tools. And of course, we can also use so much of them in terms of compliance and standards. Of course, yes, compliance and standards is very important. But also, I had this kind of concluding remarks that data science should be taken as a subset of information science. But since a subset, that's why training session. Okay, it can be the other round. I know I'm alone here, so I may not fight this. I may not fight this so much. But yes, really, let's marry each other somewhere, eh? As we move. Yeah, I have so many data scientists here, so they say strongly, no, it can't be. But in some schools, you find that some information schools in developed economies, data science is housed in information schools, by the way. Even when it comes to where I come from, Makerere, College of Computer and Information Sciences, yes, data science is housed in that community, in that school. So for developed economies, they have already seen this diversity, and the perspective that the diversity or this multidisciplinary car approach can bring on board. You understand? So they have already seen it, and now it's data science has become a multidisciplinary approach, and there's so many people coming in to see that now they are part of this ecosystem. What a nice thing to say, ecosystem that has people who have been here for years. So, yeah, we shall have a discussion where, yes, no, that's not, no, it can't be. But yes, this is exactly something that is happening, and yeah, it's happening. So, but we shall see how we engage and have a win-win. Okay, you see those guys? Are you seeing those guys? Huh? Are you seeing Table Mountain? You see here Table Mountain? So this is Table Mountain of where? So so in summary, as I conclude, these guys are just there ready for deployment. Right away. You understand? So that's exactly the spirit we have. They have come all the way from all the entire African continent, to try to see that they come to be with you and get ready to what? To work with you. So they are ready for deployment. They are here and they are hearing you right now. And they are willing to see that they get those peers they can work with to improve whatever we do in line of data science. I thank you so much. And I think we can have some interactions. I don't know if I'm doing well in terms of time, but yes, that's what I had to share with you. And yeah, we can. Thank you so much. So I don't know how you're going to moderate this. So yeah, we can have some bit of Dan, you can come this side. I can ask some questions, then I shall have our own audience. And also if they want to come in. Thank you. Okay. Oh, so let's have some 4 questions. Yes, we have one.
Yeah, I think in H3 Bionet, we have data management plan since 2017.
Okay.
And then I realized in 2018, there is a gap of research data management. That where we design research data management, and we run it for 2 years, and we're going to run it this year for 30 years. And one of the slides is the role of librarian in research data management.
Can you clap for that?
Yeah, and the other thing is, again, I think there is a nice paper by Ron and Zan where they survey the role of librarian in research data management in North America. And I think you have to do something similar in Africa.
Okay.
Yeah. When I did that course as a group, I didn't come across African health librarian. Is this a new initiative? Okay. That is my question.
Yeah, it's not a new initiative, but
it's
an
not
initiative that is getting awakened.
It is not pan-African, that's what I mean.
Oh.
Maybe it starts in Uganda or Kenya.
We have them here, the founders.
So NLM has been supporting African medical librarians for a long time. Initially, when they started around 2000, they would send librarians to NLM for 1 year. I went for 1 year. And then subsequently others went. After that, Dan and the other team, they decided on a different model. That instead of sending people to NLM for 1 year, let them be supported on the continent, and then expanded the network so that we can continue supporting all African researchers, faculty, and universities on the African continent. So it's not a new initiative, but maybe data science is the new role that is coming on board. Thank you. Okay,
I think one of the first tasks you can do is trying to train librarian, doing and encouraging local university to establish their research data management policy, because that is not an easy overnight thing to do. So I also have paper that I can share with you later. Thank you.
That's good. Yes, please.
Yes, thank you very much for your presentation. It was very useful. I just have a comment on a slide that you show here. A slide on the data cycle.
Can you replay the data life cycle? Let's
Yes, yes, because that slide ends with data sharing.
Okay.
I was expecting to see something that is like a cycle. That's after sharing what happened. Because the slide just ended there, but we call it data cycle. So
Okay.
I was expecting really a cycle.
So
after sharing, what happened?
What happens?
Yes.
That's a great one. Yeah. What happens after sharing? Yeah, and I think yes, the cycle may not have brought it well, but of late we're trying to see that after sharing, we need to do impact evaluation. We need to see whether what you shared influences policy. So there's an arm that we're trying to see that we develop. That is the value evaluation, the value analysis of the research. And I think we've been trying to see how now we do evidence synthesis out of the research that we've shared. So sharing is there, but what impact does it bring on board? So I think it's a missing gap, but I think now the librarians, in order to share, or you will be sharing. So how will researchers know that whatever you've shared has brought back something? Where is the impact of this kind of sharing? So yes, that's an important point that they take note. Yeah, thank you.
All right, good morning, everyone. So my name is Rolanda, and I am going to introduce and facilitate the flash talk session of the early career researchers. So I'll ask kindly if the first group of the early career researchers will make their way to the stage. So that is Dafine, Faith, Ashanafi, Huria, and James, please. Oh, you're going to present. I'll read your slide. I'll read your title and your name, and then you can just start. Yes. Or not, the order is not so necessary. All right, so the early career researchers have a 3-minute flash talk. They will present one after the other for this group of 5, and then they will take the questions as a panel session, the Q&A, at the end of the last presentation for this group. All right, so first we have Dafine. Dafine is going to present Understanding Transfer of Data in Health Research, a South African health research perspective on the flow of data. Dafine, take it away.
Thank you. Good morning. My name is Dafine, and I am a PhD student at the University of the Witwatersrand, and I am affiliated with the Madiba project. Today, I'm going to present briefly my topic, my PhD topic on data transfer in health research. So the concerns or the problems surrounding health data, transfer of health data in research relates to the sensitivity of data. We as researchers use sensitive data when we're doing our health research, and we are called upon to protect this data to ensure that we achieve a health research that's ethically and legally compliant. Sorry. In protecting this data, we need to consider how we handle this data, and legally processing refers to how we transfer, we receive, we distribute, we disseminate this data. Of particular importance to the research that I'm doing is data transfer, how we transfer this data. What does transfer mean? we in South Africa, and this research is done from a South African perspective, we rely on POPIA, the Protection of Personal Information Act, and it has generated most of its principles from the GDPR. In POPIA, we do not have a definition for transfer. So what does it mean? In health research, we have many ways that we transfer data. Ideally, from our perspectives, it appears that the legislation was enacted in a way that assumed that data is being moved from A to B. But in health research, we have scenarios where we are storing our data on the cloud, where we are allowing other collaborators to access our data. Is that still under the definition of transfer as we see it? And it appears that this term transfer is not inclusive of these other ways. So the aim is to understand what the meaning is. How can we balance the protection of personal information and also advance health research? So this research is going to focus on cross-border data transfer, particularly. This is where the problem lies, and it will look at some of these issues, ethical issues related to data flow within and across borders, impact of big data and technology, advancement of data flow, legal issues related to data flow within and across borders, different regulations in data transfer, the GDPR from a South African perspective, POPIA, and the role of research ethics committees in managing data flowing across borders, and some effective ways of managing data flow. Data transfer agreements have been heavily relied upon. Would want to look at the content that would suit both parties that are entering in these agreements. What content should be put in there to make sure that we are achieving data health research that is free flowing and that doesn't have obstacles, and also the legal and ethical obligations of legal researchers towards data flowing in and out. Must you keep up with data that you have sent in another jurisdiction? Must you be following up on that data? So those are some of the things that I'll be looking at in this research. I would like to acknowledge the NIH for funding this project, and I thank you.
Thanks so much, Delphine. So next we have Dr. Faith Kabata, and she will be presenting on the DSI Africa Law project.
Thank you. Good morning. My research is titled Genomic Sovereignty. I investigate questions of ownership in terms of who owns and who can control use and access of human genomic material and also genomic data. And in terms of ownership, the landscape looks like this. We have the state that claims that stakes a claim on ownership based on state sovereignty. The argument that the state is supreme over its territory and everything in the territory of the state has control. Then we also have individuals who stake a claim based on personal rights, privacy, and also the right to individual autonomy. We also have research institutions that stake a claim based on the investment that they have made, talking about IP rights. And then we also have indigenous people who stake a claim based on the sovereignty that they exercise over tribal lands. Now, I focus on the state under the concept of genomic sovereignty. It has been defined as the ability of a people, a nation, or a country to own, control use and access of samples, data, and knowledge that comes out of genomic material. And this claim has been made in the Global South, and it echoes some of the discussions that were there yesterday, looking at genomic material as a national resource and protecting it from exploitation by the Global North, whether you're talking about Global North countries or also companies. So the states in the Global South argue that they need to protect their genomic material, and they also need to reap the benefits. So that's where the claim comes from. And the global position, as we know it, is that it is not clear, it is unsettled on where ownership of genomic material vests, because the UNESCO Declaration on the human genome and human rights talks about the human genome as heritage of humanity, so not vesting ownership on anyone. Of course, this claim by the state is not entirely unproblematic, because when the state views human genetic material as national resource, there is a problem, because unlike other national resources that are fixed on the territory of the state, population is not fixed and population cannot morph into territory. Then of course the state has also to contend with the other claims that are being made by indigenous people, by individuals, and also indigenous people and individuals. So it's not entirely unproblematic when the state makes that claim. So my research investigates the concept of genomic sovereignty as it has been applied in the global south, mainly in Latin America, and asks whether it has any utility value, or it could have any utility value in African genomics research. It also investigates the state claim to ownership and asks whether we could extend state sovereignty to ownership of human genetic material, and also genomic material. And also, if we were to accept the concept of genomic sovereignty, then how do we reconcile the state's claim with the claims that are made by individuals and also the claims that are made by indigenous people? Or is it that we then accept that genomic sovereignty or state sovereignty cannot work in this area, and we say sovereignty, rest in peace? That's my research. Thank you.
Thanks. So next, we have Ashanafi Arga, and he will be presenting on quantile regression modeling for longitudinal data analysis.
Good morning, everyone. My name is Ashanafi Irga. I'm affiliated to University of KwaZulu-Natal. Most of now here I'm learning about data management, but fortunately we use, I'm focusing on the use of data. I'm an end user of the data, that's what I mean. And our DSI Africa program is called Washa Takimu. It's Swahili language. For those of you who know Swahili language, Takumu means ignite data. So Washa stands for working on application for data science and health in Africa. So I'm focusing on quantile regression modeling for longitudinal data analysis. This is my outline. I start with background and I'll finish with acknowledgement and context. As a background, as we know, conventional regression models analyze the outcome variable through mean-based regression. Mean-based, as we know, they are focusing on what? Average results. When you apply generalized linear model, generalized linear mixed model, the conventional model, they are focusing, even if they feed the data well, they are focusing on what? Average results. Here it comes with the quantile regression. Quantile regression enables more fully to explore the data by modeling the conventional quantile at low and high quantile, meaning that it will see the 5th percentile or the higher percentile, which is 95 percentile. So quantile-based regression emerged as an effective analytical technique in numerous study of areas. It can detect also the covariate heterogeneous effect. That means it will see the how, for example, if you want to see the region on the body mass index of children in certain countries, so how that low underweighted children, that means the lower quantile of that body mass index is affected, or which we are focusing on. It will show us a different heterogeneous effect. So quantile regression technique look further into the data, get more information, and become an essential statistical tool for addressing numerous research areas. So these are some of our applications. Recently, this application of quantile mixed effect modeling in modeling CD4 count from HIV infected patients in KwaZulu-Natal, South Africa. It is published recently. These two models are recent, even they were developed in 2019 and 2018. So we are able to publish and see the result of the CD4 count, meaning low CD4 count means the lower quantile. So we are focusing on which patients or which patients need to focus on. The other one is application of quantile regression modeling body mass index in Ethiopia. We see in here also we study which children or those who have lower body mass index that, or those who are underweighted children need to get attention. And these are some of the quantile regression plots. The x-axis indicate the quantile plot. You can see from 0.05 quantile to 0.95, the higher quantile. And the y-axis indicate the estimated value. And those, the other one, B2, B3, those are the covariates. Further studies, currently I'm studying on quantile-based machine learning approach. As you know, machine learning are focusing on still those random forest neural network. What we know in machine learning, they are focusing on mean-based still. So I'm extending that research and I'm focusing on quantile-based machine learning approach. Recently, I received a data set from ARI, which African Health Research Institution. I'm also looking for additional data source to apply the quantile-based machine learning approach. I would like to acknowledge my mentors and the team members, Professor Mosha Meshebela, Professor Henner Mwambe, and Professor Thiel. Thank you very much.
Then next up, we have Huria Tigali, and she will present pathogen genomics at the heart of integrative data analysis for epidemic preparedness and response.
Thank you. Good morning, everyone. So I work at the Center for Epidemic Response and Innovation at Stellenbosch, and I'm part of the Inform Africa project. So within the Inform Africa project, our goal is to integrate various data streams to understand infection dynamics in Africa. So in our group at Stellenbosch, we actually produce pathogen genomics data. For example, for SARS-CoV-2, we've produced over 40,000 SARS-CoV-2 genomes for South Africa. And this is precious data. However, it does not tell us much about the epidemic and infection dynamics without integrating with other data sources. For example, we need a lot of information about the patient metadata, but we're also very grateful for the global community that has shared more than 13 million genomes of SARS-CoV-2 globally. And so this global genomic data and metadata is a fantastic resource for us to analyze our data against. And then we integrate, obviously, all of that within the epidemiological context so that we understand the evolution of the viruses in context of what's happening with case numbers, for example. And now we're also starting to integrate population level data, for example, demographics, population densities, human mobility, and even climate parameters to understand how epidemics transmit on the continent. So with all these data types, we're able to answer a number of different questions. For example, what are the origins of certain pathogens? When were they introduced in a certain country? How does human mobility play a role in the infection dynamics? Can we forecast the next outbreaks, and how is climate change shaping the risk of epidemics? We use a number of methods to do that. For example, genome assembly, genomic epidemiology, phylogeography, phylodynamics, machine learning, mutational signatures, as well as data visualization. And from that, we produce very actionable results for public health. That's the end goal, whether nationally or globally. So through epidemic monitoring, forecasting, pandemic preparedness plans, and global health alerts. These are just some examples of concretely how we've integrated various data streams to produce answers about epidemic dynamics in South Africa and in Africa. The first one is about outbreak genomic epidemiology, where we use genomic data, geolocation of specimens, case incidence, and test positivity rates. And this helped us to detect the Omicron variant in South Africa, for example. The second example there is about calculating disease susceptibility for arboviral outbreaks in Africa using genomic data, disease occurrence data, cell phone mobility data, land surface temperature projections. And this is currently informing our genomic surveillance strategies within the continent. We have also used HIV and SARS-CoV-2 patient status and viral loads data to show that although some patients that have untreated HIV suffer from prolonged infections with SARS-CoV-2, as soon as they're able to get back on treatment and control their HIV viral loads, they are able to also test negative for SARS-CoV-2 sometimes after 9 months of infection. Lastly, we're showing how within the Inform Africa project, we have started to integrate clinical data, hospitalization data with our genomic data to understand on a population level the dynamics between HIV and SARS-CoV-2 burdens in South Africa. Thank you. I would like to acknowledge our partners on the Inform Africa project, the NIH for funding, and our teams at CRISP and SERI for the sequencing work.
Last in this group, we have James Orra. He will present use of machine learning models to predict poor pregnancy outcomes using routine health facility data.
Thank you so much and good morning. So I'm James Orra from Uzima, from Akan University. So today I'm going to present to you how to use machine learning to predict poor pregnancy outcome using data from maternity. So as a definition, I've defined poor pregnancy outcome to include diabetes, preterm births, fetal restriction, hypertension disorders. And we know this is a major risk factor among millions of women during the pregnancy and throughout their lifespan. So this is a problem common in low and middle income countries. And also the risk varies within countries and between countries. So for this, we propose to identify and predict the risk factors of poor pregnancy outcomes using machine learning algorithms among women seeking delivery services in a private tertiary clinic. So since 2018, we wanted to collect about 10,000 data, and the data is in the cloud. This data comes from 3 Aga hospitals, that is from in Nairobi, Kisumu, and Mombasa. So we have defined the outcome to be in a binary scale as any birth outcome other than a live, healthy mother and newborn. So to help us analyze this, we have different kinds of independent variables that includes individual level data on socioeconomic status, history of natal care visits, birth spacing, maternal nutrition, and maternal infection, that is majorly the malaria and HIV. So in terms of the analysis approach that we intend to do for this, we'll first start with the logistic regression, which is we call the classical traditional logistic regression to explore the association between the outcome and the independent variables. This also helps us identify these risk factors. Then we move to the state-of-the-art tree-based methods of ML, which majorly the random forest and boosting, the 2 types of boosting, that is current boosting and XG boosting, to create the PPO. Then to get a better model, a better fitting model in terms of bias and variance, we are going to use different parameters using grid search to get to tune our model. So the model will be assessed using ROC curves, and also you'll be using our classification accuracy. Other metrics that we plan to explore are the patient recall curves and decision curves analysis. This will help us identify the best fitting model. So before I conclude, we already obtained ethical approvals of the 3 facilities that will be participating in this. We've also obtained the national approval to do the study. Then finally, I'll be able to acknowledge the following people in my study. Thank you.
Thanks, James. So now the floor is open for questions to this group of early career researchers. You may raise your hand. Just wait for the microphone. Okay, sure. Go ahead, Henry.
Thank you very much for very good talks. I think my question goes to the last speaker, Olga. Do you envisage issues of missing data in the data that to deal with them?
You still having my question?
Okay, so we've just acquired data recently and we are looking at it now, trying to clean it. We expect some missing data in that, and we plan to use different sensitivity methods. We'll try to impute our data in some cases, and then we try to fit more than one model without the missing data and the missing data, and you see which one fits our data well.
No, that's my background. So I have a question. We are focusing on 3 sites. Is there any reason? You are developing a model. I guess you are going to be using it nationally. So I'm looking at representativeness. If you take that model to maybe a government hospital in your country, I mean, are you sure based on the samples you are going to be, the patients you are going to be recruiting from those sites is going to predict adequately those ones that are not captured in your site? I hope you got my question.
Yes, I do. Okay. So our plan is to use data from Aga Khan, which is a private tertiary clinic in Kenya. But the algorithm we're going to develop, we can validate this based on data from the public hospitals. So there's a possibility to extend the model validation using data from public hospitals. So that's the plan, to extend that. So we hope that our model from the private will fit into the public. If not, we put as a limitation in our study.
Last presenter. I looked into your definition of what a poor outcome is going to be. You said it's any other outcome than a live and healthy modern baby. I'm afraid you will have to probably refine that definition and be more specific in the outcome variables that you're going to look into. Else, I don't see how you will be able to analyze that.
Thank you. That's noted. But we have a broader definition in the write-up. Yeah.
I don't know if the mic works. Okay. Sorry, again, James. I apologize before I ask the question. But anyway, my question is that, of course, for every visit that a woman has in the hospital, they take an image, a scan. So why are you not utilizing the image data as well in your prediction? Why are you only using the patient level data? I think that would really enrich your model. And then the presenter before you, can you please speak more about the machine learning model that you're developing? I know it's all mathematics, but I think I would like to hear more about what you're going to put in that machine learning model for your predictions. Thank you.
Okay, so I can go first. So this data is collected at the time of admission of these mothers. So I know we have a lot of scans from our radiology department and the departments that we can incorporate, but we'll first deal with this one on admission data, and maybe we extend to the imaging. If we can connect, we can link, because some of these mothers don't do imaging at this facility. So it will see which one link, and then after linkage, we can be able to include that specific category of women that has both admission data and data on imaging.
Okay. My question is also for the last speaker. Do you compare between rural and urban areas? Because higher poor pregnancy outcomes comes from the rural areas, at least as far as my country is concerned. Thank you.
When we start, I said that the risk varies, is true. It's correct. The risk varies within the country. It varies. So in this case, most of these facilities are in urban areas. So we've not considered that, but maybe there's a variable asking on the residents. We can incorporate that as a covariate in the model and see.
Thanks. Sorry, just one moment. There was also a question for Ashanafi from Cynthia. So.
Okay, regarding to the quantile-based machine learning, the conventional machine learning approach like the random forest, the super vector machine, and the booster also, they are focusing on still they when we use them, they're giving us the mean-based or average results. So, but when the focus or the interest is to see the prediction at different location or at different points, and the covariates have heterodistic characteristics, so it is recommended to use the quantile-based machine learning approach. It is called just quantile-based machine learning approach. So we are, this is our current study, and we recently received a data from ARI. So we're gonna apply quantile-based machine learning approach. That's the approach we're going to apply. Thank you.
Okay, great. Thanks. Sorry. Thank you very much, all of you. I have a quick question for Delphine, and then I have a quick question for Ashanti. Delphine, when you talk about that there is no true definition of transfer, can you talk a little bit about kind of how you're going through to define that, what ontology principles you're using for that to define transfer? And then for Ashanti, you talked about the importance of seeing the 5th and the 95th quantile, that you can do that with quantile regression. Can you talk a little bit about why that's important? Thank you.
Good on. Hello. Thank you for the question. So with this research, I think that the aim is not to come up with a definition, but to propose recommendations for the government to either define it, if particularly in the POPIA Act, the definition for processing has been broadened enough. I think they can do that. But from our perspective, we want to propose that instead of using transfer as the description of movement of data, we propose for using flow of data. Yeah, so transfer of data, as long as it's inclusive of all the aspects of how data has been moving around, access, not actually moving from point A to point B, but remote or digital access to the data or sharing of the data. Thank you.
Okay, thank you for the question regarding to the 5th and 95th percentile. Fortunately, quantile regression, you can have from 0.01% to 0.99 or the whole percentile, but these are the recommended percentile from 0.05, 0.25, 0.5, which is the median, 0.75, 0.85, and 0.95. If you model on that percentile, it will capture the whole data, the whole covariate effects on that percentile. For example, let's see the body mass index of a children. The body mass index of a children, if you put it in percentile from the WHO recommendation, 0.5 percentile indicates those who are underweighted children. And from 0.5 to 0.75 indicates normal health or weight. And from 0.95 percentile indicates overweight or obese. So if you model from 0.5 and 0.95, it will capture underweighted children and obese children. So it will tell us on which children we have to focus on.
All right, I'll just have one general question for Faith. Faith, if you have to put in a nutshell, what is the most innovative thing about your study?
Yeah, thank you for that question. As I said, the concept of genomic sovereignty has been raised in the global south, and there has also been talk about it in terms of African genomic sovereignty. So the most innovative thing would be to see whether that concept would be deployed to come up with infrastructure that supports research, genomic research in Africa, because literature from Latin America shows that it didn't work, but not to say that it be abandoned, but to say that there's still room for it, but with a different way of conceptualizing it.
Thanks so much. All right, that concludes this session or this group. Can we just have a round of applause? All right, so now we call on the next group of early career researchers to take the stage, please. It's Yasmit, Karen, Etienne, Michael, and Millicent, please. Great, so it's a pleasure to introduce Yasmit. Yasmit will present perceptions and knowledge towards COVID-19 vaccine.
Morning, everyone. I'm Jasmeet Shah, and I'm from the Brain and Mind Institute, which is hosted at the Aga Khan University in Nairobi, and I'll present about the perceptions and knowledge towards the COVID-19 vaccine. As we know, COVID-19 had crippled the whole world, and there has been strategies on how to combat the disease. And we know that vaccination is the most important and effective way in avoiding any kind of disease. And we know that 2 to 3 million of deaths are prevented through any kind of vaccination, and 1.5 million could be avoided if global coverage is improved. And as we all know, that COVID-19 vaccine was generated very rapidly, and there has been a great debate during its introduction. And vaccine hesitancy, as defined, is the reluctance or the refusal to vaccinate despite the availability of the vaccines. And it's one of the 10 global health threats in 2019. And there are various reasons why people choose not to vaccinate, and they're very complex. And WHO has identified the complacency and convenience in accessing the vaccines and lack of confidence, which are the key reasons of not getting vaccinated. And therefore, we wanted to do this study in the aim to identify and look at the perceptions and knowledges towards the COVID-19 vaccine. We also wanted to look at whether there are differences between those that got vaccinated versus those that did not get vaccinated. And then we also went ahead and looked at differences between different healthcare institutions and whether there are differences where participants were coming from there. So this was a cross-sectional study that we did between November 2021 to January 2022, which was during the second wave in Kenya. It was within 6 healthcare facilities. 4 healthcares were private facilities, 1 governmental facility, and 1 was faith-based facilities. And the participants were any general adult public, either the patients or the relatives that were visiting this healthcare facilities. The survey was in English and was built from literature review, and the questions that were used were from the literature review, and we had consent to use some of those questions. So the survey questions included socio-demographic characteristics such as age, gender, marital status, education, employment status, citizenship, and race. We also looked at any medical comorbidities and some questions on COVID-19 infections. We further then looked at the attitudes and perspectives towards the COVID-19 vaccines, and this study was approved by the IRAC at the Aga Khan Hospital and also the governmental institution. So we had 3,996 participants that were that had filled in the survey. The median age was about 33 years. 55.8% were females, and 43.7% had stated that they were exposed to or infected with COVID-19 without testing. 68.8% had received the COVID-19 vaccine, and 63.1% were most worried about dying through the COVID-19 infection. Perceptions about the COVID-19 vaccine, 81% stated that it was important to get the COVID-19 vaccine. 61.6% stated that the pharmaceuticals are developing safe and effective vaccines. 30.0% stated that the vaccines developed in Europe or USA are safer than other countries. 25.5% stated that the vaccine was faulty or fake. 65.1% stated that the vaccine was rapidly developed. 37.6% stated that there were medical complications in the future after getting the COVID vaccine, and 26.6% stated that it was promoted for commercial gain. Whether they would take the vaccine, and about taking the vaccine, 79.9% say that they would take the vaccine. 77.6% stated that they recommend the vaccine to a family. 65% stated that they would get their children vaccinated, though 40.5% were hesitant in taking the vaccine due to side effects, and 48.2% used the healthcare providers as a trusted source of information of COVID-19 and COVID-19 vaccine, and then 19.9% used the media as the trusted source for COVID-19 and COVID-19 vaccine. Looking at association about those that got vaccinated versus not vaccinated, merit participants were associated with getting vaccinated. Higher education was associated with getting vaccination. Whether they stated it was important to get a vaccine was also associated with vaccination. Pharmaceuticals developing safe vaccinations was associated with vaccination. An interesting finding was that whether the vaccine, because the vaccine was rapidly developed, that was also associated with getting vaccinated. Looking at the association between healthcare facilities, private versus government versus faith-based. Private, it was seen that the higher percentage stated that it was important to get the vaccine, and pharmaceuticals develop safe vaccines. The governmental, the higher percentage stated that the vaccines made in Europe or USA are safer, although faith-based institutions stated higher that the vaccines are faulty or fake, they were rapidly developed, and there were medical complications, and it was used for commercial gain. So the conclusions of this study was that it was one of the first studies with a large-scale population looking in East Africa about the vaccine hesitancy, and also comparing between vaccination and no vaccination and the differences between different healthcare institutions. Vaccine hesitancy in Kenya, even though much lower, remains a dynamic and a challenging problem in lower middle income countries. Although the vaccines are theoretically available, the access to get these vaccines in rural areas is a challenge, and there has needs of mitigating strategies in Africa to address this vaccine hesitancy problem in the world. Future work or ongoing work that has been happening, we are currently under review of another paper with the vaccine refusal trends in 2021. This was publicly available data from the World Bank through the Rapid Response Phone Survey, and looking at the trends of how the vaccine refusal rates are. We're creating education and awareness materials to deploy to healthcare facilities to give them to the patients and their relatives on the importance and the advantages of vaccines, which also now starts combating the misinformation on the efficacy and the side effects of the vaccines. We also want to further leverage this study to target different counties where we have lower vaccination rates. Currently, to date, only 25% of the Kenyans have at least got one dose of vaccine. So we know that we still have to get a long way up to there. So this is what we're doing, and I want to thank the institutions that are part of this study. Thank you.
Thanks, Yasmet. So next we have Karen Kenny. He will present on the public understanding of big data in genomics medicine in Cameroon.
Good morning, everyone. I'm Kenny Kamga Karen. I'm a Cameroonian physician and a postdoctoral fellow at the University of Cape Town. My talk today will be on public understanding of big data in genomic medicine in Cameroon. It is well known that ancestral African population are the most genetically diverse in the world. 30 years after the completion of the Human Genome Project, it is now evident that embracing the perspectives of accurately diagnosing thousands of monogenic conditions and predicting disease risk for most common complex traits, as well as tailoring treatment according to individual pharmacogenetic profile, and potentially curing some diseases with genetic editing technology, we have to conduct research in the African population. Despite the declining cost of genomic sequencing, the major challenge is equitable access to this new technology, which can prevent genomic knowledge from becoming a global public good, particularly in Africa. This is due to inequalities in healthcare systems, deficit in genetic research workforce, and limited access to research funding. To address this burning ethical question, we conducted a pilot qualitative research between July and August 2022 to explore the public understanding of big data in genomic medicine in Cameroon by investigating models of public engagement and preparedness for big data use in health in Cameroon. Building on our previous experience with the sickle cell community in the southwest region of Cameroon and the Fragile X community in the western part of Cameroon, we conducted 4 focus group discussions and 14 in-depth interviews. Participants responded to 4 categories of questions, which gathered participant opinion on big data, genomics, genomic medicine, data storage, data sharing, and readiness for data-driven medicine. To date, we had 56 participants. At the first glance, most participants had very little knowledge on big data and genomic medicine. Concerning data storage and data sharing, most interviewees believe that data should be shared anonymously with other researchers. In addition, divergent strategies were mentioned to help the public make good use of genomic data and big data. And finally, most participants think Cameroon is not yet ready for data-driven medicine. Nevertheless, they propose some strategies that could help improve and encourage the public to participate in genomic and data-driven medicine studies. On a concluding note, we think that a multi-site analysis of the whole data set will give a better picture of the African's perspective and attitude towards big data in genomic medicine. And we would like to acknowledge the founders and the PopGem team. Thank you.
All right, next we have Etienne Kouakou, Understanding Water, Sanitation, Hygiene, Heat and Health Interactions using Data Science for an Early Warning System.
Thank you. Morning, everybody. I'm Etienne Kouakou from University of Nangua-Brugua, Côte d'Ivoire, a member of the team of UPCG, University Péréphéro-Gon-Coulibaly in the Dauphin, Côte d'Ivoire. And I'm postdoc researcher in the Heat Center Research Project 2. My background is hydrology and hydrogeology, but I also have a master in GIS and remote sensing. So my postdoc underline here is about understanding water, sanitation, hygiene, and heat health interaction using data science for an early warning system. So regarding Africa big cities, we have many types of living, standing, and households living. And we have also all these people are facing the effect of the climate change regarding to the heat. So the question we try to understand here is how people in a same city like Abidjan experience heat effect in different conditions of access to water, sanitation, and hygiene. So we have 3 main objectives. The first one is to analyze all these conditions. And secondly, to try to map these inequalities in terms of mapping, detailed mapping, and then evaluate the impact of the heat on the urban water demand. So to do that, we'll need different type of data regarding drinking water network, monthly household water demand, storage network, and also household standard of living. And we'll also have to need climate data, health data, and so on. Analysts will focus on the spatial analysis in order to make a mapping, analyzing water and sanitation and hygiene issue. We are now starting, so by the moment we are screening the health data and identify the necessary socioeconomic data owners and make contact with them in order to have the data. And we are also building reflection about vulnerability mapping. All this will contribute to reach to achieve the HIT objectives, particularly the establishment of the early warning system. For that, we'll need, in the team level, we'll rely to the support of the training engagement core of the HIT Center in terms of capacity building in fields like the climate and health, and also data science, in field also of computer specific software, and we'll also rely on the support of the DMAC. And then we, at the team level, we also see DSI Africa as an important and additional training opportunities. So thank you very much.
Thanks, Etienne. Next, we have Michael Mugisha, and he will present on using international classifications and data standards in electronic health systems in Rwanda, a prerequisite for structuring healthcare data to advance research and training in data science.
Thank you. Good morning. My name is Michael Mugisha, and I'm based at the University of Rwanda. My presentation will focus on the collaboration we have with the Ministry of Health to integrate existing classifications and standards in the electronic health records so that we have a more structured data to inform training and research. So the use of vocabularies, classifications, and terminologies in routine healthcare is an important step, as we have said in previous, to acquire fair data. But several classifications and terminologies are in place. If I would mention ICD-11 ICHI and then SINOMED and many more, they have been developed to help in collecting these structured data. And using them may help in collecting data that can be used for clinical, public health, and policy decisions, but as well as extended to research and training. I'll reflect on the key classifications we are currently working on with the Ministry of Health to be integrated in the healthcare system. We have here the ICD-11. Most of you maybe know that it is now out and being used. And we are helping the Ministry of Health to integrate it into their systems to ensure that we have a level of data details that can inform all those benefits we have in data, but as well as this international classification of health interventions that can now help to code everything related to health interventions in care. So what are the gaps in using classifications and terminologies and their implications? There are various vocabularies and terminologies in use currently in place, and the use of outdated classifications, and even non-use of it at the point of care. In other words, used for reporting or research purposes. And what it leads is collecting data that is more unstructured, or in a way that you cannot have best use of it. And building on these gaps, we want to work with the Ministry of Health, and this is a partnership that has been going on, to ensure that we use the skills and training we have at the University of Rwanda, and then support the Ministry of Health to come up with developing structured data in a way that is more used for healthcare decision, but as well as for training. So our training program will bring in skills for biomedical and public health, computer science skills, and statistics and mathematics to apply data science principles in coming up with structured data. At the end, we'll be having more useful and informative data for research training, but as well as clinical and public health decisions. Thank you.
Thanks so much, Michael. So next we have Millicent, and Millicent will present on the analysis of the effects of high-density lipoproteins on early formulation of a new atherosclerosis plaque model.
Hello, everyone. I'm Millicent Afrifo-Poku from KUST Ghana. Okay, atherosclerosis is basically a chronic inflammation in the artery, the inner lining of the artery, which is caused by a gradual buildup of cellular components that diffuse into the intima of the artery over a very long period of time. And it involves several cellular components, including the high-density lipoprotein, which we are paying particular attention to because of its atheroprotective effect. And as we can see in the images, the first image shows the various stages that the atherosclerotic plaque formation can attain, whilst in the second image, we see the various cellular components from interacting with each other in the intima of the artery to form the atherosclerotic plaque. So with this study, we focused on three cellular components, being the oxidized low-density lipoprotein, high-density lipoprotein, and macrophages, with a particular focus on the high-density lipoprotein. And we used nonlinear partial differential equations to formulate a model, performed two analyses, being the stability analysis, which included with diffusion and without diffusion. And we identified certain parameters that has effects on this formation process, given as the bifurcation analysis. So with our quantitative analysis, we were able to establish that with the three various cellular components, there are interactions, and with the presence of high-density lipoprotein, we see an immediate decrease in the macrophages. This being as a result of the atheroprotective effect of the high-density lipoprotein extracting or performing the reverse cholesterol efflux. And we could also identify for the diffusion, the stability analysis with diffusion, that although there's cell diffusion, it didn't really contribute to the diffusion-driven instability. And lastly, with the bifurcation analysis, we were able to establish that certain parameters, such as the one that had to do with the digestion of macrophages with the HDL, had a particular contribution where a stable node, meaning a stable system, tend to be unstable due to the presence of the low-density lipoprotein and the macrophages. So with our key findings, we were able to tell that although the high-density lipoprotein has an effect on the atherosclerotic formation with its atheroprotective keynote, it didn't really go on as expected because it has to stay in a certain threshold, because it can equally contribute to the anti-inflammatory or the pro-inflammatory of the plaque formation. And we also established that the cell diffusion of the various cellular components didn't have effect on the model that we generated. For further studies, we tend to pay attention to the high-density lipoprotein and the various genes associated with that, and also be able to simulate data sets that will be studied to know the various points that plaques can be formed and advise on targeted therapy medication. These are my supervisors, and I would like to acknowledge people involved. Thank you.
Thanks, everyone. So the floor is now open for this group of early career researchers for questions. Oh, there's a question.
Thank you, Dr. Question is to Dr. Kiran. Dr. Kiran. Sorry, I'm here. Okay. Yeah, your study is a qualitative study. I realized that you only give us information on the sex and the age distribution. Are there other information that you collected from the participants?
Thank you very much for that remark. Those were the two main things that we collected from the participant, even though we got their locations where they were coming from. So that was the additional thing that we could collect.
Okay, sorry, just a backup question to that. Sorry, the information on your age, do you think the way you presented this is quite informative? I mean, it's like a range.
Yeah, concerning the age range, I gave the age range, the average age and standard deviation. It was on the slide.
Okay, okay, I didn't see that. Thank you.
Yes, my question is to the first presenter, Jamit. Interesting study because of its importance as well. One of the things you mentioned towards your conclusion was the difficulty in availability of vaccines, maybe in rural areas. I wonder whether your data show that. That's one question. And just wondered whether you had any information among vulnerable populations as well, such as pregnant women, in terms of what they think about the vaccines. Thank you.
Thank you for the question. So we are the rural area that did not get the vaccines is probably just from the reports that we've got from the Ministry of Health. We did not do this, but we have identified, because the country gives out the distribution of vaccinated personnel in each of the counties in Kenya. And we know that the counties, for example, in the northern areas is where they're not getting vaccinated. And that's what we want to target it as a second or the third study, just continuation of the study. On the vulnerability population, I have not been involved in the first one, but there are colleagues that I have collaborated on the refusal project that I stated that is under review, had looked at the refugees, particularly that was available within the World Bank data through the Rapid Phone Survey. But we've not specifically looked at specific vulnerability population. I'm also part of the another study that WHO is looking at COVID-19 vaccination in pregnant women. So that's something probably that will probably come out from the Kenyan population.
Microphone. Okay. Hi, this one is for Karen. The discussion about big data and genomics in Cameroon. And given that you mentioned that there was a lack of knowledge and understanding of these methods and what they would show, are you at all concerned about unintended consequences of discrimination or, down the line, stigma and discrimination with this data?
Thank you very much for the question. Actually, given that there is lack of knowledge about genetics and big data, we think there could be some sort of stigma and discrimination based on our previous interaction with communities having genetic conditions and seeing how they were interacting with the community and how the community behave towards them. So we think there is some sort of stigma that is occurring in the society with these people with genetic conditions.
Thank you. My question goes to Millicent. I just wondered whether you, in your study, did you think of the role of triglycerides in the formation of atherosclerotic plaques? Triglycerides.
The role of triglycerides.
The role of triglycerides.
No, please. I didn't consider that. The main focus on this one was the high density lipoproteins.
My question goes to the first presenter. So your study had to do with finding out the extent to which people accepted or otherwise COVID-19 vaccines. So in Africa, we know that some African scientists know the implications of the various implications of vaccine development, what actually goes into the development of a vaccine. And in other countries, we are aware that African scientists actually led the vaccine hesitancy that was going on in the continent because they know that much data did not come from Africa. Much data from Africa did not go into the development of the vaccines that were being given. So, quote and unquote, they were scared about the possible negative effects that these vaccines could have. Did you consider the fact that probably not a lack of the technical know-how, but then the capacity for African scientists to also generate data to add up to the development of a vaccine that could be acceptable to all could have also caused this problem?
So we didn't specifically look at that, but that's something that when we're doing the literature review and we have found out that a lot of this misinformation is from social media where Africans think that the other countries are trying to put a microchip in the vaccines, you know, to probably track this thing, right? And we just wanted to purely do exploratory of what the public seems to understand about the vaccines being developed first in the US or Europe, because those were the only countries that started developing this vaccines, right? So we just purely were exploratory to see whether they culturally believe that those vaccines are safe, you know, whether pharmaceuticals companies are developing safe vaccines or not. So we didn't actually look at about, you know, the technicalities or, you know, about them being developed in Africa.
Thanks, Yasmin. There's one final question.
My question goes to Etienne on understanding water sanitation and health. And I'm curious about in your implementation, whether you're going to consider using a spatial data infrastructure and how these systems are going to communicate. Is this something that you're thinking about? And are APIs available for these data sources that you intend to consider?
Can you repeat, please?
You present a very important topic on understanding water sanitation and health. And in your presentation, you're looking at considering data sets for drinking water, monthly household water, and sewage data. And I'm thinking, whether I missed this, maybe I stand to be corrected. Is a spatial data infrastructure one of the ways that you're thinking about having these different systems communicate so that you can present a more informative study? And is this APIs available for these digital data sources from Cote d'Ivoire?
I don't get well your question because of my English. That you want to know if I...
How are you intending to have these digital data sets communicate to perform a more informative study?
All the data sets, how I will get them communicate.
Yes.
Okay. We will use software like I guess to bring all the data together to to make the analysis. I don't know if I mean. Is it the question?
Please, can I come and help?
Etienne, I think she's asking about the special data.
French. That, yeah.
Les données géospatiales, quoi. Je pense qu'elle parle de ça, d'où ça provient, quoi. Si j'ai bien compris sa question.
Ouais. Je peux aider un peu ici. En fait, c'est que j'étais sur le point de lever la main aussi pour soulever ça. Dans toutes les présentations qu'il y a eu ici, on a beaucoup parlé d'outcomes qui sont santé. On parle de on parle de data santé vraiment. Yeah. Tu es le seul qui a présenté quelque chose sur autre chose que ça. Tu as parlé de eau, assainissement, hygiène. Elle dit justement où est-ce que tu vas trouver ce genre de données et est-ce que tu as l'intention d'avoir référence à des infrastructures spatialement localisées pour les lier aux autres données. Comment tu vas faire ça? C'est un peu ça la question. C'est le spatial et les données spécifiques que tu as dit que tu vas chercher. Ils ne sont pas forcément des data health science en fact. Yeah. Comment tu lis ça aux autres?
Ah, ok. Thank you. So I try to answer in English. So for the data set regarding water use, we are searching now data like this, but we have in Abidjan for water issue and sanitation, we have one society who is in charge of this service since 1960. So we are collecting data regarding water and soil. So we will try to collect this data and look at household level if we can find regular data regarding the years of the study we are going to take. Okay.
So much. So a round of applause to the early career researchers. So we will call on the last group. So the last group of the early career researchers for today, I call on Kadim, Rogers, Odette, Oluchi, and Wondorson, please. All right, first up, we have, it's my pleasure to introduce Kadim, and he will present on the survival analysis of HRD mutated breast and prostate cancers.
Thank you. So hi everyone. So my presentation will start with, as usual, as an introduction and finish with a conclusion. So as an introduction, I was going to talk about, so I need to be quick, right? So once you miss tea break, so yeah. So I'll start with breast cancer and prostate cancer of the most prevalent cancers in women and men worldwide. And there has been a lot of new cases in 2020 alone per million. So there are also numerous risk factors which can contribute to breast and prostate cancer. So one of them I'm going to look at is HRD genes, which is homologous recombination deficiency. So which is functional defects in DNA repair system. There are and mutations in key genes of these HRD pathway can initiate progression of breast or prostate cancer. So there is a list of like 17 genes which is commonly used. So in this study, I'm going to use data set from CBio portal, which includes clinical data and genomic data as well. So for this data, as an initial analysis, I'm going to use tools in CBio portal itself to see the effects of mutation in these genes and also their impact on survival. So the first tools I'm going to use is oncoplots. So there are some the oncoplots for breast cancer itself. So I have taken the frequency of the genes which has more than 4%. I have circled it in red. And for breast cancer, we can see there are BRCA2 and NBN, which are most frequent ones. And for prostate cancer, you can see again, it's BRCA2 and NBN, which is very frequent in these two prostate cancers. So now I'm going to see which HRG genes has the most effect on survival. So, again, I'm going to use survival tools from the CBio portal as well. So the HRG genes which were used for greater effect on for breast cancer were BRCA1 and BRCA2, which relate to studies which is literature which is available. And also BRCA2 is one of the most frequent we can see from the oncoplots for breast cancer. As for the prostate cancer, we have seen that the HRG genes which was used for greater effect on survival was FANCC and NBN and RAD50. So which it doesn't coincide with some of the literatures which says that BRCA1 and BRCA2 and ATM, which is associated with aggressive prostate cancer. But one thing we can notice is that NBN is the most frequent HRG genes in prostate cancer from the oncoplots. So as a future study, I plan to study the similarities between the molecular profiles of breast and prostate cancers, which can, hoping that the results can provide insights into the therapeutic interventions for cancer patients. Thank you.
So next up we have Roger, and Roger will introduce his title to his talk.
Thank you. My name is Moav Rogers from Mbarara Data Science Research Hub. And we are trying to propose a digital pathology platform for automated diagnosis and classification of diabetic retinopathy from retinal fundus images. So diabetic retinopathy is a vascular disease of the retina caused by chronically high blood sugars from diabetes, and it's the leading cause of irreversible blindness amongst people aged between 20 to 75 years. This disease affects people who have had diabetes for a long period of time, say 10 to 15 years. And the most affected group of people are the working age group, especially people in this room. It is important to note that around 463 million people are living with diabetes. And of these, 285 have some form of diabetes retinopathy. And 154 have visual threatening diabetic retinopathy, including macular edema, a condition that fastens the process of blindness. And the count is still on. We can clearly see that by 2045, these numbers will have doubled, especially in sub-Saharan Africa, where we have ill-equipped health facilities and also have a shortfall of retinal experts, especially ophthalmologists. I'll give an example of my country, Uganda, where we have 48 ophthalmologists, and of these, only 27 are in practice. And they reside in urban centers of the country, serving a population of only 11 million people. So leaving the 34 to be diagnosed or worked on by people that are not experienced and also experts at screening the disease. So this motivated us also to come up with a way in which we could empower people within our remote settings to screen for these diseases. And because also we note that the current screening modalities that do exist within our population are time consuming, and they require an expert to achieve satisfactory clinical imaging. We've also seen that they have variations For example, the commercial algorithms, the commercially available algorithms were designed on data sets that do not fairly represent our populations. So when you subject them to our population, we've seen variations, and we believe that these variations could be a source of error while diagnosing diseases within our communities. Thank you.
Thanks so much. So next we have Odette. Odette will present injury patterns and associated health outcomes among motorcyclist trauma patients in 4 hospitals in Cameroon between January 2020 to May 2022, a research protocol.
Good morning, everyone. I am Odette Kibu from Cameroon, postdoctoral research fellow, Design Africa. I hope after these 3 minutes of presentation, most of you here in this room will add trauma research to what you do. And like Mohammed, I'm going to respect the 3 minutes presentation. So I'm going to present on injury patterns and associated health outcomes among motorcyclist trauma patients in 4 hospitals in Cameroon between January 2020 and May 2022. This is a research protocol. Before I start, I want to share with you a little story of Ryan, who lived in a small community. And Ryan was a motorcyclist that died of a road traffic injury. Ryan's brother became a drug addict because of what happened to his brother, and the small community where Ryan lived suffered from the trauma. This is Ryan among the 1.25 billion people in the world that die every year because of road traffic injury. It is not Ryan alone that dies, or it's not the 1.25 billion people that die, but the other people associated or that are connected to these patients. And in Cameroon, you would understand that 10% of injuries are a result of 10% of death are due to injuries. And low and medium income countries, 90% of injuries, 90% of deaths are due to injuries. And the objective of this study is to assess the injury patterns that are associated with the injury patterns among motorcyclists and their associated health outcomes. Because between January 2020 and May 2022, when we conducted this research and did an overview, we discovered that 55.9% of road traffic injuries were due to victims that use motorcycles. And that is why we want to understand what are their injury patterns and what are their associated health outcomes. So this study is a retrospective study on the population, the trauma motorcyclist patients. The study was conducted in a hospital setting, and the sampling technique that was used was a consecutive sampling technique. And we're going to look at the data, we're going to extract the data from the data that was conducted between January 2020 and May 2022. The expected outcomes that will come out with the injury patterns, the health associated outcomes, and also map the distance from the scene of the accident to the hospital. And this will inform the interventions that will be put in place in order to reduce the burden among this risky population. Special thanks to NIH, the University of California, Berkeley, the University of Los Angeles, California, Los Angeles, PACE, that's the Program for the Advancement of Surgical Equity, and to the University of Boya. Thank you.
Thanks, Odette. Next up, we have Oluchi, and Oluchi will present to us overview of governance framework for data science health research in Nigeria.
Thank you. My name is Oluchi Maduka, a postdoctoral trainee on the Bridge LC project. Bridge LC project is a collaborative research ethics study focused on bridging the gaps in the ethical, legal, and social implications of data science health research in Nigeria. There are several components of the project, but I'll be speaking to the specific aim one, which is to evaluate the extant governance framework for data science health research in Nigeria. We did that by aggregating and analyzing the current frameworks of oversight of data science. It's purely a legal research and analysis approach. We adopted case law research methods, text analysis. We relied on primary and secondary data and identified specific themes which we sieved out from the law. And then we raised several questions, which are, what are these laws and that provide this framework for data science health research? And whether these laws provide sufficient framework in the area of de-identified health data, secondary use of identified health data, commercialization of data, and commercialization of tissue. And then what are the gaps? This table shows the laws we looked at. We considered a lot of laws, but for this presentation, we identified 6 most important, and then how they responded to these questions, and then the themes that we considered in the laws. But most importantly, I'd like to mention the interpretation that the courts are giving to the privacy provision in Nigeria. For data science, we are looking at sensitive data, but the way the courts are interpreting it, it's even building photographs, that's, even though we know that building photographs, they are publicly available, they are not sensitive enough, but the courts are saying that before you use these photographs, you will need the consent of the owner. Because in one of the cases, the person alleged that he was embarrassed seeing his building photograph on a place without his consent. So these are some of the themes that we considered: privacy, whether these laws protect cultures, groups, and communities, rights of data subjects, dignity, discrimination. And then overall, Nigeria has a robust research ethics framework. Data privacy and protection fall under several laws and regulations. These laws provide guidance, particularly as it relates to data subjects' rights, consent, privacy, protection of cultures, like I said, commercialization of data, and protection from discrimination. However, there are gaps regarding the ethical review of data science health research, the use of anonymized data, de-identified data, and publicly available data for research. I acknowledge the support and staff of the Center for Bioethics and Research, and then the NIH. Thank you.
Thanks, Oluchi. So next we have, and last of this group, we have Wand Dawson, and he will present the data warehouse architecture for Ethiopian health sector. I don't know if that's the title.
Yes. Okay, welcome to the last flash talk. So I'm Wand Dawson from School of Information Science at Addis Ababa University, and I'm also co-investigator as well as faculty scholar for the AfriADST project, which is a collaborative project between Columbia University in USA, University of Nairobi in Kenya, and Addis Ababa University in Ethiopia. And from Addis Ababa University, one of the techniques that we are using to help our graduate students, this is a training program. So we have a master's in public health data science program, which is being prepared and ready to launch. One of the things that we set up at Addis Ababa University is to have a research interest group, so that graduate students can easily join and make a sustainable contribution to the health sector. So saying this much about the project, Ethiopia is a country with more than 120 million population. And if you look into the health system, we are challenged by many diverse problems that we have. And the Ministry of Health has a health sector transformation plan where technology-driven solution is taken as one of the pillar to help, the health sector in terms of giving information for decision makers, for policy makers to come up with a solution. So we have tried to look into the existing e-health systems that are available, which are developed by the government of Ethiopia or donor agencies or some private companies for different purposes. And there are around 220 e-health related apps or systems, from which 77 are unique in terms of the type of data they collect and the type of users that they have. So the focus that we have in this proposal is the 77 e-health systems that we have in here. And if you look into the user landscape at the left side, as you can see, some of them are providing information for the patient, some of them for physicians, low-level health workers, to the level of the decision makers, especially those systems that are available at the Ministry of Health are meant to provide information for policymakers and decision makers to come up with an intervention. And if you look into, again, in the middle, the data dimensionality, the e-health apps are having information about patient data, drug distribution, medical equipment, demographic data. So as you can see, we have multi-dimensional data and user groups. And when we look into these 77 e-health apps, they are very much, explored in terms of many different variables that we want to look into. So as you can see, the deployment environment is quite, diverse. Most of them, as you can see in the middle, the top picture, 59 of them are available in the physical server that is situated in different organizations. It can be hospitals or the Ministry of Health. And we also have a standalone system that are serving a particular purpose. And we also have some applications deployed on the cloud, especially those developed by donor agencies are hosted on the cloud. And if you look into the heterogeneity of the software standard, most of them at the bottom, as you can see, 48% of them are proprietary, which is going to make, data integration, pooling of data from this system be much difficult. Some of them are open source, which is, promising. If you look into the data exchange level, 61% of those, do not, as such, report. They try to send data, and 39% of them send data to the, the Ministry of Health, including its structure, but 69% of them are not as such, into that domain. But more importantly, the openness is the one that really, gets our attention. As you can see, 58% of those e-health apps, they don't have, API, which means, integrating with such kind of systems would be really tough. So we have to have a workaround, and 66% of them, they don't have any, interaction with other systems as well. Mind you, the main reason that we are focusing on this is we know that these e-health systems are developed to serve a purpose. But at a national level, unless and otherwise, we have unintegrated data for the decision makers that shows patient records, at the same time, drug distribution, medical equipment distribution, and the like, making a decision in such kind of, a higher perspective would be really difficult. So the idea that we have in this project is we need to be able to develop a data warehouse architecture that can bring these, applications that are put in a solitary manner. But we know that the 77 applications, all of them might not be brought to the same standard because they are already mature, they have been used. But at least if we can bring some of them into this framework, and again, set the standard for future e-health system to be developed, then we know that the nation would have a better, repository of national data in the health sector that can actually inform decision makers. So the primary focus that we are going to work with our students after this preliminary analysis is to look into the three diverse deployment architecture, which is the cloud, offline, and server-based or local server-based deployments, and also the wide variety of data dimensionality that we have. And the primary focus is going to be on the data and integration layer. We know that once we're done with this, the processing and the analytic level is going to be the task of the data scientist to make sense out of the data. Thank you very much. And I would like to thank AfriDST, DESA Africa, and NIH for the opportunity given to us. Thank you very much.
Okay, so the floor is open. I know we're a few minutes behind, but the floor is open for questions.
Yeah, thank you. So my question goes to the second presenter, and the law from Nigeria. Yeah. So first, I wanted to find out if you could tell us. I couldn't see any results you showed, but you made mention that you observed some variability between the conventional approach versus the vendor systems, AI systems that were implemented, and versus the, if I understand, the third one which you intend to do, which is more specific to your local context. Can you share some details on that as well? Maybe should I proceed to the next person?
Okay.
Oh, yeah.
We've done some reviews and also tried to do some experiments within the hospital. We've seen, for example, the OCT. It was calibrated on the threshold set in the OCT for Caucasians. And we see that when you subject it to our population, we get variations with the results. You find that we have different retinas compared to our population. So because of that difference, when they use retinas of, for example, another population to train an algorithm within that is embedded within the OCT, and they subject it on another population, we've seen that there are variations, and we believe that these variations could be a source of error when trying to use the same kind of machine or camera on another population. We all know that AI poorly generalizes to cohorts that it did not learn on.
Okay, just a quick follow-up on that. That's all. I want to be specific on the metrics you used in trying to do the comparison across the three systems in this case.
That wasn't my study.
Okay.
I just had to review some of the work they did, but it wasn't my study.
Oh, okay.
Yeah.
Thank you. So that maybe a follow, but just to the law person, you mentioned that you had to review a lot of frameworks or legal frameworks in Nigeria, and you settled on 6 of them, if I understand. I want to understand what criteria you used in your selection process and how you finalized on those 6.
Okay, thank you. Okay, so initially when we started the study, our goal was to look at the laws that touch on data protection. So what are these laws? So we considered several domains in health, in the finance. So for each of these domains, we looked at the laws, the act establishing some of those agencies, and then we saw that some of these laws talk about data protection. But when then we came back after the first meeting, then we again discussed. Of course, we have several data science experts in the team. So we said that it will be cumbersome to look at all these laws, that we should focus on data science health research. So that was the second criteria that we used to select those laws, the specific ones that touch on data science health research. Thank you.
Good afternoon, this is for Odette. Are you going to have a chance, you gave that great moving example of Ryan, but are you going to be able to look at data on impacts on families, or is this centered in the hospital?
Okay, for this part of the research, we'll be focused on the victims. But another study which we plan to do would be to look at post-trauma among these patients and also among their families, check maybe their quality of life and see how it affects them too. Yeah.
My question for Khadimi is, you talk about the HRD gene. I want to know why you select only breast cancer and prostate cancer, because ovarian cancer, you can find this gene in the advanced stage of ovarian cancer, as well as pancreatic, etc.
So actually, ovarian cancer also was one of the studies that we were going to include in it, because there was one study that one paper we have seen is that there is the correlation between breast, prostate, and ovarian. I mean, if the parent has either prostate or ovarian cancer, the daughter may have breast cancer or ovarian cancer, something like that. So that's why we have taken 3 of them, but here I have include only 2 of them. Yes.
Thanks so much. A round of applause for these early career researchers. All right, we'll go in our quick tea break. Tea break is in the courtyard, but we will convene on schedule again at 11:30. Thanks, everyone. I thought we can do it outside. Hi to the early career researchers. Can we have a group photo in the courtyard, please? The early career researchers, group photo in the courtyard, please.
Testing, testing. Testing, testing. There we go. All right. Thanks.
I think we'll get started in about a minute. People can come in. Call your colleagues, tell them to come in. Okay, well, I think we'll have people rolling in from tea break as we get started, but I don't want to put us even more behind on time. So welcome everyone to the session on opportunities and challenges of the application of AI and machine learning on health data in Africa. Welcome everyone, come on in. So in this session, just like all of the other themes, we'll do things a little bit unique. We'll start off with 2 keynote presentations, looking at broader issues around machine learning and AI in Africa. After those 2 keynote talks, we'll move on to shorter presentations from 3 of the DSI Africa projects. They are 2 of the training programs and 1 of the research hubs. And so just broadly with this theme, we do want to think about the innovations in AI and machine learning, but also discuss the ethics and issues around bias, understand the training needs and capacity building needs in this space, think about challenges, best practices, solutions, and kind of generally talk about how we can move forward in this space. So I think we can get started then with our first keynote speaker is Dr. Skylar Speakman. He leads the AI sciences team at IBM Research Africa, based in Nairobi, Kenya. Skylar will be speaking broadly about his work at IBM Research Africa, but he's also one of the co-investigators on the Mediva project in DSI Africa, and he'll be speaking on trustworthy AI and health discovery. Thank you.
Good morning, everyone. I hope my voice is able to carry on throughout my talk. I was chatting with Brad this morning, said I woke up with a bit of a twinge and wasn't sure if I was going to be able to finish the session. And he graciously volunteered to say that he will come up and recite NIH policy documents if I'm not able to finish the rest of the session. So I hope my voice will save us all from a fate of that. Again, thank you for the introduction and the invitation to be here. I want to start by talking about an amazing team I have based in Nairobi. I can humbly say this is the team you all wish you had. These are invited speakers across the global South, coming from all great places of academia. I want to brag about John on the far left there. About 8 years ago, he joined IBM as an intern, turned engineer. We sent him off to do his PhD at the University of Massachusetts in computer science, and he came back and we hired him full-time as a research scientist this past August. I expect the exact same trajectory for the 2 software engineers also listed up here. So on my very first slide, I actually want to highlight 2 areas that I'm not going to be speaking about today. Responsible AI is incredibly broad, incredibly complex. And I believe actually our second speaker in this session is going to spend more time on the social norms and ideas of AI ethics. Also, we've already heard talks earlier this week on AI governance. Really fascinating topics, but ones I'm not going to be addressing in the next 15 or 20 minutes or so. Rather, I want to talk a bit more about the algorithms themselves and what machine learning algorithms are doing in this space of responsible AI. So if you have questions on the principles, values, and norms, please save those for the second speaker. And I'm going to focus now on the trustworthy ML algorithms. So I have this thesis that I call it, and I don't have data to back it up. I do have 8 years of experience of training machine learning models here on the continent and sitting down with banks and telcos or the Gates Foundations or the NIH And I'm all trying to, tell them, use data science, make data-driven decisions. And it's been rough. Most of these algorithms we generate, they never have that broad of impact. And it's not because a lack of data. It's not because a lack of compute. Both of those have been topics earlier this week. It's not because we don't think Brad gave us quite enough money, and that if we had just a bit more, then AI and machine learning would have broader impact. What I've learned over the last 7 or 8 years working on this is at the end of the day, the decision makers do not trust the machine learning model. They have some very straightforward questions about these models that ultimately hinder the broader impacts. So after a statement like that, a question that comes up is, should decision makers be trusting the data science, the data-driven, the machine learning, the AI, all of those spaces? Should those decision makers be trusting those models? And also on this slide, you can see a great quote by a previous CEO of IBM. Amazing thing about trust is it's so tough to build and so easy to destroy. So what do we now? I'm going to give 2 examples of ways we are trying to build trust into these machine learning algorithms, or more specifically, highlighting some of the danger points for them, because we know trust is so easily destroyed, and the downstream impacts of that is ultimately the machine learning models that are going to be generated by a lot of these projects might not actually see the broader impact. So I just want you guys to really have the take-home message from here. Trustworthy AI, trustworthy machine learning is a very important key component of actually convincing decision makers to put your machine learning practice or your machine learning algorithm into a broader practice. So what are some areas, some blind sides that machine learning data scientists need to understand about their algorithms? Here are 3 examples. Bias and fairness. Is your model making systematic mistakes on some subset of the population? Your overall accuracy might be great. You might have increased on the state of the art by an epsilon. Congratulations. But is your model making systematic mistakes, and are you aware of that? Explainability. Deep neural networks are getting a lot of attention. There's some really cool technology. We're still not 100% sure of the connections that the model is actually making. And I have an example in our slides today to walk you through about why it's important to have some component of model explainability. Uncertainty. Usually your algorithms are going to give you a yes, no outcome, a cat or a dog outcome. They're not inherently designed to say, I don't know. So there's more work in including these algorithms to say, here's some records that could actually use another look by a professional. Unfortunately, the list of trustworthy pitfalls continues on into privacy, into robustness, and into accountability. I'm not speaking about all of those today. I know Laura's probably already looking at her watch, but I do want to go into more detail about 2 of these areas that we've done work at the Africa Lab based in Kenya. Fairness and bias. The point of fairness and bias, from my perspective, also I lead IBM's research within trustworthy AI within fairness and bias. So this is something that I actually do spend a lot of time thinking about. And the takeaway message from this is you need to understand your data and models at the subset level. How do your models predictions differ for men versus women, old versus young, urban versus rural? All of those questions are looking at your data at the subset level. Data practitioners do this already. The problem is there's so many subsets to consider, exponentially many, and you're not going to be able to consider them all. That's where we bring some of our code in and actually try to help data scientists and modelers understand their data at the subset level. An example of this that we completed earlier this year was actually working with the NC3, the National COVID Cohort Collaborative. So they are collecting lots of data across multiple hospitals, and the sample that we used was about 1 million patients in the US, and they had, unfortunately, about a 13% mortality rate. And so this was a project we did with Watson Health, and they said, what can you tell us about these mortality events. And the features that went into the model covered lots of patient demographics and a bit of patient history. And to start very simply, we ran a first order logistic regression model. I love logistic regression. Don't let anyone dog logistic regression. It is absolutely amazing, but you do need to understand some of its weaknesses. One of the questions we asked of this model was, what subset of records is this model the most biased? That is, where is it giving a higher predicted mortality rate than we actually observe in practice? Or in the other direction, where is it saying, actually, we think these outcomes should be okay, but we observe much more mortalities? And even in a simple logistic regression, no covariate shifts, no moving those things around. Even in these examples, bias will come up in your models. And so the subset that answered this question was cancer patients under the age of 50. So even in a very straightforward modeling question, there is going to be a subset of the population where your model did not appropriately predict. Part of our code, I'll get to that the very last slide, finds those subsets. Now, what's going on here is there's an interaction between age and cancer, and our first order logistic regression model did not capture that. It doesn't capture interactions. So the end result of that is a biased subgroup. I want to end on this saying bias is not a 4-letter word, all right? It's not something to be completely avoided at all costs, but it's something that you need to be aware of and understand the limitations of your logistic regression model, not allowing cancer and age to interact. So normally age would be quite a preventative or a protective feature, but cancer and age have an interaction, and that's where we see this group where our logistic regression model is actually off by a factor greater than 2. So unfortunately, patients in this category were more than twice as likely to have a mortality event than predicted by our correctly operating first order logistic regression. It's not all negative. You can also ask the question in the positive direction. Is there a subset of the population that actually had much lower mortality rates than predicted? And this suggests, again, the protective feature interactions. And they were women between the ages of 1849, no diabetes, no cancer. So this is ending this little tale on an optimistic take that, the model can be wrong in both directions. And you just really need to ask that question. Where is my model making these systematic errors, a systematic deviation between what we expect according to the model and what we actually observe? But do not be afraid of bias in that sense. You just really need to be able to understand from that point of view. So bias is one area. I would now want to talk about the second, an example we did. Again, now this one is using healthcare data from the African continent on explainability. So explainability is when someone's going to ask you, great, your model's really accurate. You can report your AUCs, your F1 scores, and you can show that, you can run it in a short amount of time, not high training requirements. But then they'll ask, how is it reaching its conclusions? Some models, such as logistic regression, are more easily interpretable. You can check out the coefficients. You can see what the effect is of age on the predicted probability. In this case, we used a different model, boosted decision trees. I absolutely love boosting decision trees. This data was trained on the demographic and health survey data. So I hope most of you are familiar with the survey data that's collected across multiple African countries. And all of the details in that little blurb right there is just to kind of show you we really tried to do due diligence on this, right? We had correctly separated training and test. We calibrated our model. We optimized for area under the curve. We did all this, all right? Coming back to the explainability question, you're going to see this theme coming up here. What subset of records was the model giving highest predictions to? We can tell you what the overall accuracy of this model was. It was surprisingly high. It was in the 80s for the AUC, if you guys are impressed by any of that. But that wasn't the question that came back from the Gates Foundation. They wanted to know who was vulnerable of experiencing, I don't think I actually said what the outcome was, of experiencing neonatal mortality. So that was the outcome of interest here, is whether or not they had a child that unfortunately passed away. And they really wanted to understand neonatal mortality. So we ran our code on the model. The point of all this is not the model. We are now trying to explain how that model was reaching its conclusions. And this was the subpopulation that came back where our model was saying we are giving the highest predicted probabilities to this group of people. Households of size under three or smaller, a male head of household, and where the mother has had 2 births in the past 5 years. So we sat down with Gates Foundation, maternal newborn child health experts, looking at all of this and trying to figure out. And any thoughts from the room? Are your global health brains churning, trying to figure out why this particular group was vulnerable? This is not a bias question. You can go back to the data, and sure enough, the rates of neonatal mortality for this group are extremely high. So they are recorded in the DHS as a live birth. So that's part of, but you're getting close to it there on that. Yes. Did the mom die? Also, you guys you're getting around the problem very well. The mom is the unit of measurement on this one. So the mom is still alive because that's who we are interviewing on these questions. So the mom is still alive. You guys starting to piece this together? I'll give you a clue, but the lady here is correct. If you have a male head of household, the mom is the unit of measurement, and the mom has had 2 births in the last 5 years. There's supposed to be 4 people in that house. All right. So our model has learned subtraction. All right. We have this, what's also known as label leaking. Yes, it's correct. All right. The model did what we asked it to do. However, it is making connections that we probably didn't really intend it to make in the first place. So now do we go back and use different data, but how complex of a pattern does it have to be before it's learning something novel? And when it's learning what we call label leaking, the outcome of interest, neonatal mortality event, unfortunately found its way back into our data. And we tried to correct for this. There was another features that we were taking out because we knew it would be too obvious and our model would make that connection. We didn't catch this one until after the fact when we applied some of our explainability tools on this model and said, oh, whoops. So we're the point of all these again is coming back to the same question. Should decision makers trust AI models? I'm not going to give you an answer one way or the other. These 2 previous examples should show that I think we still have work to do on this. And this is, again, work being done by some really smart people that know this data very well. But when you take a closer look at this from the lens of bias or fairness or from the lens of model explainability, then you start to even gain more insights about the machine learning models. And there just needs to be this much more healthier dialogue about the real impact that machine learning algorithms can have and really understanding their limitations. And it can be as something as simple as logistic regression does not allow interactions. So you're going to be systematically biased against some group. Or in the other extreme, your boosted decision trees allow interactions all over the place, even the ones you might not want, as the case we saw in the male head of household, mother with 2 child examples. So I want to end this 2/3 or so of the session just to remind ourselves, trust is incredibly important. IBM believes that what's holding back broader impact, whether it's with governments or with industries, is this challenge of trust, whether that's in explainability or robustness. And I don't have time to go into all those other examples that our work has, that we've done some work in. But I think this is such a fascinating topic. And I've given you 2 real world examples of work done on the continent where fairness and bias and explainability have popped up. So I now want to transition to the last third or so of the talk, and wanted to talk about what's the role of data science for discovery. Is anyone here familiar with DALI, caption to picture generator. In fact, I believe some of the artwork for this year's consortium was actually automatically generated as well. So these images over here were generated by an AI. Was it DALL-E specifically? All right. So I typed in data science for health discovery into DALL-E and said, hey, give me some pictures. And here's two of them that came up. I don't know if these are representative or if you think they did a pretty good job. I like them. I think they did okay. But now I want to actually spend the next 10 minutes or so seeing if we can put together an actually much more informative picture of what data science means for discovery. So I've got two axes here, and these were originally taken from a great blog called Simply Statistics. And in the upper right-hand corner, we have the goal. Discovery, we have science, we have progress, we have this great ideal of what the outcomes from something like our DSI projects want to be. All right, so that's where we want to get towards. All right, and it's going to take a combination of having a good question along with evidence and data to support that hypothesis. So that's where we want to end up. We start in the lower left with a mess of data, and at least in the case of Madiva, that's very much where we are right now, this mess of data right here. In the lower left corner, we've got very open-ended questions. We don't quite know necessarily what the best methodology are to use to analyze this, to find evidence. So I propose then that a picture for data science for discovery is this messy process of going from data to science or to discovery. And I know Brad's in the room here, so I straightened out that curve a little bit more than it actually is in practice. I think the real data scientists know I'm missing lots of restarts, lots of completely backward directions here. That's okay, but there is this idea of balancing off strength of evidence and quality of question when you're starting with data. More annotations to this picture. I would say the data scientists in the room, the statisticians, the machine learning people, they really like the idea of finding the pattern, of finding the strength of evidence in the data. Whereas the healthcare researchers here, they want to find a better question. So we're not juxtaposed from each other, but we're not necessarily pushing in the same direction all the time. And I do want to give one example of this where there's this interplay now between data scientists or statisticians wanting to find strength of evidence first and then ask questions later. And I know that's backwards from the typical health research point of view, where I have a question first, now I'm going to go query the data. So here's an example, and it's the last one of my talk today. We actually were coming up with algorithms, and the goal of the algorithm is to maximize evidence. So we are not querying what is the overall mortality rate, if it's a male head of household or not. All right, that would be question first, and then go to check to see if the mortality rate changes between those two groups. Rather, we are saying what subset of the data gives us the most evidence that would allow us to reject the null hypothesis, right? And this is a different question than the typical question-driven research. So this was a data set we got from the knowledge integration team, also from the Gates Foundation. There was about 20,000 births, 20,000 pregnancies and births recorded in Ghana. And they had lots of different features about the mother, about the baby, and they had whether or not a neonatal mortality event was recorded. So again, a nice straightforward data set that had been already cleaned. This was part of the Amani study, if you guys are familiar with the Amani study. Carrying on with this theme of subsets, which subset of the data shows the most evidence of higher neonatal mortality rate? What I want to make sure this question differs from the previous three I've asked, previous two. There's no model here. We are not doing a predictive model to try to train neonatal mortality outcomes on. We are simply asking, find us the subset where observed mortality rates are much higher than the mean. And this was our discovered subpopulation. Home births attended by a medical professional, where the medical professional was either a doctor or a midwife. this subpopulation, while small, were 87 times more likely to experience a neonatal mortality event than the others. An incredibly, incredibly high signal. Now, the foundation and the Amani authors already knew about the risk at home births being higher than hospital births. Right? They knew to be able to ask that question, go check the data. Yes, there's a significant result there. They did not know about this group, but our kind of open-ended question of saying, scan this data, find me a subset where mortality events is really high, and this is the one that came back. This is that maximizing evidence step. It was then followed up by lots of discussions about what's the question that we think this subset is answering. And there's 3 different examples that came up from 3 different points of view. One of them was the data owner from the Gates Foundation. And this one's actually, unfortunately, rather pessimistic. He believes that the at-home mortality rates are actually quite high and they're being underreported unless a medical professional is attending there. So he thinks this is representative of noisy labels. It's a pretty negative take, but that was an interesting question that came from the fact we found this subset. Another one, a clinician, a physician who's been practicing in Africa in MNCH for years, thinks actually there's training differences going on here. You put those exact same medical professionals in a hospital setting, incredibly low neonatal mortality rate. So he was wondering about training scenarios about this. I'm the statistician there at the bottom. I'm the one that's saying correlation is not causation. I believe that there is what we call unknown confounder, something that's going on that's both increasing the rates of neonatal mortality and summoning medical professionals to the delivery. And that's why you see this pattern here in place. I don't have an answer as to which 3 of these is the correct, but these are examples of how the quality of question can change if you're presented with strength of evidence first. And I know from speaking with these people, they would not have asked these questions if the evidence had not been there first. So to come back to here, I do know that this is kind of makes some people uncomfortable to say, no, you're supposed to do science by asking the question first and then going to check to see if you are validated. You're cheating. You are going to see which subset actually would give you the most power to reject the null, and then you're building scenarios around it. Yes, we are. But this is part of that interplay of why I think data science for health discovery is a really interesting topic. And we have to have this combined effort of increasing the quality of questions from health researchers and having algorithms that help find the strength of evidence for those questions, or vice versa, if need to be. So in conclusion, we opened up talking about trustworthy AI, or more specifically, perhaps the lack of trustworthy AI. I've seen this play out many times in my professional life. You will show someone a model that is more accurate, more interpretable, and they'll say, no, sorry, we don't trust it. So these are really fascinating areas to work on in order to increase the downstream impact of machine learning or data science driven methods. And I gave 2 examples of that within fairness and bias and explainability. And then we created this little image here about the interplay between data and health researchers and science. And we have different goals, but hopefully there's going to be nice exchanges on this. And we can both increase the strength of evidence and increase the quality of the question so that we eventually get to discovery and impact. I promised I wouldn't put on my Mediva hat or my IBM hat too much in this talk, but these 3 questions, where do we have model bias? How is the model making its predictions? And even the simpler one of completely regardless of a model, where are our outcomes of interest distributed? These are questions we're going to be asking in Mediva Research Hub, specifically Project 2 in the precision health questions. So watch this space. I think that's going to be some interesting questions or interesting results coming from there. And then finally, I'll put on my IBM hat. These 3 questions are all part of the same set of code that is open sourced and readily available in Python as part of what we call the AI Fairness 360 Hub. So check out AI Fairness 360 or just even AI 360 will get you the links. It's actually a very popular GitHub repo on Python. So the algorithms that drove each one of these questions all publicly available. You guys no longer have any excuse not to be asking some questions about your models. Where is it making mistakes? Who is it giving the highest predicted probabilities to? Or even a more basic question, how are my outcomes of interest distributed across all of these possible subsets? So now I'll take my IBM hat back off and thank you all for your time and attention. And I think I'll be around later on for some more questions, or Laura, if we can take them now. Yeah, all right. I hope one of these is hot.
Yeah, thank you very much. That's a very, very interesting talk. So first, I'll start by giving a comment in terms of this issue of starting from the question and then going to the evidence, vice versa. I'm with you, actually. I think we should start with a very well-defined question first, and then, if possible, collect the data and then test, but using good statistics, not messaging it. But there are some cases where you don't know the answer. You don't know the question because it's a new area, right? So we actually have NIH funding these hypothesis generating studies, right? So they are done for that specific purpose. So I just want to comment on that.
All right.
But coming back to the issue of bias, I think looking at the right subpopulations is very important. But it's not only what you do at the modeling stage. It's actually what kind of data you're going with to begin with, right? So you could have gap in the data, and most of the time the gap is in vulnerable populations. So you're actually using data from other populations to make predictions about, and it's going to be wrong, right? And then the other one, and then the other one is actually you will have more likely messy data in vulnerable populations. So when you use things like logistic regression, if you have misclassification, obviously it's going to give you bias. Of course, you can use a better model, like hidden Markov models or something like that. But still, you're dealing with handicap when it comes to the populations that you really care about. So I think the input is also as important as the modeling state as well, whether you're doing predictive modeling or strength of evidence. So I don't know, what are your thoughts on that?
I would just say on the importance of the input going at this, the way we treat this, some people would call them the features or the covariates. We would also call that, now we would say, our search space. And you are completely correct that this type of search space is going to be limited by, do you have accurate age, gender, demographics, health histories on that? I think an interesting approach of this idea of maximizing evidence, you can put in more features in that search space than you would if you were training a model. If you were training a model, then I think you really have to think more about the features that go into that. If your goal is maximizing evidence, I tend to, I don't know if Scott is in the room, he knows this, I would say put more features into the potential search space because we're not necessarily doing a modeling step yet. So in that regard, I would say I would tend to more than less if you're doing this search goal. The second comment was about data hypothesis generation. And to a slightly different audience, I would definitely pitch this all as data-driven hypothesis generation. That's what this idea of the exchange between maximizing evidence. First, I would say we do have one question before the maximizing evidence, and that is, what's your outcome of interest? So in all of these questions, we had to say, neonatal mortality, that's our outcome of interest. So that's kind of that first question. Then the follow-up is, where is neonatal mortality events most highly distributed if your search space is all of these possible subsets? So there is that tiny little question before where you know your outcome of interest. And unfortunately, I don't know if the data scientist would be able to inform what that outcome of interest should be. Once that outcome of interest is defined, then you can come back to some of these tools. So there is still, maybe the first mover is still the health researcher who says, hospital mortality of COVID, that's my outcome of interest. Now go find a pattern for it. Okay. All right.
We'll have some more time for questions in the panel discussion after all of our speakers. So our next talk is quite complimentary. We'll be hearing from Dr. Kamanthri Moodley, a distinguished professor in the Department of Medicine and director of the Center for Medical Ethics and Law, Faculty of Health Sciences at Stellenbosch University. Kamanthri is also a PI of the Research for Ethical Data Science in Southern Africa, DSI Africa project, and she'll be speaking about balancing the harms and benefits of AI ethical considerations. Thank you.
Thank you for the introduction, Laura. Thank you to the NIH for funding this huge project, DSI Africa Consortium. And thank you to the organizers at the Coordinating Center for arranging this event. It's for those of you not from Cape Town, venues, hotels, etc. are in short supply at this time of year. And so I can only imagine how difficult it must have been to put together this event for such a large group of people. I'm the PI of the REDSA project, and we are looking at ethical, legal, and social issues related to data science and AI. And if you haven't seen our poster already, please have a look, and it's presented in much more detail. I'm not going to focus on the project now, but rather address the issue of harms and benefits related to AI. And to my previous speaker, Skylar, sorry, but bias is going to be a four-letter word in this presentation. Yeah. So I thought I'd start off with something that we're all familiar with. We have experienced the pandemic over the past few years. And one aspect that was really critical globally was how we would fairly allocate limited ICU beds to patients with severe COVID-19. Now, in South Africa, many other countries in sub-Saharan Africa and in low and middle income countries, triage decisions are an everyday event. We were all trained as medical students to be familiar with triage. When I worked as a family physician, I had to be involved in triage myself on a daily basis because we have an unfortunate ratio of healthcare providers to patients in this country, many other low-income settings. There were times in many hospitals prior to the pandemic where there would only be 6 ICU beds. Worse still, in rural areas, maybe 1 or 2 ICU beds if we were lucky. In Cape Town during the pandemic, our ICU bed number did increase substantially. Our academic hospital was the primary COVID ICU for the region and for the country. And so we had a slight increase in the number of beds, which helped a lot. Despite this, there had to be triage frameworks in place, and people struggled. It was highly controversial because frameworks were developed in high-income countries and imported into low and middle-income country settings where they were not always completely relevant and could not take the context into account adequately. And so from an academic perspective, lots of debates emerged around how this critical care triaging should occur. A number of factors were used. There were SOFA scores and frailty scores, etc., that were added manually. People did this in a rudimentary type of way. However, what had been happening in some other parts of the world is that there was development of a triage tool using machine learning. And this particular piece in Nature explains in great detail how using CatBoost Python, a model was developed to assist with triaging. And the intention was to reduce mistriage, because often we know that people who ought to be admitted into an ICU may not be because of errors. And the intention in the development of this algorithm was to attempt to reduce the rate at which mistriage occurred. And they used data, large data sets. So they had about 140,000 patients visiting the the emergency department every year. And using 8 years of data, they were able to develop and train a model in terms of assisting with selection of patients for ICUs. Now, in this model, these models are always controversial because there are a number of objective factors that are taken into account when we triage, but also a number of subjective factors, including the clinician's experience, knowledge of the patient from prior visits, etc. So when we think about, the ideal way of triaging, it often has to involve a combination of objective and subjective factors. However, in this particular model, a number of important objective factors were taken into account that are not necessarily always taken into account in traditional triage models. And these included factors like the time of arrival of the patient in the hospital, the mode of transport used to reach the hospital. And here where patients arrive at night or arrive in an ambulance, they are more seriously ill and they are at higher risk. Also interesting was the concept around age. So lots of debates occurred during the pandemic about what is that cutoff age going to be over which we will not admit patients into an ICU. And when we work with age, we often use it as a very blunt instrument. So we might decide arbitrarily to say anyone over 70 will not be admitted to this ICU, depending how dire the situation is, anybody over 60. But when we use age in that way, we risk losing the 66-year-old person where the cutoff is 65, who has very good health and an excellent prognosis and would do as well as the 64-year-old that we would have admitted to an ICU. So using age as a continuous variable takes this factor away and makes it more accurate. Also very important was taking into consideration the sex of the patient. And often this is not factored into decision-making in healthcare. So female patients as opposed to male patients and building this into the algorithm as well. What was the outcome of all of this study? So the researchers report that they were able to reduce the mistriage rate from 1.12% to 0.9%. It might sound like a small difference, but they report it as being a significant difference, because if you take into account the fact that 140,000 patients are presenting to an emergency department in a year, and that they have to be triaged, you would end up saving around maybe 200 to 300 more people per year. Now, how we value and quantify that difference depends on different contexts. Suffice it to say that the method that they propose was more efficient than the traditional triage method. Now, I don't think anyone doubts that AI has the potential to substantially improve healthcare and quality of care at health institutions. And this has been adopted since 2015. Changi Hospital in Singapore has got robots in use for delivery of meals, delivery of drugs, etc. And these are the hospitals of the future. I think for us in sub-Saharan Africa, we don't really see this yet to this extent, but this is the world that we are going to find ourselves in the future. Now, apart from critical care decision-making, we know that AI has been instrumental in improving diagnostics in a number of other fields in healthcare, usually the visual field. So dermatology was the first one where Stanford University published their research in Nature in 2017. They used a database with 130,000 images of 2,000 different skin diseases and compared it to the diagnosis reached by 21 dermatologists and found the AI tool, the app, to be superior. Likewise, in the field of radiology, similar examples abound in the literature where diagnostic precision of an AI tool exceeds that of a human radiologist. In the field of rheumatology, we know that a large portion of the management of a patient is patient education and encouraging patients to manage themselves. Here, the use of chatbots is an important advance in assisting in the management of patients where doctors themselves do not have sufficient time to engage with patients and to give proper patient education. When I worked as a family physician, I remembered that I was told I had to see every patient in 7 minutes and no longer. And I can only imagine how much it helps the clinician to have another mode of communication to use when dealing with or trying to manage patients with chronic diseases that require a great deal of interaction. Now, in the healthcare setting, much has been done to develop codes of conduct for digital and data-driven health technologies. The UK National Health Service has developed their code of conduct. And all of this is because there is a concern with respect to governance, ethics, and legal issues. The important question that we have to ask ourselves, though, is, in terms of benefit, is does AI drastically improve diagnosis and treatment? So we have many examples where it does, but there may be some situations where the benefit is marginal. And this is an important consideration as well. So at Tygerberg Hospital, which is our academic hospital, we've recently introduced the Da Vinci robot, and a number of surgical procedures are now being conducted using robotic technology. And it has its advantages and its disadvantages as well. So the surgeons are really very pleased and, in fact, amazed at the detail they get to see when using robotic surgery. And for colorectal surgery, prostate surgery, this is sometimes quite important to quality of life of the patient after the surgery. Cutting specific nerves can result in erectile dysfunction, inability for patients to have a full use of their bladders, etc. And saving patients from those side effects is an important advantage of robotic surgery. But on the other hand, endoscopic surgery, having humans conduct the surgery, has a whole range of other benefits to it as well. And one has to calculate the marginal benefit of introducing AI technology in all of these scenarios. Now, an important concept to consider when we look at harm, benefit, and the ethics in general is a concept referred to as ethical debt. And this is the accumulated harm or the accumulated debt that occurs from an ethics perspective if we fail to take ethical considerations into account from the get-go. So right at the design phase of a project, we need to take all our ethical concerns into account. And this is why the DSI Africa project is so important, in that the LC groups were included from the get-go. Now, this ethical debt concept is often compared and contrasted with another concept called technical debt. And I think maybe Skylar, IBM, other industry partners will be familiar with this term, where industry or corporates decide in advance that they know the technology is not yet fully developed and perfect, but they are going to release it anyway, and they will fix the problems that arise in time to come. Now, important publications have appeared in recent times looking at the concepts of ethical tech, ethical debt, etc., technical debt. And I think much of this also arose during the pandemic, when all of us were busy on using online platforms for communication, and we were familiar with episodes of Zoom bombing that occurred during these sessions, where sometimes sexist language, racist language, or pornography, invaded our academic discussions. And the interesting comment made by the CEO of Zoom at the time was that the risks, the misuse, we never thought about that. So when the Zoom platform was developed, the risk of Zoom bombing was not anticipated. However, the harm caused was substantial. And although they have made significant efforts to reduce this and increased security, etc., this is an example that is widely quoted as being an issue of technical debt. Now, with ethical debt, we know this accumulates over time. And what is interesting and important to consider here is how debt, the ethical debt accumulates and who stands to lose the most. So the metaphorical debt collector often comes after the harm is inflicted. And this is why it's so important to prevent the harm up front. This interesting paper by Catherine Petrosino speaks in much detail about who pays for the ethical debt in AI. And she argues that the misalignment between who incurs the debt and who ultimately pays for it is substantial. Often big corporates are incurring the debt, and it is the patient or specific categories of patients. For example, if Black patients are disadvantaged in terms of healthcare provision or healthcare services as a result of AI tools, then that entire category of patient base pays the price for the technical debt as well as the ethical debt. Another COVID example, I'm sure we were all familiar during this pandemic that when we used our pulse oximeters in our homes to check our oxygen saturation levels, we felt quite empowered and we felt at ease, and we knew that if our levels dropped, we needed to seek healthcare. I think the sad outcome of the pulse oximeter was that for people with skin color that was darker, it was not as accurate as it should have been. In other words, it underestimated the degree of oxygen deprivation in a darker skin. So patients who would have needed to present themselves to a hospital earlier may not have done so because they were misled by the pulse oximeter reading. And this is a very, very important consequence when biased data is used in algorithmic models and in the development of health technology. Now, an absolutely fascinating book and highly recommended to all of us in DSI African Consortium is this particular publication by Caroline Criado Perez, who writes eloquently about the bias that exists in big data. She discusses this across various different aspects of our daily lives. And as women, we all know how we struggle with car manufacturer design, seat belts that never fit us properly, other safety issues in terms of a design that significantly disempowers women. And in addition to this, there's a whole chapter dealing with health bias and how little attention is paid to the different physiological impacts with respect to health research. And in our global population of 7.7 billion approximately, there are more than 50% women, yet these are the women that are often invisible in general, but also in health sciences. If we go back to the NIH itself, and many of you will be familiar with this, it was only in the 1990s that the NIH put out a call for inclusion of women and minorities as subjects in clinical research based on the NIH Revitalization Act. And so if we look back at all our clinical trial data that exists prior to 1993, we should be rather concerned about the representation of women in clinical trials and in research. Interestingly, where drug responses are concerned, many scientific studies have been performed using male participants. And the results have been considered valid for women, assuming that gender did not affect the outcome. And this is something referred to as the Yentl syndrome. Now, in a publication by Loretta et al. In 2017, she summarizes her eloquent article by highlighting some of the differences that we need to take into account where human physiology and pathophysiology are concerned. We know that sex hormones play a pivotal role in explaining gender differences. The endocrine system in particularly is deeply affected by sex hormones. And we need to ensure that all these factors are taken into account to explain prevalence and severity of disease. Gender-related physiology may explain the different effects of a therapy which induce different therapeutic results in women compared to men. And this applies very significantly to the way in which adverse events to a whole range of drugs are experienced by women. Now, cognizant of the many ethical debates around AI, the World Health Organization developed a guidance looking at ethics and governance specifically for AI in health. And they have come up with a number of principles. I'm sure many of you are familiar with these. And they range from protecting human autonomy. And we know that this is a very important part of healthcare in general. Aspects like consent and confidentiality are part and parcel of healthcare. And we know that data from electronic health records and research projects are used to develop algorithms for AI in health. And so important in that when we are collecting data from patients. Yesterday, we had a number of discussions around the use of electronic health records from the UK Biobank perspective, but also in the Western Cape province of South Africa, we have a data center. And the data has been made available. It's collected in a de-identified format. It is available to researchers. But the concerning aspect of this data center is that patients whose data sits there are not aware that the data was collected for the purpose of future research. And that's a really important consideration. Of course, safety is another very important principle. And so the importance of ensuring that any AI tool that is developed will not cause harm or will minimize harm in the risk-benefit ratio is part of what we refer to as non-maleficence in the ethics world. And so that is a really important principle. You have heard a little bit from Skylar about explainability, and you will hear that in other AI talks as well. Transparency, intelligibility, these are all the issues that are also related to the black box phenomenon in AI. And so the incredible importance of being able to engage with the public, engage with patients to explain how and when their health data will be used. And this requires a considerable amount of public consultation and debate. Of course, responsibility and accountability are part and parcel of any technological development, and all developers of AI need to be held accountable for negative impacts. I did say I would not touch on the law. We did a whole session on this last week when we ran a seminar series on AI and big data. And our legal team in the RETSA group presented a wonderful session on all the legal implications. But I think accountability is really important. In South Africa, we have the Consumer Protection Act, which holds all parties in the supply chain network responsible for anything that goes wrong in healthcare. And so where developers are concerned, this really needs to be taken into account quite seriously. Of course, inclusiveness and equity is absolutely critical. And from the WHO perspective, they acknowledge the digital divide between high and low income settings and mention very specifically the aspect of bias, which I've already touched on considerably. But benefit sharing in big data research and AI is really important because it corrects inequity. So in South Africa, benefit sharing is not illegal and it is not criminal. When we enroll patients or participants in research, they are remunerated for their time, inconvenience, and that they spend at the research site. No research participant is paid to take part in research. No person may sell their tissues, cells, or organs in South Africa. That is clearly unethical. But when research is conducted, there should be benefit sharing agreements in place. And this is very well described in the SAN Code of Ethics, where the San people, who are the original peoples in this part of the world, expect that there will be a benefit sharing arrangement or agreement put in place before research even commences. And one has to approach the San Council to discuss how this will be effected. It is not necessarily the exchange of money, but may be in the form of resources that are made available to a specific community, academic bursaries and scholarships for people who are less advantaged in those particular communities, but a whole range of benefits that need to be discussed in advance, because at the end of the day, especially where corporate role players are involved and profits are to be made in the future, local participants and patients will object very strongly to not receiving any form of benefit from their data, their samples, being participants in research, etc. And it is based on principles of reciprocity that are important to consider in all the research that we do. Of course, AI that is developed should be responsible and sustainable. And we have to take into account impact on climate change, which of course I'm sure other groups are working on. Now, most recently, the United States government released the AI Bill of Rights. And similar to the WHO guidelines, they discuss a number of important principles. These 5 are the particular principles that are stressed. And you will notice considerable overlap in the WHO guidelines and in the AI Bill of Rights. What is really important here, though, is that they stress the importance of human alternatives. So we know that when we work in the field of AI, there are going to be patients who will be early adopters and will be thrilled to have robotic surgery and any other important new technology. But there will also be patients who prefer human doctors, human touch, and their trust relationship with their original service providers. And in that particular case, this option should always be made available. This is also important when we consider the aspect of automation bias, because there are some AI technologies that are developed to augment or assist human clinicians and surgeons, etc. But when those technologies start making decisions on their own without human input, then the risk of automation bias becomes serious. So we've discussed a number of these principles already, and I'm not going to go through them in detail again. Suffice it to say that these principles are important and need to be integrated in any AI development projects, and that this should occur early. Now, this is a really important quote where data is described as the oxygen on which AI depends. And regrettably, it is inculcated with decades of discriminatory behavior that is both implicit and explicit. And yesterday, this particular article was released on looking at trust. So we've heard a lot about trust, but this particular publication argues that reliance is more important than trust. So before we can build trust with research populations or with patients, we need to ensure that the AI technology is well tested and tried, like we do with other devices and like we do with drugs or other interventions. So this piece calls on developers of AI and others to ensure that new AI technologies are also subjected to clinical trials, and that we work from the basis of evidence-based medicine approaches where AI is concerned as well. And the author argues that trust is just not enough. We cannot coax people into trusting us. We cannot engage with them superficially by giving them information, but rather we have to be co-creators of our developments and engage the public and engage people at an early stage so that they own the process as much as we do. And so this really makes for very, very interesting reading. To end off, this is a beautiful piece of art, sadly not created by humans, but by AI technology alone. And while it's really wonderful, and imagine how quickly we'd have beautiful works of art, there would be the downside of the human touch where art is concerned, and the technique and the skill that goes into producing excellent pieces of art. On this note, I want to thank you for your attention, and I'm happy to take questions.
Just one question for Cantor before we move on.
Hello. Okay, thank you very much for the talk. I just have one concern here. You say in an example that radiologists using AI was far better for MD. But what's normally expected? Is it a desired result for the AI? Because for me, it will not be desirable that AI perform better than radiologists. Maybe for me, if it's the case, it may be that something may be wrong. So I will expect that this be as better than medical, but not it outperform this.
Yeah, I think there is enough evidence to show that in some cases, AI outperforms humans. Remember, humans are prone to error, and it's what the human eye can see and detect. I think the most critical example is if we look at robotic surgery, and if you see the difference of what the human eye can see when a surgeon is operating, as opposed to what a robotic surgical tool can see, and the importance of the additional information that comes from having a robotic intervention. So I'm not saying that robotics and AI are foolproof and always better than humans, but the risk of some adverse events is lower with AI technologies. And as things stand, technology is not replacing human healthcare practitioners or surgeons, but it is augmenting the work of healthcare professionals.
So we'll move on to the next portion of our session today. We'll hear from 3 of our DSI Africa research projects to discuss both their projects and how some of the themes from today incorporate and are related to the work that's being done. So our first speaker is Dr. Kiros Berhane, the Cynthia and Robert Citron, Roslyn, and Leslie Goldstein Professor and Chair of the Department of Biostatistics, the Mailman School of Public Health. He is one of the PIs of the Advancing Public Health Research in Eastern Africa through Data Science Training, or AFRIA DST program in DSI Africa. Thank you.
Thanks, Laura. I think it's a good afternoon now, I guess. So I'm going to be very brief, just to describe what the project is all about. So AFRIA DST, as Laura said, is advancing public health research in Eastern Africa through data science training. It's one of the 6 or 7 training grants under the DSI Africa framework. So the project structure is as described on this slide. It's a collaboration between Columbia University, where I'm based, and also Addis Ababa University in Ethiopia, and University of Nairobi in Kenya. Within each institution, we have multiple stakeholders and partners, which is typical for data science because it's truly transdisciplinary. At Columbia, the project is based in the Department of Biostatistics, but in collaboration in the School of Public Health with environmental health sciences, epidemiology, and the ICAP at Columbia program, which brings in health systems into the picture, and the Columbia Data Science Institute, the School of Engineering from Computer Science and other units, Department of Statistics, and the Lamont Doherty Health Observatory. From University of Nairobi, again, we have a very similar structure. The project is based in the School of Mathematics, where the Department of Statistics is based, where Professor Patrick Weke, who is in the audience, actually is a PI for Kenya, again, in collaboration with the School of Public Health and the School of Informatics and Computing. And then the third partnership is from Addis Ababa University, where again, we have very similar structure. The project is based in the School of Information Science, where the country PI, Dr. Rahel Bekele, is actually the PI, also in the audience today, in collaboration with the School of Public Health and in the Department of Statistics. And of course, we have number of stakeholders, both governmental ministries, which are going to be the eventual employers of our trainees, and also non-governmental partnerships from industry and private sector. In fact, IBM Africa, IBM Research is actually a partner, and other private sectors, and then other academic institutions like KEMRI in Kenya, for instance. You have already heard from one of our faculty scholars and investigators, Wondosen, and of course, our fearless project director is in front of me, also comes from the Columbia Data Science Institute. And we have a training advisory committee that comes from all institutions, but also covers the wide, spectrum of skills that we need, in addition to our, scientific director from NIH. So just briefly to walk you through what the project is all about. We have 7 aims. The flagship aim is actually the development of new degree program in public health data science, focusing on the master's program. In addition to that, in aim 2, we have faculty development, and we have cohorts of faculty scholars that are, selected carefully, both from the team, but also from across the board in each of the 3, in each of the 2 countries. And it's a year-long mentorship program that also continues through the life of the project, but in a way that's actually progressively owned by Kenya and Ethiopia, because the first cohort has Colombia-based mentors, but as we go to the second and third cohort, we have actually co-mentorship, and the mentorship itself is actually kind of transformed fully into the. Then we have a bunch of short-term training programs, both development of well-done degree programs, training modules that are strategically selected, but also typical short-term training, both in the hybrid model and in the in-person model. And then, of course, one of the flagship, features of our project is that, the MS students are supposed to have practicum projects. And what we have done for that is we created partnerships with already existing projects like a GeoHealth Hub, which focus on climate change and environmental issues, which I'm also a PI on. And then we have, the Maya satellite project, which generates huge amount of data, including some in Africa, where it's a very fertile ground for actually data science immersion, and many other projects, including ICAP, which brings health systems into the picture. So we are actually infusing and empowering the students from the get-go in actually dealing with real data problems, real issues that they have to solve. And as I said earlier, we work with stakeholders. And finally, I think the idea is to have impact in a real sense, to build capacity, to create sustainable programs, and also to, at the end of the day, do better public health science and better public health practice, and of course, better understanding of impactful science. So in a nutshell, that's basically the program. At the end of the years, we will have potentially a PhD program or regional extension, and of course, there will be monitoring and evaluation across the board. So very quickly, I have already talked to you about all these issues in terms of what the programs is all about, and the milestones are being achieved. And if you want to hear more, actually, we have a poster that has been displayed for the last 2 days. So before we take it off, go and check it out and learn about the year 1 milestones. But I think, we're off to a good start. And as we speak now, actually, Kenya is going to start the first cohort of MS trainees with the curriculum fully developed. And our first cohort of mentors of Hub scholars have already, done almost a year program, including a visit to Colombia, and many immersion opportunities, through online programs. So that's essentially, kind of the summary of what the project is all about. So very quickly going to AI and ML on health data in Africa, as it relates generally, but as it relates to our project as well. So what are the opportunities and challenges and that we can think of? Obviously, I think many people have already said this: unprecedented abundance of increasingly complex and voluminous data across many domains of health and determinants of health. So the challenge is, of course, data are not always consistently collected, stored, and shared in ways that could be accessed and utilized by researchers and stakeholders. And we have already talked about the potential for bias from the previous two speakers. And then the opportunities to develop data partnerships and collaborating within DSI network can ease access to this kind of data. Challenge, building trust, maintaining privacy, ensuring ethical and legal practices within data partnerships. This requires structures and foresight. Again, we have heard in ample way actually from the previous speakers. We can benefit from expertise within the DSI network and approach gaps as an opportunity for targeted training and impact. Again, informed practice of machine learning and data science techniques, but in a way that's actually infused and intertwined with what our end goal is. Data scientists could play a very transformative role in exploiting big data revolution in order to really address and solve multi-pronged health challenge in Africa, and especially in Africa. I think the gap in data, but also the disparity in quality of data, especially when global models are being produced, is actually huge. So we really have to be careful, not only in doing the right modeling, but also collecting the right amount of data and filling the gaps, both in terms of information and capacity, human both and physical as well. And then, of course, we are establishing multi-tiered training programs in public health data science, building on well-established partnerships and models so that we can build on success. So the last thing in terms of challenge and opportunity I would like to say is building sustainable cross-disciplinary programs requires institutional flexibility and collaboration. This is very important, and the program has to be designed in such a way that it will actually live beyond hopefully actually DSI Africa will live forever and will have 20, 30 years of funding, but at some point it will stop, right? So I think, at the end of the day, we have to make sure that what we build collectively is sustainable, so that it's owned and there is a buy-in from the home institutions themselves. Of course, our committed team is able to build enthusiasm and institutional consensus to pave a path forward, again, to create, buy-in. So finally, of course, this is a great opportunity to collaborate, and our website is here, but happy to talk to anyone when we get a chance. Thank you.
So moving on to our next DSI Africa project, we'll hear from Dr. Joyce Nabende. She'll be Joyce is a lecturer in the Department of Computer Science at Makerere University, where she heads the Artificial Intelligence Lab, and she'll be representing the MacData training program. Thank you.
Yeah, thanks, Laura, for the introduction. Hi, everyone. I hope this can. Oh, okay. Yeah, so I'll be talking about the MacData program, which is the Makerere University Data Science Research Training Program to strengthen evidence-based health innovation, intervention, and policy. So our program is run jointly with the Johns Hopkins University, the PIs, Dr. Katete and Professor Jolova, and Dr. William Checkley, and the rest of the other team. So it's a program that's run jointly with the College of Health Sciences in Makerere University and the College of Computer Science, Computing and Information Sciences, where we come from as well. Our project goals are to establish data science research capacity at Makerere University with focus on major infectious diseases like HIV, TB, malaria, and epidemics with pandemic potential. I think you all know that right now we have Ebola as one of the pandemics that we have in Uganda. And so when we wrote it, of course, we didn't know about Ebola, but it really fits well with the new pandemics that keep coming up in our country. And so we're focusing on training with impact on interdisciplinary skills that allow data science applications to problems beyond the scientific focus that we have in our program. Our objectives, of course, is to establish higher degree training, both on MSc and PhD in health data science. So just to say, in the College of Computing, we have the computer science program, a master's in computer science, where we've been focusing on AI and data science as one of the tracks, but that wasn't specifically for health data science, and we're doing different applications. But with this particular program, we want to enhance what is already existing in Makerere University as a very good opportunity for us to grow the use of data science and machine learning, particularly in health. We also want to provide postdoctoral training that will enable Ugandan H3 Africa alumni to transition into faculty. Makerere University also got funding previously where we've been implementing a bioinformatics program in the College of Health Sciences, and we also are leveraging that as a very good opportunity within the DSI Africa Consortium to be able to train postdocs and move them forward into faculty. And then train the already existing Makerere faculty and equip them with capabilities for data science, research, and mentorship, because we believe that this really should be multidisciplinary and we shouldn't just leave AI and machine learning only for the computing people, but there should be that multidisciplinary approach to training and research. I think this just summarizes what we've managed to do in year one, and I will probably just skip over this for time. So in terms of the training for MSc program, that's like a very important thing for us. Sometimes reviewing curricula can take up a long time. And so instead of coming up with a new course, we decided to leverage the already existing bioinformatics program and then focus on introducing a new track on health data science, because that goes a little bit faster in terms of curriculum review. And a good opportunity here is that we already have the program that's existing. We have data sets that have been produced out of the H3 Africa program that now we can leverage and work with for our MSc trainees. And in the health data science program, we've now introduced a track that focuses on, in the bioinformatics program, we've introduced a track that's specifically for health data science. And many of the things that have been spoken about here are very key to us as we design our curricula. For example, focusing on ethics and fair principles, data management. These are very good things. And I think this meeting has really helped us. And we can use this also as a very good opportunity to take these things in and put them in our curricula as we revise. We are also very keen on the industry attachment as one of the things that we have in our curricula, where we want to have people coming in and enrolling on the program, but these people are probably placed somewhere where they're working. For example, in UVRI, which is the Uganda Virus Research Institute, and you have a trainee from that place, then it's very easy for them to be able to leverage the data that is existing within their workplace as they try and do their research. And we are equipping them to use machine learning and AI with the data sets that they have. And this is a good opportunity, I think, for us. One of the challenges is that we have the data. Data is not exactly findable. You can't know who's working on that. And we think that through this program that we can try to start to build a data repository within Uganda and have data sets that can be openly used by other trainees as we go along. We have our PhD students that have been enrolled on the program who are very keen. So we kind of divided our cohorts to have two trainees. We started with a health background. And then in the next round of the PhD advertisement, we'll focus on people with a computing and a statistics background, because we want to make sure that we train both kinds of people on our program. So we have Magdalene and Shahid. I won't go into details of their work, but it's expected that they will, start off their journey. They've already started off, and they will go to Johns Hopkins early next year, where they'll be able to continue working. And because their background is in health and not necessarily machine learning, so we feel that this training opportunity will, enhance their skills in machine learning and AI, and the collaboration we have with JHU will also help us to be able to achieve that and transfer skills when they come back to Uganda. So they're going going to leverage data sets that we have in the country, clinical, demographic data around malaria, which is Magdalene's work. And then for Shahid, it's around molecular data that we have access to through one of the PIs on the project. We're also supporting master's trainees who are going to do their research in health data science in the second year of their research. They focus on doing a research project, and we want to ensure that we can be able to support them to do their current research in health data science. So as a way forward, and what we think are, our take homes, thinking about the whole program, is that we are ensuring that with Mac Data, we've established multidisciplinary research teams at Makerere University. Sometimes in Makerere, we tend to work in silos. The computing will go alone, health will go alone. But we think that this multidisciplinary team that we have formed, and with the Mac Data program, it's enabling us, to work together as a university, such that we can leverage on our skills. Sometimes when I'm in computing, I'm like, oh, I have these ideas. I can do machine learning. Where do I get the data from? Who do I know in the College of Health Sciences? But right now, I can easily answer that question. And I think that this DSI program is one of the things that we can leverage to remove all the barriers that we have at the university. And this will likely impact Makerere University's research culture and training in harnessing data science for health, and also strengthening the partnerships for training and research. And there are many things, of course, around curriculum harmonization that we are trying to work on as we incorporate the health data science aspect into our program. Yeah, thank you.
So our final speaker for this session is Dr. Sibu Makanya, who's a research scientist and manager at IBM Research Africa in Johannesburg, where she manages teams in applied artificial intelligence. Sibu is a co-investigator on developing data science solutions to mitigate the health impacts of climate change in Africa, or the HEAT Center.
Okay, cool. Thanks, Laura. In my culture, you never stand between a man and his lunch, so I'll try and be brief. So we have a pretty cool acronym, the HEAT Center. This really represents a transdisciplinary team of researchers, both from health sciences, computer science, and some of the more mathematical sciences, all banding together to try and develop solutions, looking at problems at the nexus of climate and health. We are focusing for now at the impact of heat on health. Well, I'll get into more details what specific health outcomes we're looking at. So this is just briefly describing some of the aims of the HEAT Center. So we do want to develop this ecosystem and platforms that support analysis, where you are fusing existing environmental and climate data together with the data sets that you get on the health side. Specifically, in our core focus at the moment is leveraging existing clinical trials and cohort data sets. We do hope and have the greatest of intention to really become and serve as a continental resource when it comes to looking at the impacts of climate and environmental and the environment on health. Now, this just takes you, just briefly describing the structure, the technical structure of the HEAT Center. We have, as many of the other research hubs, a data management and analysis core. This is formed by a strong partnership between UCT, the Climate Systems and Analysis Group, who come with their tools in the form of high performance computing and some of the skills around the climate sciences, together with IBM, where we're also leveraging some of our own geospatial data management tools and the data for the purpose of this particular project. Now, some of the, we're not only looking at, as a DMAC, just the curation and management of data, but we're also helping support the two core research projects in terms of developing some of the data analysis and data analysis workflows. So some of the things that we're looking at, for example, are from the climate side, we're looking at aspects around subseasonal to seasonal machine learning, applying that specifically to outputs of numerical weather predictions to improve the skill, because we know that there is the space between what the numerical weather prediction models produce and what the climate models can do, that we have a bit of a loss in skill that can be addressed by leveraging some of the machine learning tools. And specifically also when you want to move from your raw kind of like your temperature information, for example, to some indices that communicate heat hazards, we want to leverage some of the machine learning tools to do that kind of work. The two core research projects, the first one is focused more on the impacts of heat on maternal and child health outcomes. And that is a huge exercise because we are basing this on what is called an individual participant data meta-analysis approach, which means we are collating data sets, existing clinical trial and cohort data sets from all over the continent that had been done between 2010 and also the studies have been published between 2010 and 2022. And we want to fuse that together with some of the existing climate and environmental data sets, which we also know are also pretty large. What is cool about the DMAC structure is that through use of tools, I know there was an earlier question on linking together of geospatial infrastructure because you can't possibly be moving such large data sets. We are using APIs. We're also developing tools that then allows the data scientists who are using or want to kind of check, what kind of data sets are available that allows easy visualization of the data that we have in climate and in health. And so those are part of the tools that we'll be leveraging as we get some of the data sets that we'll be getting in the IPD and starting to think about some of those hypotheses that we want to test. And then in the second project, the focus is more around heat health prediction modeling because the whole aim is to develop an early warning system that could be used in the context of African cities. And I'll show a picture that might speak to why exactly the focus on African cities. I won't go through this, but this just shows on the right, just a picture of the Jupyter Hub environment where data scientists can go in and just through code, using the relevant API keys, can be able to access data that is available through CSAG or through the IBM Pairs platform. I think what is great about the DMAC is obviously this facilitation of collaboration between parties that are sitting, on various parts of the continent and even globally. And a lot of the work that we're actually doing at the moment is just around curation of data and pre-processing. And those amongst us who are familiar with data science and statistical sciences and so forth would know that 90% of your effort is just around data curation and preparation. And then the fun part is only 10% of the job. So this just gives you an idea of the distribution of the studies that were identified to be relevant for the IPD. So you would see that in the north of Africa, we actually haven't identified studies that fit the criteria that we had set. But the good news is we have more than 240 studies that have been identified, looking at more than 1.4 million women, collecting repeated measure. So you can imagine each individual woman would have a series of time points for which data has been collected. And the coverage is that we have coverage over 33 sub-Saharan African countries. There is actually a poster that was prepared by my collaborators led by Ijoma. So if you haven't had a look at that poster, she's also got a QR code that gives you more information about just basically some descriptive information about these studies that have been gathered already, or the data that has been identified. Now the IPD, because we are looking to fuse basically existing health data together with your environmental and climate data, there's actually a lot of effort that would go into just processing the climate and the environmental data to a point where it is, possible to then link it up with the health data to form that data frame from which the analysis can take place. So there's a lot of effort. Skylar spoke about, identifying subpopulation. The same thing when you have environmental and you have climate data, you also want to identify, certain regions that might be of interest, particularly regions where you might have low vegetation cover, regions where you might have density in terms of building coverage and so forth. So a lot of processing would go into this, and a lot of what we call feature engineering, but basically it's just coming up with the predictor variables that you'd want to use in your model. So I said I would come back on why African cities. So this is an area at the nexus between Alexandra, which is a township, densely informal settlement in Johannesburg, and Sandton on the right. You can see that in Sandton, you actually have a lot of vegetation cover. You also have a bit more space between housing because it is planned houses. Whereas on the right, you have the informal settlement where you have much more dense, and also the type of materials being used there are not really friendly when you start having a heat event. So it's corrugated iron, most of the shacks, and you can imagine what happens when you reach temperatures above 30 degrees Celsius. This is just showing some work that the team has done, just showing just a variation in terms of your vegetation cover, your built-up coverage, comparing that with indices that speak to land surface temperatures. So we're interested in really estimating the urban heat island effect and trying to see, in particular here, the idea was trying to really ascertain that in areas where we have high vegetation, that we would expect to have our land surface temperatures to be lower, and they did make that finding. And where we have densely built up areas, we tend to find that our surface temperatures are higher. So it's at the moment just gathering the data and doing some exploratory analysis. And later on, these data sets would then be linked with the data sets that we're getting on the health front. So just to maybe acknowledge the partners, obviously this project is being led by Professor Chesik and Professor Lichtes, but we also have partners across various institutions from an academic point of view. CSAG I've already mentioned, and then ourselves from Cote d'Ivoire, we also have representation, as well as some universities in the state. So I think if you have further questions, there were quite a lot of posters that go deeper into the methodologies around land surface temperature. You're please welcome to review it.
Thank you. So I think in the interest of time, we will have some time for questions, but I think we'll jump straight into audience questions. So people start thinking about what they want to ask, and maybe all of our speakers can come sit up on the stage, please. Thank you. You have a question? There's a question over here.
Thank you for the good, diverse presentations. And probably I'll not ask the statistician a question because I'm a statistician. But maybe my first question is to Dr. Moodley. You know that South Africa is considered as the West, or a country or a continent by its own across the other African countries, right? Because you guys are way ahead of the other African countries. Where do you see balanced and ethical AI being developed and used within the other African continents, because African countries, because Akbar is not here, but he started presenting about AI in Kenya and we got bad reviews that, hey, AI will never ever work in Africa. Don't push this machine stuff replacing the human stuff. So that's just a question for you. Where do you see the other African countries? Because South Africa, I would say, is not part of Africa currently. And then my other question is to the two other training programs. I've seen you say that there is lack of data scientists, and I'm glad that DSI Africa is promoting on having masters and PhD programs, developed within Africa to maintain this. But do you have a sustainability program after the PhD graduation or the master's graduation? Because we all know that the pay scale and the salary scale for statisticians and data scientists is very low as compared to the West. And as you've seen, one of them had mentioned that I think they're sending their PhD trainings to Johns Hopkins, right? So I know that a lot of this, especially statisticians or data scientists that are getting trained, especially from Kenya to the US, don't come back. And that's where our lack of data scientists and statisticians is. So as much as we're developing a training program, what else are you doing ahead to sustain and make sure that there is not that pay gap between the Western and the African data scientists?
Okay, so South Africa is very much a part of the continent of Africa. And I can tell you that although we have very advanced research ethics systems and governance in South Africa, where it comes to data science and AI, I think everyone's just starting to develop guidelines and laws. We do have the Protection of Personal Information Act, but so does Kenya. So other parts of Africa are also developing legislation. And we have a publication in the South African Journal of Science now that indicates legal systems in various different countries in Africa. So there is legislation being developed with respect to data, but where we all lagging behind is development of law related to AI. And so in South Africa, we will have to depend on existing other law. So we have a National Health Act and we have a Consumer Protection Act, etc. So I think we are all learning together and we're all trying to develop governance systems and data access committees and data transfer agreements, etc. So it's something that I think the continent will do together.
Sure, yeah. Yeah, thanks for that question. So in my presentation, I actually alluded to that. We wanted the programs to be run in Kenya and Ethiopia, but with, fully the curriculum developed actually in ways that are relevant to the countries. And then the retention question that he asked in terms of whether people will stay here and whether the pay scale will be good. I think one idea that we have followed is to create partnership with government and private sector so that the programs are designed in such a way that actually the people will be marketable. I mean, not much you can do in terms of actually creating, increasing the pay scale. I think the market obviously will play its role, but hopefully, with the private sector growing and the government entities competing with the private sector, hopefully the pay scale will go up. But at least the training phase will be sustainable in the countries, but also, the programs will be integrated with what the employers need so that they will be marketable. So unavoidable, but trying our best.
Yeah, I think the question you ask is important. Many of us, I think, from Makerere ended up training outside Makerere, but we came back to the African continent. It's hard, but yeah, we encourage people to come back. So what we do is we make sure that the student is registered, is a registered student at Makerere University. You get your PhD at Makerere, not at Johns Hopkins. Although you're going there for 1 year, you have to return because you have to continue with your PhD. I think we also try to ensure that they're attached in research labs where they're coming from, such that when you come back, you're not coming back to, nothing, but there's a place where you're coming, where you still have access to the data that you're going to work with, or the data where a place where you're going to collect the data in a way. So we are thinking about it. It's hard to tell about money and everything. I can't give an answer to that, but we'll do our best to ensure that, they can stay after the training. Yeah.
Thank you. I think we have a question over here.
Thank you very much, speakers. And
Just a comment directed to Dr. Bahane's case of APRI. Yeah, in the East African community, I think there's an education council that is trying to harmonize curricula. They have gone ahead right now in harmonizing undergraduate education. They are trying to ensure that all curricula across East African universities are harmonized, standardized, such that a student can train anywhere in Kenya, Uganda, Rwanda, Tanzania. And I'm sure they are pretty coming soon to graduate training. And I don't know, do you have plans to reach out to other training programs, say in Rwanda, Uganda, to harmonize these curricula you are developing? I heard you saying you are developing curricula for more university, stuff like that. That will lessen the burden of these committees in the community that are trying to harmonize education.
Work with him.
I'm trying to.
Yeah, so that's a very good question, a very good comment. I think for the project that we have now, we, at least with the two countries that we're working with, we have tried, to work together. So the curriculum is actually developed jointly, but with the recognition that there could be some variations, and we cannot have it like 100%, harmonized. And then the other question is, if you saw my aim slide, there is an aim actually where we will talk about regional expansion, but also maybe looking at PhD programs, curriculum for PhD programs. So at that point, probably, I think the idea is whether we go second cycle or not. I think, obviously to work with other universities. But even without waiting for that period, if there are countries that are developing public health data science programs, we'll be happy to work with them even right now.
A question over here.
Yes, thank you. My question is to the HIT lady. I thoroughly enjoyed your presentation.
Thank you.
Obviously, one of your concerns must be some of the biases that you would see in terms of vegetation cover and the lack of clustering of houses and all of that affects the environment, the effects of the environment that you're interested in looking at. And I just wondered how you would dissect some of those covariates that kind of cluster the patterns that you're seeing.
Yeah, sure. So there's been specifically in the area of statistics, the use of approaches like your hierarchical types of models that take into account mixed effects. But I think what is very important, and which is why we also we're developing tools for kind of like your visual exploration of the data, is to have that awareness of clustering, specifically not only for the environmental data, but your socioeconomic data also tends to cluster. We have a poster where we were showing just clustering of unemployment. So areas of deprivation tending to cluster together. That's a very important consideration that we have to take into account as we go into modeling, this type of modeling that we have to do for the heat center. Another a challenge from a technical point of view in terms of model building is you're also dealing with data that differs in terms of your kind of like your basic spatial units. So you have gridded data, but they vary in terms of resolution. You also have your socioeconomic data tends to be in these irregular aerial units. And then you have data from the health side. Your individual patient data might be at kind of like your point location. So you have different types of spatial data and you're trying to integrate them in a modeling context. And so you also have to take care of those nuances and use the relevant models and techniques that treat this issue around spatial misalignment. But yes, I agree, you have to take care of clustering.
We could take one last question if there's any over here. This one.
Yeah, so thank you so much for the presentation. So I just wanted to get so this concept that IBM is doing within the continent, and how much you are involving that in the curriculum development?
You started it.
All right, I'll start it. So actually next March, IBM Research Africa based in Kenya is going to be celebrating our 10-year anniversary on the continent. So we were the first industrial research lab on the continent. We have now been followed by the likes of Google and Microsoft, but we were the first movers there. I would say the way I'm most closely connected to capacity building would be through the process I mentioned about my friend John, coming in as an intern, working as an engineer, getting a few papers out the door so that getting into grad school and some of the world's most competitive programs is a breeze. And then it's up to them if they want to come back. And so far we're doing okay on that part for bringing them back. So that's an area that I feel really strongly about in terms of capacity building. And there are other ways, putting on a massive online course or being involved with the some of these training courses. I am an advisor on the NYU Moy University training grant, so that's an angle that I'm putting into there. But I really enjoy the other aspects of actually working with the team, preparing them, and then sending them off to a world-class PhD program. So that's where I feel called to be involved in the capacity building.
Yeah, maybe just to add on to that. So obviously we have very strong kind of like internship programs, and we have various ways in which we bring in interns. But another important thing, when Skylar did share a resource that it is open source. So actually our AI teams produce a lot of open source tools. And I think one of the, I guess, task that falls on our shoulders is to also make the consortium aware of some of these tools because they might be useful for your project. But another important thing is we tend to have what we now call signature events. So that's where we have like the What's Next in AI seminar series. So again, I guess the task is upon us to make sure that the messaging gets through so that the rest of the consortium is also aware, because those are open to anybody to join. And we just recently actually had a summer school around logical neural networks, and that came with a kind of like badging program. It's still there. So those are a kind of information that we probably need to get better at sharing with the consortium, but those are some of the other ways if that the consortium can benefit from some of the programs that we have.
Coordinator Rolanda can definitely work with you to disseminate some of that information. I think in the interest of people getting lunch, we're going to have to end there. We're almost back on time now. So thank you to all of our panelists again and all of you for your questions.
Just one more note about where lunch is. It's in the courtyard today. Thanks.
1, 2. plenty to drink. Okay, so what's going to happen for the next 2 hours, we're going to call it, is we're going to have a keynote speaker. We're going to have a series of other speakers come up and talk, and then we're going to have question and answers at the end. So the overarching theme of this particular session then is to really talk about the strategic importance of engaging communities in the context of data science research. In this session, I hope that there are going to be things that you are going to hear that are going to resonate with you. And in fact, I want to challenge you to think about some of the things you hear as to how they might be relevant for your project, okay? We're not going to give you the answer for engaging communities because there is no single answer, but hopefully you're going to provide you with some thoughts that you can think about taking back to your community. So I've had this question multiple times already from many of the speakers, and they've said, well, what is the outcome? What do you expect to get from this particular session? And I'm going to give you the answer right now. Okay, the answer for every single one of you is I hope at the end, you may consider walking up to one of the speakers, not me, by the way, one of the speakers who are the experts, tap on their shoulder and say, excuse me, could we please talk about this? Okay, because I think they're going to have experiences that are going to be incredibly valuable for you. So a key thing about this particular session is that the speakers, by the way, agreed that this is not about showcasing what they have to offer necessarily. They're going to provide you with some, I'm going to call them seeds for fodder. They're going to give you a few things to think about in describing their programs, in talking about some of the challenges they may have had, and some of the successes they may have had. But that's going to be information that we are then going to collectively talk about. So it's not just going to be us talking to each other up here. It's important that we engage you. So the beauty of this particular session is that we have 7 speakers, and they're at 45 minutes a piece. Yeah, you can do the math on that. Okay. No, we have a keynote speaker who's going to start it all off about a half hour or so. Okay. We then have 5 different projects from DSI Africa that are represented. We have 3 of the research hubs. We have 1 of the ethical, legal, and social implications projects, and we have 1 of the training projects. Now, we have an added bonus on the end of all of that, okay? And we've held this out to the very end. We also have, given the context of this particular theme, we have a communications expert, okay? And I'm going to introduce each one of these people as they come up for their appropriate section. But this is going to be what I believe to be a pretty rich conversation. So, admittedly, the concept of community engagement is very, very broad, okay? And we're going to recognize that right now, okay? What I want you to try to think about, though, is community engagement in the context of data science research, which is going to narrow this down. It's going to be more specific to the efforts that we have in DSI Africa. But at the same time, you're going to be able to hopefully beg, borrow, and steal examples from other areas of science as well. And I think the best way to sort of talk about that is to introduce our keynote speaker, who's going to provide some of those examples. So our keynote speaker is Dr. Stephen Chacha. Stephen, and I'm going to have to read this, by the way, because he's got this like list of things that he's done. And I'm only going to touch on a couple of those. Stephen currently serves as the director of the East Africa Hub. He has served in a variety of roles as founder and director for a whole bunch of things, by the way. Some of these groups include the Tanzania Data Lab, the Youth of the United Nations Association of Tanzania, and the Africa Philanthropic Foundation. There's the title of Stephen's talk. So I'm going to get out of the way and let him take care of it.
All right, thank you, James, and very good afternoon to you all. So as introduced, I'm Stephen Chacha from Development Initiatives based in our Africa Hub office, which is in Nairobi, Kenya. So at Development Initiative, what we do, we harness the power of data and evidence to end poverty, address inequalities, and also build resilience through the different, development kind of work that we engage and actually we do. If you look at our strategy that we are currently implementing, at the heart of it are the 3 key drivers of change that we're driving. The first one is on strengthening data ecosystems. We very much believe in building data ecosystems so that we could actually have bases for each and every one of us to actually be able to come together, collaborate, share data, and really build collaborations and partnerships around data. The second drive of change that we are pushing is increase in the use of data-driven evidence to inform decision making at different levels. And through this, we do a lot of analytical works and we produce a lot of global reports, providing evidence to guide decision making in some of the key sectors around the world. So you can actually read more on our website based on the global reports that we actually produce as an organization. Then the third area of work or the drive of change that we're actually working on is actually on creating culture of data use. And that's why when I was actually invited to speak with you all today, and I thought, it would be nice to actually be able to share a bit of our experiences on actually building culture of data use and how does that actually relate and link with the work that we actually do in community engagement. So maybe to start in my presentation is very much trying to look on the actual problems and challenges that we, more or less, try to address on a day-to-day basis through the work that we do on data science, and the investments that we do actually do on data. So basically, we are at a stage whereby we are more or less, I should say, data rich, but information poor. Because most of the initial investments were very much about, creating data. So we are at a point in time whereby we actually have a lot of data that is available, but with very limited use. So that's, a common challenge that I believe most of us are also trying to address, through the different, kind of investments or projects and programs that we're implementing. But also coordination issues. And for the last couple of days, I've been hearing a lot of, concerns around data access, cross-border data sharing, a lot of very common coordination kind of, challenges that we all face in the different kind of engagement that we actually have. But also, most importantly, is a shared aspiration that we all have. To be able to move data from raw data to information, knowledge, innovations, and the data science products and services that we are all trying to build so that we could actually be able to address and serve the pain points that our societies and communities are facing. And most importantly, at the end of the day, be able to impact and improve the lives of people that we are all trying to, to target or improve in one or the other. And culture of data use have a very important role to play in all of this, as I'm going to explain in the next few seconds. So traditionally, as we've been conducting data assessments, we've very much been paying attention to the supply side of data, the demand side of data, the technical capacity or the technical side of data, and also the enabling environment and the political economy of data per se. And there've been very little consideration of culture or culture of data use, which I consider to be a very important group that actually, odds and bring all of these, different kind of, paths together. And even the whole concept of actually data use is something that really emerged very later on after we actually realized we are just collecting a lot of data and there's a very limited use. And that's why most of our, recent investments and projects and programs are also very much trying to promote data usage, as a concept. But in order to actually be able to achieve sustainable data usage, there has to be a very strong culture of data use to go hand in hand, and support that. So I think Peter Drucker put it very well in terms of actually emphasizing the importance of culture. Culture is strategy for breakfast. I think, some of us must have heard that, quote before. So literally what Peter is trying to tell us is the fact that regardless of how, fantastic our strategies are, regardless of how good our investments are, how good our data science products and services are, how good our data and evidence that we're generating is. But if it's not really supported by a very strong culture, and in this case, culture to make sure that it's actually being put into use, then we are likely to, achieve very limited, impact or outcome that is actually intended. And it's also likely to be unsustainable over a long period of time. So this really what emphasizes on the importance, law of culture in the normal organizational kind of life, but also in the project and the kind of work that we actually do on the side of data science and data as well in the programs and projects that we actually implement. So ideally, when you look on key things that actually underpin sustainable culture of data use, there are a number of them. Number one on the list is leadership. Leadership is very crucial in terms of actually be able to nurture the culture of leadership in any setting, being an organization, institution, or in a community, meaning there has to be leadership from the top. That is really leading by example on how really data is being put into use in our institution, organizations, or communities. So that is extremely important. But as well, it has to be inclusive. Inclusive in the sense that we need to take an ecosystem approach by ensuring that the different kind of partners and stakeholders that are engaged or involved in the ecosystem are actually part and parcel of the process, so that we can have very clear laws and responsibilities among actors, and so that we could really be able to leverage on each other and really be able to include each and everyone that is supposed to be included or be part of the picture. But as always, we have to be responsive to the realities on the ground, responsive to the needs of the communities that we engage and work with, but as well responsive to the needs of the countries that we implement these projects and programs in the sense that we're building a culture of data use that is actually addressing the real world problems and challenges that are relevant to the communities, relevant to the countries, and are relevant into the context that we actually do operate in. Again, we also need to be user-centric in the sense that we need to take into consideration and give priority to the actual needs of the individual users that we're intending to target with this data, evidence, products, and everything else that we're actually generating, so that at the end of the day, it can actually resonate, it can actually be able to be put into use by the intended users that we are engaging and working with. Accessibility is crucial because at the end of the day, to have a culture of data use, then the data itself has to be accessible. So we really need to make sure that there's data accessibility, really to be able to support and nurture culture of data use that we want to see happening having in place. Data quality is of extreme importance in the sense that once you have poor data quality, then there definitely going to be a low uptake and usage of the data. So the two actually go hand in hand together. But as well with the different stakeholders and partners that we actually engage and work with, there has to be relevant levels of data literacy, skills, resources, and assistance that is actually being offered to them to enable them to engage with the data, to make sense of the data, to be able to analyze the data, draw insights, and really be able to put the data and evidence into use, in the way that is actually intended. So we also need to focus and prioritize, capacity building, data literacy, and skills around that area. And as well, we have to facilitate the fusion between domain knowledge and technical know-how. And this is usually what I say, that's where the magic happens. When you really are able to bring in people with the technical know-how and people with the domain knowledge, including the local domain knowledge, which most of the times we tend to underestimate, which is extremely important. We don't know the solutions better than the people who are actually living the realities on the ground. So that knowledge is extremely important to be integrated and to ensure that we involve it in the solutions, in the designing phases, and as well in the delivery of our data science programs and projects. Again, we also have to mitigate the risks because, this is where the issue of trust is. People have to trust the culture of data use that we're building. And as part of the trusting process is also for them to be fearless or, to really not have any concerns regards with, the risks that are actually involved. So the risk mitigation element is also an extremely important area to consider into this. We also need to understand the motivation and incentives for people to use data. And we need to mold and build a culture of data use that really addresses the different motivations and incentives that actually people have to enable them to use data. So that's also an important element. And partnership, we have to embrace partnership in all ways and forms, including, with our own research participants, our own targeted end users. All of these are partners, and we have to treat them as such in terms of actually involving them in the designing phases, offering feedback, to them based on the data and evidence that is actually being collected, and very much being able to push an engagement on the dissemination, utilization, and down the value chain, the way that they are supposed to be engaged and involved in the processes. We also need to embrace open science and open data in the way that we build culture of data use, so that it can be accessible, it can be built on, it can be expanded, it can be, replicated and grown, and achieve kind of a growth that we want to achieve within, the ecosystem, within the sector, but also in other places that it can actually be replicated in one or the other. Champions are extremely important, for us to be able to achieve a vibrant, culture of data use. There have to be champions among us who are really going to pioneer, who are really going to be passionate about really pushing and driving the data use to be able to realize the outcomes and the impact that we want to see happening. So champions are extremely important element as well to consider in doing this. And most importantly is institutionalization. We need to institutionalize the culture of data use, because at the end of the day, with all of these initiatives and all of this, kind of thinking, if it's not institutionalized through things like data policies within our organization, things like data strategies within, our organization, or, policies of some sort within the communities that we actually engage, then we are likely not to actually be able to sustain or build a sustainable culture of data use in the areas that we're engaging in. So now I want to move on and really share our organization, experience in building culture of data use, and my own personal, experience, from the work that I've been doing with Data Collaborative for Local Impact Program. For some of you may know about the program, and also the Tanzania Data Lab that I co-founded, and I was leading it for more than 5 years, and now with the Development Initiative that I'm currently leading as well on the side of the Africa Hub. So at the global level, we are part of the Data Values Project. This is a global movement or initiative that we are one of the co-creators and working closely with the Global Partnership on Sustainable Development Data, if some of you maybe know them. And it's all about demanding a fair data future. So it's really trying to push for principles that the data future or data should actually be driven, by things like supporting people to shape how they are represented in data, invest in public participation for accountability, democratize, data skills for a greater equality, create cultures of transparency, data sharing and use, fund open and inclusive data systems so that all people share in the benefits, of data. So it's really putting people at the center of the data movement. People at the center of the data products and services that we're actually building, so that we really are inclusive, as I said earlier, and really involve and prioritize the interests of the people in the work that we actually do. But again, I want to emphasize on the important role of engagement and co-creation based on my own personal experience and engaging at different levels in a number of countries, building data ecosystem and culture of data use in a number of areas. So these are the examples of some of the engagements that I've been, personally involved in. And I specifically want to zoom into the mapping of the hyperlocal data flows in one of the districts, in Tanzania, where we actually, in efforts to try to understand the problems and the pain points better, we actually worked closely with the local government authority in the area and the key stakeholders in the health sector in the area, very much to do the actual mapping. How does the data flow from the health facilities all the way up to the national level, using a use case of that one district that we engage in and what you worked in. And one of the, perhaps not a very surprising finding to most of other African countries in the room, is the fact what we actually realized that data was actually not utilized at the health facility level. The health facility level were just a point of data collection, and they channel data up to the districts, all the way up to the national level. But at the same time, there is huge potential on how service delivery can actually be improved and how decision-making can actually be improved if that data is actually put into use at the point of collection in that case. So this example, for an example, led into a partnership now with the local government authority and the Ministry of Health in developing what we call Health Facility Data Use Guide, which was a guide that was endorsed by the government to train and give the necessary skills and tools for the healthcare officials at health facility level to enable them to engage and be able to use the data to improve service delivery and to improve decision-making at the facility level. So, but again, it's something that we were only able to, to find out by actually working with people who understand their problems better and really investing in research, in understanding the problem, instead of actually just coming down with a solution that, this is what you need. So these are some of the lessons that we've actually been learning as well. At the national level, we've supported the National Bureau of Statistics in Tanzania to conduct the National Data Gap Assessment for the country, which really exposed the data gaps that are there, in the country, in all sectors. The country only produces 40% of the data that is needed. Then there's over 60% data gap. So how do you fill this data gap if you're not creative by bringing other, alternative sources of data to complement on the data gaps? So this actually led into a partnership and, build up on the framework on how to integrate non-traditional data into official statistics. So that how can we bring in data from the private sector, from civil society organization, from citizens, meaning citizen-generated data, and other sources of non-traditional sources of data, so that they can actually complement and fill in the data gaps. But all of these were part of immersement, deep engagements, and co-creation processes with the key stakeholders and communities that actually matter at that level. And through this work as well, we've done a lot of work, developing data roadmaps that really brings different stakeholders at different levels to corroborate and work together in building, cultures of data use that are relevant at the subnational level and also at the national level. But most important as well is to make sure that we also leave no one behind in these engagements, because there's also a risk. The way our data, systems are, they are not disaggregated enough to include all of the key vulnerable or marginalized group. Very basic, people with disability, young people, women, are very likely to be marginalized in most of our, data work and intervention, and even our data, science products and services that we're actually building. So we have to be very intentional in ensuring that we're inclusive enough, and that we actually are trying not to leave anyone behind by actually integrating these concepts in the work that we do. And these are just as examples of the products that we actually developed at the global level, on the data side of leaving one behind, but also specifically Inclusive Data Charter in Kenya and in Uganda, but as well the Tanzania Youth Data Engagement Strategy for the case of Tanzania, in terms of actually ensuring that the youth are engaged in the data processes, in the digital revolution, and the digital transformation, that is actually, happening in most of our countries at the moment. The skills side of things in terms of capacity building is extremely important to ensure that really data is actually put into use. And through this, we have actually engaged in a number of initiatives, from short-term courses, tailor-made, courses, into advanced programs such as the Master of Science in Data Science program that we are running with the University of Dar es Salaam, in Tanzania. But a very good example that I want to give here is a partnership that actually emerged from our engagement with the local government authority and the local government training institute. So from our engagements with the local government authorities, we actually realized a number of challenges. One, the skills gap that was actually there, among the local government authorities, officers, on data. But secondly, the motivation and incentive, it doesn't matter how much you train them, but they don't really put those skills and knowledge into use, because they have no motivations. Like no one can hold them account, not to be data driven or anything like that. So what happened through discussion? Then we opted into actually introducing a data leadership curriculum in the local government training institute in Tanzania. So we went into an MOU. We co-created a curriculum with the local government training institute, and the beauty of that is that each and every local government officer in Tanzania, before they're being posted, they have to go through the local government training institute for training. And from time to time, there are those refresher courses which are actually being offered by the training institute. So now the curriculum is already in place, and now it's mandatory for each and every local government officer that has been recruited by the government to undergo that data leadership training at the local government training institute. So in building a culture of data use, meaning this is a long-term game in terms of we are really looking for a long-term kind of change here. So meaning over time, we're actually going to be having local government authority officers being posted in different parts of the country who are actually going to be data literate, meaning they're actually going to have basic data skills that they will have achieved through the training that they'll actually be receiving there. And already there's a commitment from the local government authority to integrate data usage as part of the performance metrics for the local government officers. So meaning over time, there's already going to be a motivation and incentives for them to actually be able to put this, data skills and put the data into use in the work that they actually do. So I just wanted to highlight that example as part of, the work that we did in building data culture there. Again, I want to emphasize on the importance of investing in local capacity and citizen-generated data. So we were approached by one of the districts to support in mapping the district. So literally, this district was completely off the maps. Like there's nothing, apart from a dot with a name, there's nothing about this district on the map. So what we did, we engaged with community, youth mappers. We actually recruited community, youth mappers from that, community, trained them on OpenStreetMap tool and on ODK tool. And again, here I want to emphasize open science, open data tools, that we're trying to use so that they can easily be accessible. They can actually continue to engage and use them, over a long period of time. There are no licenses or anything, in engaging with those kind of tools. So with that, in a period of us 3 months, we managed to map the entire district up to the hyper local level. So a district that was completely off the map was fully, on the map with detailed information, on that, district. And now this is kind of a data set that came up. Very rich data sets. And the beauty of it is that now the skills and knowledge are with the local community. And now over time, these maps are constantly being updated because some of the youth that we engage are border drivers. So who easily can go around the place, realize, there's this feature which was not there. And they just choose to update because they have the knowledge, they have the skills, they have the tools on their hands. So it's something that they're actually constantly doing. And we have done this in a number of, areas in different countries, and it is working. So I just want to emphasize on the, on the power and the need of actually engaging local, actors and change makers and building local capacity that could actually be able to go a long way, and even complementing, some of, the data that we are collecting, and really be able to get real-time updates on certain elements, and really integrating citizen-generated data as part of the work that we do as well in data science for health. Champions. I think I already alluded, to the importance of having champions in building culture of data use and really sustaining, data use in the different kind of areas. So I cannot emphasize this more. Is very much identifying the right champions at the right levels to be able to, support and sustain the work that we are doing, there. Again, it is very important to take a value chain approach in promoting the data, the use of the data and the evidence that we are generating. There's a lot that can be done to the data that we're generating beyond even what we can think of. So we have to engage with the, with the industry. We have to engage with communities of entrepreneurs. We have to engage with the communities of innovators in order to be able to really realize or actualize the actual potential of the data and evidence that we actually generate. So these are just examples of the work that we have done in some of the of the project that I was involved in. And I want to emphasize this. This has to be intentional. This will not happen by itself. We have to be intentional about this. We have to be intentional about sharing our data with these communities. We have to be intentional about supporting businesses to emerge out of the value chains that we're actually involved in. We need to be intentional by supporting other innovations to emerge, based on evidence and data that we're actually generating. So these are some of the innovations. We actually supported over 55 innovations over a period of 5 years, focusing on different kind of areas, ranging from gamification, that are targeting youth to influence youth, behavior change, to empower, youth empowerment kind of, platforms for employment, Lishe Yetu, which is about, food and nutrition, Dr. Elsa, which is purely on the health field. And maybe I want to just to emphasize more on Dr. Elsa, which is very much in line, with the work that this community is actually doing. So this is an AI-driven tool, very much trying to fill in the gap that we know we all have of doctors to patients in our countries. And in some of the facilities in rural, places in our countries, is basically, manned up by a nurse. These nurses are saving lives in those locations, but technology could actually be able to offer a lot of help and support to enable them to make the right decisions, right diagnosis, and do the right kind of prescriptions, as needed. So this is what Data ESO is all about. And I do believe there are opportunities for innovation like Data ESO, to emerge from a lot of the work that you guys are doing, and the evidence and data that you're collecting in many ways. So this is just an example of things that we could consider and try to be intentional about in terms of really promoting and engaging. So we have also been trying to be creative and have fun in doing this work, in the sense that bringing creative, innovative ideas on how we could actually be able to communicate data differently in ways that it could actually be able to resonate with people, touch people's hearts and minds in one or the other. So these are just examples of the work that we've actually been doing. So let me start with the podcast. So we have a series of podcasts known as Good with Data, just as an alternative way for us to be able to share the work that we're doing on data, to share the data and evidence that we're collecting, the findings and analysis that we actually do with the wider, that we can be telling stories about the data. So it's about data storytelling, to a large extent, so that it could actually go, far and really be able to reach and benefit a lot of people in an easy, simple language that people can resonate and understand, easily. And it does not mean that we have not engaged with traditional media houses. We actually did. So we engaged with a number of traditional media houses in establishing data desks within the media houses. That has really contributed significantly in data journalism in some of the countries that we're actually engaging in. So what sometimes is missing, they are just skills. You may think maybe there's no good coverage of health data, science, whatever products in the media locally. But trust me, you have not engaged them rightly. If you build capacities and you feed them with the right data and they know how to, to understand the data, they're journalists. They can tell stories on those data. So we just need to make those connections and linkages to be able to facilitate, the wider sharing of the findings and, the data and the work that is actually coming from our work, so that we can actually be able to really achieve the impact that is actually intended. So the top right picture, that is a fashion show. So you may be asking yourself, what does fashion show has to do with data? So what we did, actually, we took gender-based violence data in the country, and we engaged a community of young designers. We gave them the data sets and engaged them in a competition to design clothing designs based on the data sets. So for colleagues from East Africa, coastal East Africa, they are aware of the Kanga clothing, yeah? So this was a Kanga design. So, and it was intentional. So it's gender-based violence on a Kanga design. So the Kanga are the piece of clothes that are worn by women and girls along coastal areas, in East Africa. And they usually carry a message, with them. So the whole idea was to communicate gender-based violence through Kanga designs. So we had a number of, entrants in this competition. It's something that started a kind of a simple idea, but it was amazing in terms of the interest, in terms of what really got into that. So out of that, we actually shortlisted, the entrants into 5 top, entrants. Then we organized an exhibition and fashion show, showcasing those designs that they actually came out of that. And these designs have gone a long way. We have pictures of them in the White House, you name it. They have really gone a long way. So I'm just trying to emphasize on how creativity and innovation, on how we can communicate data differently, can really have an impact, can really be able to resonate with the audiences that we are trying to target, and can really be able to have a long-lasting kind of impact that we want to see, happening on the ground. The picture on the bottom left, that's a mural in one of the areas. Again, is one of the areas with the highest HIV prevalence rates in that location. So we chose to use murals as ways of actually communicating data and evidence to actually be able to influence behavioral change and other elements, in that way. Also, the other picture on the right, bottom right, that is one of the recording sessions that we had. We did a lot of music songs. We did a lot of music videos, especially the issue of drug abuse issues that actually relate with the young people, because, that's the right medium to engage with them. So we had a lot of interesting, products that actually came, around that. So that's really trying to share some of the creativity and innovations that we brought in terms of how we engage with the communities and how we communicate the data, evidence, and the findings. And again, I think it's always important to celebrate, achievements and have, sessions like this where we share experiences, best practices. And it's always important to celebrate our successes in, data use, and how really data use is really impacting life, is really leading to, changes in different kind of ways. So this is an event that we initiated in 2017. It was basically started off as a national event that really brings in, national stakeholders to share success stories, celebrate achievements around, data and data usage and everything else. But it has grown now into an international, event. The Data Tamasha last year, 2021, this event is organized every after 2 years. Last year in 2021, it attracted 800 participants from all over the world. So some of the topics that we're discussing here, data protection and privacy, were topics that were featured in Data Tamasha last year. And they had expertise from all over the continent and from all over the world. As I was telling, some of the discussions that I've heard here, actually, I know people are doing work in those areas, based on the engagement that we've had in this kind of platform. So it's always important to engage, take advantage of this kind of conferences and platforms that are actually there, and very much trying to use them to continue building collaboration partnerships on building culture of data use around different kind of areas that we actually work in. So together with celebrating, we should not forget why we are doing what we are doing. So I believe we are doing what we are doing in order to be able to generate evidence to influence policy, decision-making, and most importantly, something that we are not talking, a lot about, is financing and investments. On the first day I was here during the opening, someone mentioned about this whole program and the $75 million, investment. To me, that is a seed funding that has gone into this. What are we planning to generate at the end of this cycle of funding? How are we attracting investments from our own governments in terms of actually how are we building use cases? How are we influencing policies through policy briefs so that they can really lead into changes that we want to see? How are we building proof of concept based on the different kind of projects and programs that we're implementing so that they can be scaled up, replicated in other parts of the continent or even in other parts of the world? How are we building investment cases so that our governments can see value in investing in data science and innovation for health and really be able to allocate budgets through our health budgets? How are we building cases to our private sector within the continent? So that they can actually be able to invest in this area. Our philanthropic foundations in the continent, our development banks in the continents. So how are we building investment cases? This has to be part and parcel of our mission, because, the 75 million will end, after a couple of years, to come to an end. So what's our plan in making sure that we use all of this work and evidence that we actually generate really to make sure that it really resonates to people, they understand the value of this work, and more players, even our own governments, our own private sector entities, will be more than willing to invest and support the initiative and the work that we're actually doing. And finally, culture is dynamic, it's not static. So it's something that we need to continue monitoring closely, evaluating, progress that we're making, documenting our impact, document our lessons, and really making the adjustment and the changes that we need to make over time to make sure that we actually stay on track and we're really leading into achieving the desired outcome and impact that we want to see happening on the ground. So without James, I want to thank you so much, and I'll be open to take any questions.
Great step down. I'm pretty sure we're going to have a scheduler for Stephen when he's finished here, because there's going to be a line of people that are going to want to talk to you, which is really great. I did want to open the floor for one quick question, if anybody has anything. Otherwise, we'll jump into the remainder of our panel, or the bulk of our panel. Yes, sir. There's a microphone coming around from the side here. I would ask that you just identify who you are, so we have some understanding of maybe how to connect with you as well.
Yes, thank you very much for the presentation. I think it was very rich. I learned a lot of things. It's just a comment, because when I see the title, Building Sustainable Data Use Culture, I will prefer that we add for decision making, because it's not only, it's difficult to just separate both, because so that it is clear that data use is for decision making. So in the title, both should be together. It's already said in the development, but it's better that in the title we don't separate data use and the decision making, because it is for decision making. The second thing is that when we talk about data use, usually we don't have indicators for that. So it's better to think about how we can measure that data use, how to know that someone has used the data. You see, that's why we should think about the indicator for data use. Thank you.
Well, I'm not sure if I need to respond to that. Maybe a quick kind of comment as well. Decision making is an end game, and is something that will happen as an outcome at the end of the day. But either way, the culture of data use has to be there, because there are a lot of other things that has to happen before we are able to influence decision making. So it's only that sustenance on data use that is going to be there that is automatically going to lead into influencing and leading to that. It's not just automatic. Once you have data use, then you're going to influence decision making. It's a process. So I agree they are interlinked, but not necessarily going together all the time. It's a culture that has to be there. Then as a result or as an outcome, decision making will always follow. Yeah. And on the second one, I agree. And that's why I emphasize on monitoring, evaluation, impact, and learning at the end of the day. It's like any other qualitative spaces, but they are well-established methodologies on how to measure qualitatively, things like data use. So it's about us embedding them from the design phase of our projects and programs, so that we ensure that we have very clear metrics that we actually use to measure progress, and how we actually delivering impact when it comes to data use.
All right. Again, thank you, Stephen.
Pleasure.
Okay, so as we then transition into the remainder of our panel, what I really want you to think about is some of the comments that they're going to share. Find lessons that you might be able to incorporate into your research. And importantly, thinking about sort of the long-term nature of this. This isn't, as Stephen said, this isn't a one-time shot. It's not an inoculation, okay? We're going to have to revisit this time and time again, okay? So our first speaker then, I would like to invite up Dr. Amina Abubakar. Where is Amina at? She's over here. Yes, there we go. So, jump on up here. Yeah. Very informal. So Amina is an investigator. And again, I'm gonna have to read from the script here. Amina, so the reminder is that we have representation from multiple of the DSI Africa projects. Amina is an investigator in the, by the way, really creative acronyms for a lot of these. I applaud you all. So I'm going to read what the projects are, but then I'll tell you the abbreviation as well. So Amina is an investigator in the Utilizing Health Information for Meaningful Impact in East Africa through Data Science Research Hub. I got to breathe a couple times there. Otherwise known as Uzima DS. This is based out of Kenya, and today Amina will raise topics specifically associated with engaging communities for sustainable impact, what we just talked about. So thank you.
Thank you. So Uzima is a Swahili word for health and well-being. So we wanted to connect it with something that when we communicate to communities, it's an easy terminology. So thank you. The speaker ahead of me, we are both based in Nairobi, so I'm sure we are going to learn a lot. So as we were designing the Uzima project, one of the key things that came out is the fact that people develop all these fancy models, but they're not used. So they saw what? How are we going to get them used was so important. But also the other important thing that came out is that there's open access, there's a push for everything to be freely available. But if there's no resource to maintain that, if there's no motivation, then it will just kind of die off, yeah? So when we developed our program, next, I don't know, am I done? Oh, sorry. When we developed the Uzima Hub, we thought of it in 5 components. So we have the projects, the focus is maternal, newborn, and child health. We have the mental health aspects. We have the admin core. I always call it the most boring bits, ensuring MOUs are done. People turn up for meetings, but well, somebody has to do it. Then we have the DMAC, the data management and analysis bit, but we put in specifically the data dissemination component of it, dissemination and sustainability. And how are we thinking about it? Multiple players. We do have, for instance, the Ministry of Health. So the Director for Monitoring and Evaluation is part of our independent advisory board, so we can link with that. We have, for instance, the Aga Khan Foundation. Aga Khan, network has a huge set of hospitals and all that. So it's a private sector. The Clinton Health Initiative and the William Davidson Initiative, they're a business school at University of Michigan. So the first time we presented, these people are like, are you trying to sell data? We are like, no. We are thinking, when you develop these fancy models, how do you actually get them into clinics? But actually, how do you have them used in a way that it produces some income to sustain itself? When you develop something, how do you get patent? How do you get registered? How do you know? So we are at the thinking stage. We are not yet there. So I'll talk about what we are currently doing, but for us, the sustainability of whatever we do is core to the way we have designed the research hub. So one of the key things about dissemination and involvement of the communities and the public we are engaging is really starting right from the, like making it a project life cycle thing. It's not like you collect data, then go back to the people and tell them about it. So we are actually involving the community right from the start. So we have the external scientific advisory committee, but we also have a national technical working group. So here we have officials from the ministry, but at the local level, we have, for instance, for mental health, people living with, who have mental health experiences. So they really can tell us the story of that. We have media experts, so a broad range of people who are specialized in bioethics and understand the local communities we are working with. But we've done at the start of the hub, before we started collecting data. Now, we had to design the project in a very short while. So quite an amount of what is the science has already been written. But before we started working on the science, we've had a series of consultation meetings. Now, the consultation meetings has involved people from the community, like caregivers, like for maternal, newborn, and child health. It has literally involved mothers for 2 or 3 days of workshop, where we talk to them about Uzima, the priorities and all that, yeah? And through these consultations, well, they were happy with most of the things we have, but they also raised some of their key areas of concerns. For instance, in mental health, our focus is largely depression and anxiety, but the community noted they're very concerned and would like to learn more about psychosis, because there are hardly any services around psychosis. It's highly stigmatized and they don't really understand what needs to be done. So they really felt that what was very encouraging is both the members of the community and the experts are keen to have a way to use the data. Like if you look at Kilifi, we've had a demographic health surveillance system for 30 years. So they're like, wow, are we finally gonna see some of this data and see how it's used and what it means for us? So there's really that aspect. There's also the anxiety around the ethics of it. Are we going to be identified? How is that, So really addressing all those concerns early enough, it then builds for you champions, because there are those community members who are really influencers, and we got them into these meetings. They will become our champions in the community. So we are also doing packages, small awareness campaigns, interactive shows. So for instance, during the World Mental Health Day, we had a radio show where we had 400,000 people log in, and they were asking questions and answering. Actually, it was too short. I think so there's that keenness to get the community to know about our project, about the work, even before we officially start rolling out models. Now, when we develop the predictive models, we would also want to do rapid cycle evaluations. So for instance, at Aga Khan Hospital, the doctors are collecting, all pregnancy data in an app. They have 3,000 pregnancies. So they're like, okay, you'll get this data. What are we going to get out of it? And there was a really good question today. What about missingness? And my answer was actually part of the value of having this data isn't just so that we can give you feedback. Are there patterns of missingness? Are there ways you can improve the data collection? But also we can discuss back with you, is there a way for really decision-making on the quality of care being received? So we would do those kind of evaluations before we even publish the models so that we can really see the value in the community. But so where are we thinking this would lead to sustainable impact? We believe if over a period of 5 years, different stakeholders are engaged in the work we do, there will be a sense of ownership with whatever data we produce, with whatever results we produce. We know that the governments, especially the regional governments, are very keen to see how they can work with the data we have. And largely the ownership will come from the fact that we are addressing their needs and their priorities, but also that they've had an opportunity to contribute to the design and implementation of the work. But also, as I've mentioned, we are working with a business school, and at Aga Khan, we are working with the Center for Innovation in Technology, and they're helping us identify opportunities for social enterprise. So for instance, whenever we have our hub meetings, we do invite experts. So we've had the Innovation Center present some of the work they have done around social enterprise, so that the Uzima Hub members, because we are quite a large, we have different skill sets. People can already start thinking about how these models apply to them. So I think the key principle is that it's a multidisciplinary approach, the way we are going about dissemination and sustainability. So within the dissemination and sustainability core, we have people from the business school, we have people from the graduate media, we have a community engagement expert, bioethicist, and then poor me with some psychology. So this multidisciplinarity is helping us think through beyond different fields and look at where can we get innovation. So thank you very much. That's what we are doing in the Uzima.
Well, thank you, Amina. I think Amina was very good at quickly integrating some of the comments that Stephen made. In fact, that you set a really high bar for the rest of you all here. So good luck with that. Okay, so we're going to transition slightly. Amina talked about one of the research hubs. We'll transition now. We're going to bring in a training hub or a training program here. So next up, we have our next DSI speaker is Anne Mwangi. Anne has a lead role with the Data Science for Social Determinants Training Program, DSSD, which is also based out of Kenya. We have a certain theme going here, so please.
Good afternoon, everyone, and thanks for inviting me to come and talk about our training grant. Actually, I know in the schedule, Rumi is supposed to be presenting for our team, but she sent in her apologies. Her dad is unwell, but I'm part of the team, so I'll go ahead and talk about our project. So basically, this is a training grant on New York University Moi Data Science for Social Determinants of Health, which is a collaboration between Moi University, New York University, and Brown University in the US. And this is a project actually that is leveraging on work that has been ongoing in Western Kenya with the AMPATH program. So there is a team led by part of the team. We also have someone from the School of Public Health. We have Joe Hogan from Brown, who is a biostatistician. We have someone from computing, that is Rumi. We also have Rajesh, who's done some great work in setting up the cardiovascular disease program in Western Kenya. And we also have our program admin who supports the project. So as I was saying, this project actually leverages on work that has been ongoing since the 1990s, which is set up the consortium that was focusing on HIV, but now has since progressed to focusing on not only HIV, but also focusing on cardiovascular disease. And within this, we have a cohort of over 150 patients who've been followed since 2002 who have HIV. And over time, we also now have a cohort of over 120,000 participants with chronic disease in Western Kenya. In addition to that, we also have a biostatistics training program that is building capacity also around biostat in HIV. So we did realize that we have an existing infrastructure within which we have not really explored in terms of utilizing this data to inform policy within our setup. And when we were thinking about this, we were thinking about the burden of disease that exists currently in our setup, that is the non-communicable diseases, as well as the communicable diseases. And I was glad to hear also someone talking in the morning about the injuries. And there's need definitely for data science to be able to combine all this and think not only about the comorbidities and the health issues that these participants have, but also think about the environment within which they live and the issues that might have on their health outcomes. Because majority of the time, we're just thinking of the health data that we have. But in addition to that, there are other data sets out there that could also inform why the outcomes you're seeing in our participants and other innovations that we can come up with. And through the cardiovascular disease program, there have been some attempts in terms of small studies focusing on specific interventions around income, trying to see how we can make use of the existing structures in terms of helping our patients invest in paying for their health insurance, supporting them through their community groups that often are formed, especially by women, and see how those could support our participants in improving their economics so that they can be able to pay for their health insurance. But those have been very small studies, but we wanted to see how are there ways we can explore other data sets that exist to see how we can improve the health outcomes of our participants. And so the other thing is that within, as I talk about the curriculum, already we will have also within our university a curriculum on health informatics, which has really helped in improving the data capture and also improving also on the data set, the open MRS, for example, that is utilized within our structure for the AMPAD data. But in addition to that, what we realized is that we are not really making use of that data. Yes, we have the very good infrastructure for data capture, but the issue of how do we utilize that data and are there ways we can use it for decision support within the existing infrastructure? So what we realized is that our health informatics are doing very well in their expertise, but we don't have the data science within that. So we felt like it was time, yes, to also revise our curriculum for health informatics. And so what we are doing is that we are now introducing the data science track within that, so that we are training both the health informatics as well as the data science. And with this, we are working with the various domains, that is people from math, people from computer science, and we are also working with also the health practitioners, and also the social science, as well as also people from public health. And we also are establishing collaborations. We are with Aga Khan, also with IBM and several others, so that we can have our students being attached to a specific existing program. So I've learned a lot also throughout this workshop, also about other sources of data that we could use and how we can leverage and work with each other to help improve on what is already existing within the continent, so that we are not reinventing the wheel. So I'm actually glad to have been part of this workshop because I've learned really a lot. And the other, as we also think about community engagement, is one of the interesting things within the College of Health Sciences is that our students in the first semester, they actually are taught together. So they already start thinking of a multidisciplinary approach. And also we make use of the problem-based learning, whereby they are engaged also with a community around them. So which also helps them to already start thinking about not the imaginary problems, but rather work with the real problems that exist. So our structure is, we have 3 aims. One of them is to build in terms of long-term training, PhDs, postdoc, and we have 2 faculty fellows who will be spending time in New York, so that when they come back, they'll be the trainers within our program. We're also working on the curriculum, which is at an advanced stage, both for MSc and PhD. And we also will be doing workshops. And in these workshops, what we are hoping is also to work with people from the various counties who are the health record officers, who are the users of our data. So I wish to stop there, and I appreciate all of you. Asante sana.
Thank you, Anne. I think one of the things that Anne sort of picked up on was this idea of capacity building. And you're going to see that come up again later when we start talking about effective communication strategy as well. So with that, Scott already knows he's up next. Okay, so our next speaker is Scott Hazelhurst. Scott leads the Multimorbidity in Africa Digital Innovation, Visualization, and Application Research Hub, Madiba, which is based out of South Africa. Scott, the floor is yours.
Yes. Although I think I can keep up the theme is that two of our partners are Kenyan, so we're keeping up with the previous talks. So I'm going to take a slightly different tack because I'm not going to describe in detail what we're doing, but rather give from our perspective some of the issues, both philosophical and concrete, of problems around community engagement for data science projects. And I'm only speaking from our perspective, so perhaps it's not generalizable to other projects. So I'll briefly set the context, describe some of the problems, and then perhaps some of the solutions. So first, the context. Why do we want to do community engagement? I think it's important to bear this in mind because it helps plan what we need to do. Most important, obviously, is our social responsibility to the participants and the broader society to empower them. But also, I think it leads to better science, and also from a selfish point of view, in the long term, provides support for doing future work that we want to do. And we need to bear all of that in mind. Many of the issues around data science projects and community engagement are not specific to data science projects. They, I think, none of them are new, but I think data science projects do create certain stresses and exacerbate certain problems. And I want to mention these. The first, I think, is that there can be multiple parties involved. So what often happens is that there's a primary research group that goes into a community, does a concrete research project, they collect data, and then sometime later, some other project, a data science project, comes along and says, please share your data with us. So there might have been community engagement in the first step, but now who's responsible for community engagement at a later stage? Is it the data science project, or is it the primary researcher group who's responsible? And in fact, it's often not just a two-party problem, but it's a multi-party problem. And it's not just a fact that there are a number of overlapping projects. It's also the fact that there are a number of projects that overlap in time. So from a data science project point of view, we're dealing with data that's been collected over a relatively long period of time. So there isn't a single point of engagement with the community. We're dealing with something that is a more complex beast. So we need to take that into account. I think a second issue is that the data science research can be more abstract and complex. So for example, if we're doing a project on hypertension and HIV, it's relatively straightforward. I'm not saying it's easy, but I think we know how to do it, to go into the community, to engage, to explain the project, why we're doing it, the benefits and the risks. And when the project is complete, to give feedback at an individual or at a group level. I think with data science projects, first of all, I think there honestly is some more, it's more complex and perhaps more abstract. And together with a lot of jargon and hype, I think that can also be a stumbling block in explaining what we're doing. Added to that is that often in data science projects, we're dealing with data that was collected in the past. So how do we do community engagement? With whom do we do it? How do we do that? Or are we going to be engaging with communities about projects that might conceivably be done in the future? And I think a second issue, and I think this really was very clear in the presentations this morning from Skylar and from Kamanthri, is I think in many cases, it's not clear what type of feedback we can give to communities that is ethical at this point in the research that we're doing. And that's a real worry and challenge for us. Yes, we want to give feedback, but it has to be done, it has to be feedback that is meaningful and ethical. So let's look at the ways forward. First thing I want to say is that we should be seeing data science projects as a partnership between the research groups and the community. So it's really at the point that data sharing happens, is there needs to be some agreement on who is responsible for community engagement, and preferably that should be done, if possible, at the point that a research project is proposed. Obviously, there are a number of practical issues that have to be borne in mind, and that's very context specific. I think the second point, and perhaps to me this is the most important, is that we need to see data science community engagement as a process. And I think that the talk we heard earlier from Stephen, that idea of culture is so important, because I think now we're no longer dealing with a specific project, a specific point in time where community engagement has to happen, but as research that is ongoing and it's part of the process. I think that means to me that the primary burden for community engagement has to fall on those people who are doing the primary research and who are engaging with the communities, because they're the ones who have access to the communities, they're the ones who have the skills. But that doesn't mean that the data science projects do not have responsibility. And I think they have very clear responsibility intellectually, logistically, and I would argue financially, to support the primary researchers with the community engagement work that they're doing. The final point is both a challenge and an opportunity, and that is that we have multiple ways of doing engagement. And I was going to talk about them, but having heard Stephen's speech earlier on, I think the best I can do is just to cite his speech and refer any questions to him. And I'd be happy to discuss all of these issues when we have our panel discussion later. Thanks, Jay.
Thank you, Scott. Okay, so our next speaker then, let's see, we have Shangui Cynthia Munyong. Shangui is the lead, has a lead role in the public understanding of big data in genomics medicine in Africa. This is an ELSI supported project, something you should also all be very interested in. I'm biased. This is a PubGem program, and it is also based out of South Africa.
Hey, James. So I'll take you now to West, Central, and Southern Africa. So the project is titled Big Public Understanding of Big Data and Genomics Medicine in Africa, PubGem Africa. And on this slide, you have the list of PIs, co-investigators, and consultants. Okay, so briefly, these are the objectives of PubGem Africa, to investigate models of public engagement and preparedness for big data use in health, to explore the roles and responsibilities of different stakeholders regarding ethical, legal, and social issues, and the different stakeholder groups of interest to us. We have the data providers, the data producers, the data users, funders, research ethics, and research ethics committees. We also plan to investigate, we will also be investigating public perceptions of big data in health and attitudes towards governance of data. And we'll be developing equity-oriented data governance frameworks for big data-driven innovation and health in Africa. Just to mention, because the examples I'll be showcasing here from our data providers who come from the sickle cell disease community, the hearing impairment community, and another community with Fragile X syndrome. So this it shows the different objectives of PubGem and the methods that we're using. So focus group discussions, interviews, online surveys, desktop analysis, and conceptual and normative analysis. So public engagement is a core component of the PubGem Africa project. And our goal is mainly to democratize science, to take science to the public and let the public inform the work that we do at every stage of the research cycle. So it's about active citizenry in science. What does the public think about genetics? big data and its use in health? What does the public think about using their personal medical data for research and also for innovation? We're using a variety of public engagement methods or approaches. We have meetings with patient support groups. We have debates, and the picture on the slide is a public engagement activity we did recently with high school learners in Cape Town. It took the form of a debate, and with high school learners actually engaging with issues around how they would like to see their data being used and what they consider to be some of the ethical, legal, and social considerations. We have community meetings, we have science cafes, there is the podcast, which we've talked about during this meeting. We have documentaries for the Fragile X community. There is one, the hearing impairment community. They also have a docudrama, and we have portents as well. These portents specifically targeting younger groups because the Sickle Cell Project is collecting data from the children and adolescents, and so we think that portents will be a much more familiar thing with them because they are very interested in cartoons and all of that. And so the method that we use will sort of depend on the stakeholder group, and so science cafes may be much more useful for like researchers, clinicians, compared to portents for children and kids. What we are learning from the public engagement activities and some of the empirical data we have is that there is interest and for deliberative and consensus-driven approach for community and public engagement. So the importance of qualitative equality, so really giving power to the data providers. So there is an interest in power sharing, and that's in making decisions around how the data is being used. There is very little resistance to data sharing as we are learning. It's more interest in how is that data going to be used. So there is therefore shared decision making. They want to be part of decisions around how data is being generated and how data is being used. Then there is also the interest in proposal sharing. So I just said that. And information feedback. So information feedback really comes in strongly in the context of epistemic justice. There is also the idea of a very inclusive approach. And I want to just draw an example from the hearing impairment project. So the idea coming from there is that while they contribute a lot of data for different projects, public engagement or community engagement activities are not very sensitive to their needs. And how do we engage this community? So the team in Ghana has a docudrama that has used sign language to sort of communicate that the project activities, goals, and why it's important, why genomics is important. And what we are also learning from them is that they love social media. And we should use social media to engage them and short videos with using sign languages. And so we are working towards developing more videos that use sign languages to explain concepts in big data and genomics. We're also learning that the model or approach will differ for different population demographics. So the younger people more interested in social media or more informal activities than compared to other groups that will like much more formal approach. So you would hear, for example, the younger people want TikTok and all as a way of engaging with concepts in big data and health. I want to talk about the challenges, but not focus on that and see them more as opportunities for learning. So the first is that there is a need for conceptual clarity because the word public or community creates as many problems as it solves. Because at the end of the day, what community you engage, if you're not very careful, then you exclude a particular segment of that population. So when you say you're doing public engagement or community engagement, how are you defining your public, how are you defining your community, and how are you ensuring that even if there is no representativeness at particular events, that the voice of a community filters through in your research. And we're also learning meaningful engagement is costly and time intensive. Even as a public engagement project, we faced just one event is costing us quite a lot in terms of time. And by the time we finalize one event, the whole team is already thinking of taking a break. So for the research projects, I don't know how you're coping. And most times the budget allocated to public and community engagement is usually not sufficient. So I imagine what it will be for research and training projects, but we need to allocate much more resources for public engagement if we really want it to be meaningful. And of course, there's the question of what is meaningful engagement. We've talked about trust as an important part, and that's why people say we do community or public engagement to gain trust. But trust is hard-won. It is easily eroded as well. So we should be careful that the way we do community engagement, that in the process of building trust, we don't instead it doesn't lead to a breakdown of trust. And how do we do that? We need to be respectful. And being respectful is not only around how you gain entry into the community or respect to culture and values. What the participants for the different studies telling us that the respect also comes in seeing that the discussions we have with them during the public engagement activities are actually reflected in our research. So are they being reflected? Does it come through in our research priorities? When we release policy briefs, do they find their voice in it? So when they can't find their voice in it, even if we had a respectful way of gaining entry and we respected the cultures and all, they still feel like it was a lack of respect. You're wasting their time. And so we need to listen more actively. We need to get into these communities and listen. And we need to see public engagement as mutual benefit. It's for us, it's for the communities, it's for humanity as a whole. So there must be that intent to ensure that it's mutually beneficial for all. And I've talked about the importance of proposal sharing and information feedback if we want to really center epistemic justice in data science. And I think that's a key thing for data science in health. So I just want to talk. So we've done a couple of community and public engagement activities. And one of the challenge I mentioned that you want to build trust, but you could take a day or two to break down that trust. And so we had a situation where we had trust with the community. And at some point, we felt that there was a breakdown of trust because the community was saying, we actually not seeing how the discussions we have is filtering through in the research that you do. And it was more around priority setting. And they felt that, yes, you are collecting data, you're setting up a registry, but the research that you're doing doesn't reflect our needs. And in this case, it was about having a registry, but also an interest in gene editing. So, and then there were other interests that they felt that it wasn't being, those questions were not being answered by the project. So we said, we want to have a patient as a partner model. But what does this really mean? So we started by saying, we want you to have a say in how your data is being collected, shared, and used. So we currently bring them to project meetings to listen to the different projects that are going on, how their data will be used, if that's how they prefer it, and also get them to contribute to research proposal development. And in one case, seeing one of the patient representatives actually becoming a co-investigator on one of the projects. They also facilitate community engagement, they support participant enrollment, and they contribute to priority setting. And in this way, we hope that they will eventually own the registry and how the data from that registry is being used to inform health and healthcare. And so finally, we are now saying, what are we learning from this? Is that we want to co-create a framework for engaging patients as partners in research. So hopefully the next time we are here, we'll tell you how this work has gone. Thank you.
Thank you very much. I think this was really, you did a really nice job of bridging so many things here. And what occurred to me with this is that you use the word listen. I mean, really listening to people and being respectful of that is a really key thing. So I hope we can come back to that. I will say that I had this whole thing sketched out down to the minute, by the way, of how long people were going to talk and everything. And all of us should know that the best battle plan that you have when you develop, when you get into the heat of the battle, you throw it out. Okay. And that's where we're at right now. And I'm okay with that. Okay. I'm okay with that. Okay. And in fact, the next speaker is one that I only found out about like 10 minutes before we came here. So this is a really good example though, but where we're gonna improvise, adapt, and overcome. So our next speaker is Catherine Juilliard. And Catherine is representing the Data Science for Health Discovery and Innovation in Africa Research Hub, DSIGN, which is based out of Cameroon. And I'm going to say, I say based out of, and as we just heard, it's based out of, but it has a broad spread as well. So Catherine, go ahead.
Thank you all for your attention today. Our research hub is called the Data Science Center for the Study of Surgery, Injury, and Equity in Africa, or DSIGN Africa. It's based at the University of Buea, but we have partners. I'm from UCLA, UC Berkeley is a partner, the African Institute of Mathematical Sciences in Cameroon is a partner, and Cape Town, University of Cape Town is also a partner. You can see as all the other hubs, complex organizational structure and multiple leaders there. And our main goals are to decrease the burden of injuries and surgical diseases and to improve access to quality surgical care in Cameroon and other similar settings in sub-Saharan Africa. What I wanted to do today is probably raise more questions than I'm going to answer. I wanted to talk about two kind of field-based experiences that highlight some challenges in community engagement or adequate community engagement in the type of research that we do. We do acute care research. We study surgical diseases. They're often time sensitive, emergent. Trauma is a great example. I'm a trauma surgeon. Often this is done in a hospital setting where it's chaotic. People are in pain. The providers are under stress, and you need time sensitive data. You need the time stamping to be very precise because the outcomes for trauma are associated with time to treatment, time to intervention, time to diagnosis. So this is a very challenging situation. In Cameroon, we have a hospital-based trauma registry that was in 4 facilities, and we just recently expanded it to 10. So it's a very large centralized database. And we currently get informed consent from all of our study subjects, either from them or from a family member or surrogate if they're not able to give consent. So this is challenging. Our research assistants, this is an image of a training we were doing. We do a ton of role playing with our research assistants because they have to be extremely emotionally aware of the situation around them and what's happening in order to do their job. And it's burdensome. In the United States, we don't get informed consent for trauma registries. It is considered quality improvement and not feasible. So it's waived. We don't get it. And we actually recently submitted a manuscript using these data and got a criticism from a reviewer because we got informed consent from our study subjects, because we were erring on the side of protecting the patient since we were rolling out this system in a new context where they don't have a framework for how to do this. But this raises an even bigger question. Most emergency surgery or acute intervention studies in the United States are exempt from informed consent. It's called EFIC. I don't know if any of you are familiar with that term, but it's the standard way that acute care research is done in the United States, and there's a whole framework on how to do that. An example is the PROPER study. This study was in North America. There were 12 sites, and it randomized patients, bleeding patients. You had to be bleeding to death, potentially, to be included in the study, to 2 transfusion protocols. Clearly, there's no time for informed consent. You have to give transfusions right away. They got a waiver. And the FDA, the Food and Drug Administration in the US, has a very regulated way of achieving this, where you have to do extensive community engagement and education for the population that could potentially be enrolled in this study. So here's my colleague, who is a trauma surgeon in Mississippi at a fair, talking to the community about, if you end up in our hospital, you're going to be in this study. So just know about it. In San Francisco, I was at San Francisco. We were also a study site, and we had the same thing. We had billboards and radio shows and social media about this. So everyone knew, including us, if you end up in the trauma bay, you're going to get randomized. But in the US also, there are issues with this. As part of the regulation, the FDA mandates that not only do you have to do the engagement, but you have to do a survey to study your engagement and how it was received. And this group, this is published in JAMA, they went into the database of the FDA and took the 41 studies that have been done under the EFIC protocol and aggregated the survey data. And they found some concerning things, one of which, Black Americans were underrepresented in the survey population and overrepresented in the study population, which makes you wonder, how adequate is this process? And are we reaching the communities that we need to reach, which was brought up by my Kenyan colleague just now. So how do we do this in a place like Cameroon? If we want to push research forward in trauma or other surgical diseases, we're going to have to come up with a solution to this. And I'm not sure how to do it. Again, I'm not here to give answers. I'm here to ask some questions of all of you. You know, can we do it in Cameroon? Can we do it in other settings? How would they differ? What would community engagement look like? And I really look for, I've really appreciated the previous talk because it gave some great ideas around that. And what's considered adequate? Here's another challenge we encountered. The trauma patients in Cameroon, when they leave the hospital, do not routinely come back for care. And often if they do, it's delayed and they have complications that are very morbid or even lethal. So it doesn't make sense in a setting like Cameroon to bring everyone back, which we do in the United States at 2 weeks, because 80 to 90% of those people don't need to come back. It's a waste of resources. So we developed a 7-question survey that we use. We call people at 2 weeks after they've been discharged. We do the survey, and we have an independent physician exam that's blinded to the survey result to validate that. So we're in the process of doing this study. Our research assistants were like, even though 95% of our patients are giving us cell phone numbers, no one's answering the phone, and we got informed consent. We talked to them, we made friends, they're not answering the phone. Why? And we went into the data and looked at it, and we met with the research assistants and the study supervisor. A lot of it was basic stuff that was easy to fix, the wrong number, data entry error, all that we were able to fix relatively quickly. But the main problem was lack of trust. And it came down to 2 top reasons, one of which is if the research assistant was a female and calling a male patient and the wife picked up the phone, they were like, you know what they thought. They were not ready to answer a 7-question survey at that point. So that was the problem. And the other one was people thought that the hospital was coming after them for payment. They had a hard time separating the research team from the hospital administration. So we developed an intervention. This was kind of mid-study on patient education. We revised our flyer and the way we distributed it. We had a protocol with a checklist on exactly what elements of education needed to happen with the patient. We did more training with our research assistants on how to do it. We gave a small incentive. We gave them each a package of detergent because the research assistants, I think, appropriately said this is a pain for the patients to listen to, so we should give them a little bit of a reward. And then we had a documentation system to show that the education had been done appropriately. and again, this is not what our study was designed to do. So these are just observational data. They're not scientific, but we did see an increase in our triage pairs, survey and physician exam completed pre and post this intervention, which is great. But now we're in 10 hospitals, not 4. So how do you scale the human touch? Because that's really the secret sauce that made this more effective. And now we're going to face that challenge. So again, raising more questions than I'm answering, but hopefully you guys will have some good ideas. Thank you so much for your attention. The last speaker.
Well, thank you, Catherine, for pinch hitting on this. And I think it really did ask a lot of interesting questions. So it is not the last speaker. We actually have one more. Remember, we wanted to round out. It is the last of our DSI awardees. But our last speaker we thought was really important to have is somebody from the communication side of it. We've been talking about how to communicate. And actually, one of the things you said, Catherine, was the importance of being able to dynamically change things. The best laid plans are there, but then it's like, uh-oh, it's not working. What do we do? You have to have that ability to evolve over time. So our last speaker is Robert Ingalls. Robert serves as the director of Jive Media Africa and will offer his perspectives as a communications and research engagement practitioner. That's a mouthful. Robert.
Thanks very much, and really wonderful to see each of these examples and to hear your insights. It's been really fascinating to watch. So this is really, let me start here. What's in that box? Just putting it to you. What's in the box? And what was if you notice your feeling in response to that box, what could be in that box? Just anyone. Okay, maybe this data. What could be in there? A suitcase inside the box. Okay. Anything? Money? Okay. Snakes. Okay. In the interest of time, we'll leave it there because what often happens is people obviously bring their own selves to that response to what's in a locked up box. And if we were to think about it as money or something really valuable or powerful, and we think about our data or our communication or our research in that box, then obviously it can't get out until it gets unlocked. But on the other hand, if it's something that we perceive as dangerous or potentially harmful, then we're going to have this very suspicious kind of response to that thing. And I think both of those things happen to data, to research, to things that basically we don't understand and we can't easily unpack for ourselves. So I just mentioned that how does one feel? Because as a group, we're all talking data science and we're all in this one space and we're starting to get a common language for ourselves. But everyone who's outside of this space is not even using some of these words that we're using. And then perhaps the last little reflection is what keeps that box locked? What are the characteristics of what locks up our data and of our research? And some of these have started to be unpicked a little bit, but just a little brainstorm here. It's about the jargon, it's about the language we use, it's about the paywalls, it's about who gets access to data, it's all of those things, but all of those are stopping that latent potential getting out into the world, and of course contributing to perhaps mistrust and those kind of reflections around data. So really quickly, just to sort of say, this is research as it has been done, and often how it's still traditionally proposed is kind of you get this idea, you do some research, you disseminate that research. And for you and for those in the health sciences, they've always had this extra difficult component of informed consent. So the minute it's research with human subjects, you have to do this whole informed consent process. But what that's actually done is made you as a community, and I'm thinking of the health researchers, quite advanced in terms of the engagement component. Because if you look at a whole lot of other disciplines who don't have to do this kind of things, like if you're doing, looking at a fungus on a tree, you don't have to do any of this kind of engagement that you actually have learned quite a lot about. But we're in a paradigm shift because that form of creating knowledge isn't good enough anymore. We're trying to solve problems in the world, and so this is a badly drawn cycle, but it's this idea of how do we unlock the potential of the research process to do a whole lot more engagement? And I think the idea here is that engagement needs to be happening at every point of the cycle, which was said by someone, and I wrote it down in one of these talks, but engagement is a process, it's not an event. And so this idea that we identify opportunities, do research, then translate research, then share research, potentially harvest outcomes or try and learn as much as possible from that process. And that creates new opportunities and the sense of expanding opportunities. And then at each point in that process, there's opportunities and outcomes. And I suppose in a world in which we're trying to look for more and more of the measures of what are the impacts of research, it's no longer that we're just looking for, was it published in a high impact journal? We're looking for what changes in the world. And those changes don't happen because the research was published and then used. Those changes happen because if you're engaging with people all the time, then that change starts to happen in the world, as many people have spoken about. But this whole engagement process often is quite complex, and it's often assumed that you could just sort of, or it's often expected of researchers that they would just do some engagement. And I've just sketched out a little bit of a process where we talk, for instance, like we need to engage policymakers. Well, how do you engage a policymaker? Well, if you're the researcher there on the left and you want to engage a policymaker on the right, probably the process you have to go through involves doing that research, creating those products that research traditionally values, then taking a step and framing that product for a whole lot of audiences in particular ways and making it very much accessible, undoing some of those locks, then thinking about how to disseminate that, and then thinking about, in quite a complex world, how to actually get to the right people and finally getting to your audience. So there's this expectation that it should be done, but really there's a whole lot of steps to that process. And that's perhaps about content pipelines into the media, for instance, but that's not every kind of engagement. It's just one kind of engagement. I'm on 5 minutes already. So just to pull out a couple of ideas that are really about how one perhaps takes on board some key principles for doing engagement. And I saw all of this in the speeches that came before. The first one's about dialogue. We don't like being told what to do or how things are going to impact us. We really like to be involved in those. And I think even further than dialogue, and in this space, it's possibly even more likely than in a lot of other scientific disciplines, is really participation. And I think we saw quite a lot of examples of how when you get people to participate, then you get even bigger outcomes. You get a whole host of people who are actually empowered to do a whole lot of things in the world that they might not have otherwise done. The second one is obviously stories. You hear these ideas bandied around, but the very short version is that stories are the way in which humans ingest new information. We ingest information when it is packaged as a story. So I won't go more into that, but that's not just a kind of like a gimmicky marketing thing you say or something. That's the evidence suggests that story structure helps people absorb new and unfamiliar information. And then this final one is this visuals. And I think we spoke a lot about the visualization and added a sixth V to the 5 Vs. It's ultimately so much easier to engage with content and a large amount of content in a visual format. So we have to develop skills for doing that. I've just thrown that one in again here because I think at every point in the process, there's opportunities to get involved in that little journey. So it doesn't have to be do the research and hope that somebody else is going to finally get it to your audience. There has to be both of those processes going on. So I think that's probably where I'll leave it. I'll leave that thought up for a few moments, but thanks very much for the opportunity to listen to you all.
Well, thank you, Robert. So it looks to me like we've got maybe 3 hours left now for questions and answers. I would actually ask of all the panelists if they could please jump up on the stage here, find a seat. And by the way, that's you all, that's not me. So I get to stand over. There's only 7 chairs and there were 7 participants. That's by design. I put the chairs there. Okay. And think by the way, I have this whole list of I woke up early this morning and thought about this a lot. I have this whole list of questions I was going to ask. And I will say 2 things about it. One is I couldn't be happier with how this went. I thought this was really good. And I applaud the panel for really listening to one another and building off of ideas. And then second, I open it up to you. So if you have questions, please raise your hand, identify who you are, and try to be brief because we don't have 3 hours. We have 15 minutes. And then we have closing remarks. And then I'm just going to ask one of the panelists to sort of jump up and go from there. Questions? Please. We have one in the front.
Lashla Abimiku, Institute of Human Virology, Nigeria. Really enjoyed the discussions, and I love your questions because those are exactly, Catherine, the questions that I have. And also to Cynthia, just some of the novel ideas that you have. I know I need to be brief, right? So the question is, I saw him looking at me. So the question I have is for our research hub, we're actually using program data. So these are individuals that are treated through HIV or COVID. During COVID cases, the data lies with the national program, right? And huge amounts of data didn't have the opportunities to consent. So my question then is, who is your community, and how do you really involve the policymakers? You pointed out the fact that you eventually get there, hopefully for better care for the citizens, but how do you engage, and who is really your community in this case? Thank you.
I could start. Okay. So for programmatic data, it becomes a bit complicated saying who is your community, but we must give a human face to data. Even if it's programmatic data, it came from somewhere. And so if we start thinking of humanizing data and thinking of what are the different sources of that data that we have, then it gives us a clear picture of what the community is. And when I think of HIV, the advantage is that it has much more organized communities. I don't know what for your setting is, because you have communities of persons living with HIV/AIDS. You have national AIDS programs that are very organized. And so if we consider these as communities and begin to design programs to engage these different ones, that it's much more suitable for them. So for the national AIDS communities, for the national AIDS programs, it will be very different, because you certainly want to take another approach, like Stephen said, about ensuring that you train those who are sitting on the desk of National AIDS Program about the importance of data. And for persons living with HIV/AIDS, if they are organized communities, to begin to say that this is how the data that we collect from this particular group could be used to inform public health much more broadly.
Can I just add, I think another responsibility is, why do you want to do community engagement? Because there are many reasons why you're doing community engagement. Is it because you have a responsibility to those participants? Is it in order to improve your science and the impact of the science? Is it to build trust for the future? And I think that helps you build up a strategy for the best way of doing it. Yes, no, I think so. But you can't always do all of them because you don't have the resources. So I think that's the challenge, that's the difficulty.
From Center for Bioethics and Research. My question is to Scott. The other time you were talking about data science projects needing data. Do they need to go back to the subject, the participant? So it makes me to be more curious. This idea about broad consent. Okay, at the inception of taking data, the primary researcher, maybe the primary researcher could adopt the principle of broad consent, saying that, okay, this data, I want to use it for this project, but in case we might also be using it for some other things. So instead of data science projects going back to the primary participant in the study, at least that consent will have covered it.
Yes, so I think that's true. So I would say that there is, so we're going beyond consent. So let's say we do have broad consent. The participants, when they were recruited, they knew what they were signing up for. Well, we hope they knew what maybe do we know that they knew what they were signing up for, but they signed. It's been through an ethics committee. They've come back to us. They've interrogated us. We've been to the lawyers. We are compliant. So I think what Jay was hoping to achieve is it's not just meeting those minimal requirements, but what is the best practice for going on? And so I would say that there needs to be some partnership in this. And as I said, I think it's for those people doing the primary research. So it's people like Stephen Tolman over there, who is responsible for an HDSS to do that. But we as the data scientists can't run away from that responsibility, which has to be both, I think, intellectual and material.
Okay, thank you. From the design project, and my question goes to the UZEMA project. You talked about having this discussion with the women, the newborn mothers, and I was just curious. I wanted to find out, like, what exactly was your discussion centered around about? What exactly were you looking for? Is it about the quality of life of these women, or were you looking for information to inform your interventions? Like, I was just curious to know.
Thank you. So the consultations were largely around several aspects of the UZEMA hub. So we discussed with them first our key research questions. So for instance, we've prioritized looking at stillbirth. We've prioritized looking at low birth weight, and preterm birth, gestational diabetes are some of our priorities. And we asked them the question, do these research questions seem to be important? Is this the kind of thing? We also talked to them about just the concept of data science, and the fact that they have previously been involved in studies. Now we are going to pull the studies from the individual data sets, from the HDSS, and from clinics, so that we can answer more questions. So they had given concept for sharing, but do they think this kind of work where different data sets are being pulled, do they have any concerns about that approach? And then we also talked to them when we found some models. This is what we are thinking we could find. Do you think this is useful? And to whom should we communicate this kind of? So we really took them throughout our study design, our priorities and all that, to just see what they would think about what we are prioritizing. And they did raise some of the issues they thought we should look at deeper, in greater sense within their context, and how best we can address those needs. Yeah, thank you.
Yeah, thank you all for very interesting and informative talks. To Dr. Stephen Chacha from Tanzania and also Kenya, I just wanted to find out how the border riders were used to do the regional mapping for data use. At what level, or what, because I know mapping can be, it requires some statistical knowledge and something like that, but somehow we use them. So what type of tools, were you able to train them to do that mapping for data use? Thank you.
Thanks. I think there's a very growing community of youth mappers. So I believe maybe some of us are engaging or using them in one or the other. So it's a big community right now. Initially, we used to engage with university students, thinking that, they have the basic knowledge, because literally what is actually needed to be able to do community mapping is a smartphone. And by the penetration of smartphones right now in our communities, with young people, you have a lot of young people who actually have smartphones. And again, the approach that we took is very much about upskilling. It's like really offering skills, new skills and knowledge to these young people, so that they could actually be able to offer services, beyond this project to other organizations that are in need of such kind of services. So it's also more or less creating job opportunities, for these young people. So I said, border borders has not been all of them were border borders, but, some of them were, young people who are border drivers who also opted to be part of the program. So that, that's the advantage that we saw, but we've been following up on them. And, one of them who happened to be a border driver, as you said, as he's been moving around, whenever he found, interesting, developments that he feels they might have missed during the community mapping, is actually taking his own initiative to update the maps to reflect on those kind of development. As I said, it's more or less self kind of interest that is coming from them, and really also for them wanting to continue utilizing the technology, continue building up their skills. And that's what really brings in that self-sustainability element that I think is also very important in our community engagement work.
Yep. Hi, my name is Beirut Shabistari. I am from the NIH. I have a general question that applies for all of you. You talked about opportunity and challenges. Did you run into the barriers such as data transfer, data access, or even common problem of recruiting qualified data scientists?
Yes.
Clear and succinct.
I'm going to ask, how did you deal with it?
I think it's a long discussion, but.
So if I'm,
it is a problem. No, it is a problem I deal myself with. It is hard to find a qualified data scientist. I was wondering that, especially in here, how you.
So maybe if I'm to share a bit of experience there. So when we embarked on the data collaborative for local impact programs that I was leading on in Tanzania, the whole idea was to, roll out, data projects within the country. And as we were actually moving into implementing the projects, then we realized the limited, data science, capacity that was actually there. Which really led into compromising by actually recruiting, staff members and train them from ground up on some basic data science kind of skills, using, partnerships in order to skill them to be able to deliver the work that we want to, to deliver. We even tried a number of times to recruit local data scientists, and actually we failed. That actually what I should read to the partnership with the University of Dar es Salaam way back in 2016 to develop a curriculum and a program for Master of Science in Data Science program in Tanzania. And we had to bring in partnership with the University of Virginia, Data Science School, so as to actually be able to complement on the delivery of the program so that we can actually be able to groom and train our own local data scientists in the country. So as we speak right now, we are on the 6th cohort for the program. So we have a batch of graduates coming up. And I want to allude to a problem that was presented earlier on. So one of the missions is an organization, and this I'm referring to Tanzania Data Lab that we actually had. Sponsoring. So as part of supporting the initiative, we even ended up sponsoring students pursuing Master of Science and Data Science as part of our own recruitment strategy to retain talent, within the organization. But we managed to a certain extent, but I lost all of the best data scientists to the private sector. The demand is huge out there, and the competition is stiff in terms of actually payment, and everything else. So these are the real challenges that we have here, are facing. But again, on the other side, we counted it as an achievement, meaning we managed to produce world-class data scientists that are actually attracting the interest of the private sector. So for us, it's an achievement, but it's really a challenge that we're facing. And this has to be a continuous investment. And we have to accept, train people who may not necessarily stay with us forever. So that's the reality that we have to accept as well.
Over here.
Is this working?
Yes, hi, I'm Jessica Haber from Boston and part of the MUDSRI Research Hub. So my question follows on what Scott raised earlier about the quality of consent. And I recently completed a study with one of my mentees on the quality of consent during labor and delivery. So one of these time-sensitive moments. And in the interest of time, I'll just tell you the understanding of consent was horrible. Like even the concept of what research is and who we were. And so I'm just wondering if any of you up there or elsewhere in the LCs are looking at quality of consent as it relates to data science.
Maybe I can just say something about that, having sat in IRB. And I think there's one sociologist in our program who has been very interested in looking at the quality of consenting. And I think she's even published around it. And I must say, I think majority of the time, what we've just done is just giving the form, but majority of it is never really informed. And I think that has formed a lot of bases in terms of training even the research assistant around what is just the informed consent and being a process rather than just a form. And I must say it takes a lot of time for it to be really informed. So I think it's still a challenge I think we are all still struggling with. Yeah.
Maybe just to add that, so for Uzima, because quite an amount of our data is already there, we are not looking at that. But for some of our studies where we are dealing especially with families of children with intellectual disabilities and other forms of disabilities, we actually give informed consent, then we give a test. I don't know if a test is the right one, but there is the UBAC and it's been adapted for our setting. So we actually check if they've understood what they're doing, what signing up to. And there's a PhD student who is looking at that kind of data and ways to improve consenting processes. Thank you.
Yeah, so maybe to end it all, I would say it's a really important question. And it actually was a part of the title of this whole section of moving beyond the informed consent. But the premise is that the informed consent was, shall we say, legitimate on the front end to begin with. And that understanding element is a really important piece. I mean, I just updated my iPhone and, you just scroll down and click. I mean, unfortunately, that's what some research participants are doing as well. And so we have a responsibility to make sure that's not the case. So again, I want to say thank you to the entire panel and a big round of applause for them. All right. Finished.
Jay, thank you so much. So, yeah. So while we've reached the end of our meeting, all the sessions from all the days, it seems like the data science community in front of you is just getting started. So, yeah. So so thank you to all the speakers and all the sessions. The presentations have been excellent, and to the audience for staying engaged. It was just really perfect. Could we have all the early career scientists perhaps stand up? I know there's other folks standing up. We'd just like to also announce the best presenter. Some of them gone already. Awesome. So the best presentation was from Faith Kabata. Would you like to come up if you're here? And the runners are Huria Tigali and Muavi Rogers. Where's Rogers? Is he gone already? I don't see his bright shirt here, so he's gone already. So congratulations to you, and the coordinating center will get your certificates and your prizes to you. Thank you. Awesome. Thank you. So for our closing remarks, we'll call on Dr. Jill Hemskirk from the National Institute of Biomedical Imaging and Bioengineering, that also has a great role to play in the DSI Africa initiative. So over to Jill for closing remarks. Thank you. Thanks, Michelle. Good afternoon, everybody. I'm very delighted to be here, not just here, but for this entire meeting. I am from the NIH Engineering Institute. You heard the long name from Michelle, but we think of ourselves simply as the Engineering Institute, NIBIB. And our director, Bruce Tromberg, unfortunately couldn't come to the meeting, but that gave me the opportunity to attend, and I just could not be more thrilled about that. I wanted to share with you today, though, a little bit of his vision from the time when we were initially discussing at NIH the idea of having a program like this. As you know, in the US, we have lots and lots of data. It tends to be housed in individual institutions, much of it inaccessible. And that data that is accessible is often not interoperable, so the data can't talk to each other. And this is a great frustration for NIBIB. We spend a lot of our time, a lot of our efforts in data science looking backward and trying to redesign old legacy data sets and data systems into a more modern iteration. But it is a fundamental principle of engineering that the very best products come when the design begins with the end in mind. And so what excited Bruce about the concept of having a program like DSI Africa was that he could envision a coalition of scientists in Africa working together to design a fresh start, begin with the end in mind, and design a modern data system that was that produced data that was accessible, interoperable, harmonized, and could thereby derive much more fully the value that's inherent in any data set. And so what is so exciting about this program to us is that you are embarking on an effort that will produce a modern system that will be a model for the rest of the world to learn from, and also set a standard for the rest of the world to really move forward into the future. And so I want to thank all of you for that leadership, for your sharing your expertise, and for your commitment to this program. It's extremely important to us. And as I close, I just want to wish you all safe travels home. And thank you very much for what I think has been an incredibly valuable and important meeting. Thank you very much.
Can we give a round of applause for all of the coordinating center staff, please? Yeah, Francis, get over here. I think we greatly appreciate not only all the work that you all do to put on these meetings, but the fact that you're so nice to us when we have questions and always there to be helpful. And this couldn't happen without all of you. So thank you.
Finally, picture of process.